Hi, I'm Adam Crespi, and welcome to Unity 4.3 Essential Training. In this course, we'll look at building a small game in Unity 4.3. I'll start by showing you how to bring in assets and textures, and organize your project and scene hierarchy. Then I'll show you how to place models in, and use the new 2D Sprite Editor. We'll see how to create lights in the game, and bring the game to life through color and shadow. We'll create particles, and add interactivity and animation to our game. We'll be covering all of these features, plus plenty of other tools and techniques. Now let's get started with Unity 4.3 Essential Training. Unity 4.3 Essential Training is a beginning course in the Unity game engine. If you've never touched Unity, I'll walk you through all you need to know to make a small game. Additionally, I've crafted the assets in Autodesk Maya and Adobe Photoshop and Illustrator. If you'd like to explore the assets in Maya, I've provided the working files. We'll be exporting out of Maya, but I've done most of the exporting already, putting out files as FBX files. If you'd like to work in Autodesk 3ds Max, you can work in there as well and export out your own FBXs to test. I've crafted textures in Adobe Photoshop and Illustrator and provided the flattened images for you to use. Again, if you'd like to use those programs to enhance or improve upon a texture or craft your own, a working knowledge of those is helpful. So let's get started crafting our game in Unity 4.3. If you are a premium member of lynda.com, you have access to the exercise files used throughout this title. In the exercise files, each movie comes with its own separate Unity project. Unity projects are self-contained and hold all of the assets, scripts, and animations used in that game. Remember, at the start of each movie, choose File and Open Project if you're starting a new project, or continue with your existing project. When you open a project, you can browse to that movie's project and then open the scene from there. Remember also in Unity that sometimes scenes don't open automatically in projects. We can always go into the Scenes folder in the Assets folder and double-click on that movie's scene to get going. The assets for the game I created in Autodesk Maya are in a Maya project in Chapter 3. Remember in Maya to set the project first by choosing File and Set Project. There's a working Maya project called Modernista Assets, with the default Maya directories containing the models and textures for this game. From the native Maya files, I've exported out the FBX files we're going to need from this project. If you're a monthly member or annual member of lynda.com, you don't have access to the exercise files, but you can follow along from scratch with your own assets. Now let's get started with Unity 4.3 Essential Training. Game design is a large and complex topic, and a multifaceted one, ranging from psychology to interior design to scripting and implementation. Understanding at least the basic workflow of making a game is important. Before we dive headlong into our game editor, we need to see where it sits in the pipeline and what we'll be doing in the different software packages we'll use. We play games to immerse ourselves in an alternate reality. This is something that every game designer and anybody associated with the making of a game needs to keep at the forefront of their mind. And it's especially important when we're deep in the technical workings of implementing a part of that game. It's very rare to walk down the street and encounter a dragon, for example. But we play games because we'd like to have exactly that experience. We're in a street, and suddenly there's a dragon, and we have to decide what to do. We crave that luxury of often artificial fear, or the ability to do something that we cannot do readily in our daily lives without fear of the consequences. In that same vein, not many of us are elite special forces soldiers tasked with repelling the invading alien army, but we play games for precisely that purpose. Even simulation games or serious games exist to immerse the player in a version of a reality. There are training sims, for example, for planes. It's very difficult to take a novice flyer and put him or her in a cockpit of a multi-million-dollar plane. But in a training sim, we can get a lot of experience in flying that plane and understanding how the controls behave and seeing the consequences of our actions. We as game designers have to keep this in our mind, that things need to be seamlessly, obviously right, and not break the illusion of that immersion in that reality. Unity is a versatile game authoring tool. We'll use it in many facets to make our game. It's a game editor, where we stitch together multiple levels and other components to make a full-fledged game. It's also a level editor, allowing us to bring in and place assets and add interactivity, making the actual place that the player will play. It's a game engine, and this is actually the software that drives the game the player is playing. That when they're seeing the graphics up on screen, Unity is pushing that out and driving it in whatever platform they're using. And finally, it's an authoring tool. Coupled with MonoDevelop, which comes with it, we have powerful scripting available, allowing us not only to add interactivity, but craft whatever it is we need to make our game, well, fun to play. The typical game design workflow will vary from studio to studio. Every different company or batch of designers has their own particular workflow that they like, that they feel gives them the best art and the best implementation. We'll create assets in a 3D modeling package. For example, we'll use Autodesk Maya, Autodesk 3ds Max, Pixelogic ZBrush, Autodesk Mudbox, or any number of other applications for the actual production of our assets. These packages have full-fledged modeling and unwrapping features, where we're not only modeling the polygons as we want them, but telling the texture how to flow around that object, and adding in as much detail as we feel we need to see in our game. We'll also see our 2D drawing programs come into play, such as Adobe Photoshop and Illustrator. These will allow us to craft textures, a fundamental and important part of gaming. These textures add richness and realism, as we're constrained in how much we can push around in real time in polygons. And so seeing what we think is the full detail of our world provided by the texture is of utmost importance. We'll implement our assets then in Unity. We'll import, place, and add materials to our models that we've brought in. We'll also add animation, interactivity, and scripts to these assets, transforming it from simply a navigable environment to a place we can interact with and affect our world. Unity supports a number of scripting languages. We can work in C#, JavaScript, and Boo, which is a Python variant. This gives us a lot of flexibility. Rather than using a proprietary code, we're using a code that is common knowledge. There are a tremendous amount of resources available for these scripting languages, and this affords us the flexibility not only in how we implement our objects in Unity, but to custom craft whatever tools we feel we need to make this game more fun to play. With this understanding of our process, we can jump in and start to make our game and see where we really sit in our world. Unity works in a project structure. If you've worked in 3ds Max or Maya, for example, this is a familiar workflow. We have a master folder in which we'll have subfolders that we'll bring our assets, scripts, and animations into. It allows us to keep everything for our game contained and to move it around if we need or transfer it between computers. I'll start out by launching Unity and then create a new project to work in. In the Unity Project Wizard, we have options for opening a project and browsing to a directory if we need. We can also create a new project, and this allows us to custom configure what we'd like to have in our game. In the Create New Project tab, we can set a project location, bring in packages of ready-made components we'll use, and set up defaults for our game. I'll start out by bringing in a couple of packages. These are things that we use commonly, and rather than recreate the wheel, we have ready-made pieces. We can modify them if we need, but most often we're going to simply put them in. I'll add in a character controller, and then scroll down and bring in my scripts. We can always bring in more packages, but these will increase the size of our project. A package for us in Unity is simply a part of a project that has been exported out to be imported into another project. I'll leave the setup defaults as 3D. One of the big new features in Unity 4.3 is the 2D engine, allowing us to bring in sprites or sprite sheets, flat drawings with alpha channels, attach 2D physics to them, and make flat or 2D games. This provides a much easier way to make 2D games than simply putting things on planes in a 3D space and trying to view it straight on. We'll leave those defaults as 3D. And finally, we'll browse to a new directory to make our project. I'll click on the Browse button and go make a new folder for my Unity project. Here in the exercise files for Chapter 2, I'm going to make a new folder. Unity wants to create a new project in a blank folder so it doesn't accidentally overwrite any previous work. I'll click on New Folder and name this folder for my project. Once I've selected a new folder, the Select Folder button is available. If you try to make a new project in a folder that has objects in it, That'll be grayed out, letting you know that you need to make a new folder for your project. Once I've selected my project location and chosen any packages I'd like to bring in, as well as my setup defaults, I'll click on the Create button. Unity will take a minute, depending on how many packages are selected, create the project, and then open up the Unity interface. Unity is opened, and there's exactly nothing going on. There's no defaults in Unity for our project. It's exactly blank. There's no daylight, no clouds, no sky. It gives us an enormous amount of artistic flexibility to be able to custom craft the look of our game. We need to bear in mind, though, that there is exactly nothing to start, so if we want something, we'll have to add it in. There's also no scene yet. A scene is within a Unity project and can be a level or a piece of a level. It's where the actual gameplay will take place. It allows us to keep within that project different parts of our games organized and open or transition between as we need. I'll click on File, and we can see that I can save a scene and save a project, and they're different pieces. Saving a scene saves that particular scene and anything that's been placed in it, such as assets or scripts. Saving a project saves a particular view of a scene and anything in the project we've done, such as organization in our assets folder. It's important to understand the difference in them, that scenes travel within projects, and saving a project does not automatically save a scene. Now that we've got our project made, we'll jump in and start moving things around, bringing pieces into our game, and starting to populate our exactly blank space. Once we've made our project, we can get to work making our game in Unity. The main windows we're going to use are the Hierarchy, the Scene, Game, Inspector, and Project. There'll be others that pop up along the way, such as Animation or Animators for Mecanim. The Scene View navigation is much like Autodesk Maya. Holding Alt and clicking and dragging the left mouse button tumbles the view. Alt and the mouse wheel pans, and Alt and the right mouse dollies in and out. Alternately, scrolling the mouse wheel in and out also dollies. We can switch this view back and forth from a perspective to a drawn isometric, and also from an elevation perspective to a drawn orthographic view. Clicking on the viewport label Perspective changes over to an ISO. Clicking on ISO changes back to a perspective. Selecting any one of the axes in the scene takes that view over to a drawn perspective elevation. We're seeing things in a right view, but the perspective lines recede into the distance. Clicking on the right viewport label switches that view over to a drawn, flat orthographic view. Clicking on right again changes back to the perspective, and Alt and the left mouse tumbles again, and we're back to our perspective view. It's very easy to navigate around and position things exactly where we need. Unity's default units are in meters, and so when we bring things in, we need to make sure we're working in real-world scale in meters. At the moment, our scene has, well, exactly nothing in it. I'll bring an object in and see how it looks in the Hierarchy and the Inspector. In my project window, I can see I'm in the Assets folder which Unity created for me, and in those assets are a folder called Standard Assets. In Standard Assets, I have my character controllers and scripts. These are the packages I had chosen when I created that project. Clicking on the Character Controllers folder shows me the controllers and their sources that are available. There's a standard first-person controller, which looks like a capsule, and a third-person, which starts out as a constructor. I'll take the first-person controller and drag it into the scene. By doing this, I can place it arbitrarily wherever I'd like. And with that object selected, the inspector shows the different properties and components of that first-person controller. I'll press Delete to delete it, and then I'll drag the first-person controller into the Hierarchy. Dragging an object into the Hierarchy creates that object in the scene at exactly the place it was created originally. For the first-person controller, this is not as important, as we may want to position that first-person controller at a spawn point in our game. However, when we bring in objects from Maya, for example, they'll have their own coordinates in Maya, which will transfer over here to Unity. So if we want things placed exactly as we had placed them in Maya, for example, we can drag them straight from the assets into the Hierarchy view, and they'll place correctly in the scene. Within this Hierarchy, we can see that the first-person controller has an arrow next to it. Twirling open that arrow shows the two components that are part of the first-person controller. The graphics. Selecting it shows the properties of that particular capsule. Pressing F to focus in zooms in that view. This is actually the object of that first-person controller, what actually collides with a collider or a mesh. The main camera, then, is how that first-person controller sees. And we can see in the inspector that this has not only the properties of a camera, such as the rendering path, clipping planes, and so on, but has some additional components that have been added. There's a GUI layer, or graphical user interface, which will overlay on that main camera. There's a mouse look script that's part of that controller, and this controls how this object looks around to follow the mouse in the game. Selecting the first-person controller again shows other scripts that have been attached. There's our mouse look and also our character motor. This controls, for example, things like movement, jumping, moving platforms, and sliding. And there's even a first-person controller input script. Selecting any object then in the hierarchy or in the game shows it in the inspector and allows us to edit its properties. Selecting any object down here in the project view, such as our first person, again shows those properties. The relationship between the hierarchy and the project window is shown by the color of the text in the hierarchy. The blue text for first-person controller, graphics, and main camera denotes that it is a prefab. A prefab in Unity is a very important concept. What prefabs let us do is define an object once and instance it in the scene. All the instances then reference the original, so changing one changes them all. The text in blue shows that that prefab connection to the first-person controller in the assets is active and working correctly. If this text is red, it means that prefab link has been broken. The main camera here is a standalone. This is our main camera we're seeing our scene with. We can't actually see it because we're in it, but it's not a prefab. It's not related to anything in our assets, for example. Now that I've brought in a first-person controller in my blank scene, I can save that scene, choosing File and Save Scene. Unity scenes have a .unity extension. This is different from a Unity project, which is really just a directory structure. This scene wants to save by default in the Assets folder. We may end up, depending on the complexity of our game, making a Scenes folder. For now, though, I'll save this scene in my Assets folder and get started on bringing things into my game. Once we've created our project and a scene in that project, we can start making some simple pieces and moving, rotating, and scaling them around to construct our game. I've opened up my 0204 start scene by double-clicking on the icon in the Assets folder, and there's the first-person controller I put in, as well as the main camera that's created as part of that scene. Now I'll make some simple objects and look at how to move, rotate, and scale. I'll begin by choosing Game Object, Create Other, and Plane. We can see here there's a collection of simple primitives, lights, some game-specific things like GUI textures, and also audio and terrain objects. A lot of times we can get by with a simple primitive in our game. Often a lot of our colliders, or simple things that restrict a player, for example, can be made of an in-game primitive and don't have to be imported over from Maya, for example. We'll do our lighting here in-game, and we'll also put on our graphical user interface objects. I'll make a plane, and there's my plane here in the scene view, actually somewhat above that first-person controller. For moving, I'll press W or click on the Move tool up in the top left in the UI. I can move this object around on 1, 2, or 3 axes, depending on where I click on that Move tool. I'll start out by clicking and dragging down on the green Y-axis, making sure that this plane sits below the first-person controller so we don't fall through the endless space when we play our game. Alternately, clicking and dragging on one of the planes, such as XZ here, allows us to slide an object around on that plane. Finally, clicking and dragging in the middle can slide this object around in 3D if we'd like. I'll duplicate an object by pressing Ctrl-D. Now there are 2 planes perfectly coincident. As a side note, for games we need to make sure that things are not fighting on the Z-axis. What this means, in more technical terms, is that we need to avoid coplanar objects, where the faces or polygons are perfectly overlapping, and they fight in Z space as seen from the camera, each one jockeying to be on top and producing a flashing or winking effect in our game. I'll rotate this second plane by pressing E for rotation, and holding Ctrl to snap the rotation while I click and drag on that red X rotation ring. I've snapped this plane up 90 degrees, and I'll press W to move it. pulling it up first on the Z-axis and then back on the green Y. If you notice, my axes are set to the local axis here. I can change this by clicking on the local or global button on the top left of the user interface. The local axis of this object shows that it's been rotated 90 degrees. The world Y is up in Unity, but this object has its Y off to the side because I rotated it. Now I'll snap these planes together. Pressing V as in Victor and clicking without dragging to position that move tool where I'd like it, snapping to any one of the vertices in the scene. Then I'll snap these planes together and I have a light-tight connection. It's important to snap when you can. We should make as much effort as possible to have things be solved exactly, so that when the graphics card is drawing the objects in their light, it doesn't have to think about a hairline crack between objects. That definitively these two, well, boring squares are exactly put together and will not leak light through that corner. To scale objects, press R for scale. We can either scale, as we can also move, by clicking and dragging here in the view, over in the inspector in the transform section. I'll put the Z for this plane at 0.5, entering that in and pressing enter, and now this plane is half the size of the original. I'll press W to move once more. Hold V for snap, and make sure that I click in the scene view, pressing F to focus in, and positioning that snap on the bottom left of that plane. Then I'll snap it down onto the other, hold Shift to pick both, and press F to focus once more. Zooming in, we can see now I have a shorter wall, again with that light-tight connection. Objects in Unity are drawn single-sided. If we spin around the back of these objects, we can see that they are invisible, and under the floor doesn't show anything at all. We need to make sure that when we model and bring things in, they're modeled correctly with the correct facing normals. Making sure everything is single-sided ensures that we can keep our draw calls low. If you'd like to switch around your view and be able to see different ways of shading, drop down under Textured and choose Wireframe, or choose Textured Wire. This is the equivalent in Maya of smooth plus edged faces, and it lets us see not only the wire of an object, but how it's going to shade in that game. Lastly, we can configure our view to show the RGB, alpha, where is transparent or not, and overdraw. At the moment, this isn't too big of a deal. It's drawn in a dull red because there's just one object there. When I start to stack more objects in overdraw, we'll see them get lighter and lighter, reflecting how many things the game engine is looking through before we cull them down. If we're dealing in textures, we can see our MIP maps or different texture resolutions. But at the moment, with no textures applied, this isn't going to make much of a difference. I'll go back to RGB, and there's my objects in my scene. I can move, rotate, and scale as I need. The final note on scaling. If we have a prefab, meaning that its title is shown here in blue, scaling that prefab creates a new object and will drastically increase the number of draw calls we're making. Scaling a game object that's created in Unity, such as these planes, doesn't affect the draw calls as drastically. So keep in mind where you use scale. Also, from a design perspective, make sure that instead of simply scaling things to fit, you think about the sizes of objects you're going to need and craft them correctly. It's much better for the immersion in game for things to look like they're made to the right size, instead of small objects simply blown up to fill space. To finish, I'll save the scene, choosing File and Save Scene. This will save everything I've done in the scene, those three carefully positioned planes, and any materials that are applied. The view of the scene, however, from the main camera is saved with the project. So keep in mind that when you open up a scene, unless you've saved that project, you may see a slightly different view of the scene, and you can always navigate around to frame in what you'd like. For most games, our assets will be made in another package besides Unity. We'll use programs such as Autodesk Maya, Adobe Photoshop, and Pixologic ZBrush, for example, making the different pieces we need and placing them here in our game. It's very easy for a game to have several hundred assets, even if it's a small game on one level, and large games can easily have a million assets, ranging from textures to models to separate animations to scripts. Therefore, being organized is super important. I can't stress that one enough. That even if you think you're making just a quick working game, creating some folders in the Assets folder and organizing how you're bringing in things will save you a lot of time in rummaging around. I'll make some folders here in my Assets folder, and these will be for things like imported meshes, textures, prefabs I'm going to make, scripts, and animations. So when I start to bring in all my different assets, I know right where they should go and which ones I should choose from to make my game and which ones I should leave alone. I'll start out by right-clicking in the Assets folder and choosing Create Folder. This is just like creating a folder in a directory, but we can do it from inside Unity. I'll name this folder Meshes. This will be for my imported mesh files from Maya. I'll make another new folder for textures, one for animations, and also one for scripts. I've made all of my folders, and I'm almost ready to import in objects. Right now, I have one scene, my 0301 start scene, and I've stripped out the planes because I'm going to bring in my objects from Maya. I'm going to leave the first-person controller in this scene, but I'm going to put this scene in its own Scenes folder. Now, this game we're going to make is one scene as the entire game level, but it's a good idea to have scenes in a scene folder. That way, if you have multiple scenes, such as a load scene, for example, or an end scene, or maybe a scene that's viewable only when you go through a doorway, you can keep them organized as well. I'll make one more new folder called Scenes, and while I'm at it, one for materials. Now I've got my folder structure ready. I'll take this 0301 start scene and drop it into the Scenes folder. We can simply drag things around as we need, and the folder icon changes. We can also view these folders at different sizes by sliding the size slider down at the bottom. Depending on how long our names are and how big the icons are we'd like to see, we can either go bigger or smaller, all the way down to a list if we'd like. I'm ready to start bringing in pieces. I've established a clear organizational structure so that later, when I start to have, well, assets all over the place, I can find them easily and I don't end up duplicating work or using more than one of one object. In Unity, we can take in all kinds of different file types as assets, ranging from 3D files such as Maya binaries and FBXs to TIFFs and PSDs from Photoshop. For the game we're going to make, I've created assets in Autodesk Maya and drawn textures in Adobe Photoshop and Illustrator. Before we get to bringing in our assets, let's look at the game we're going to make, a small game called Modernista. I've opened up the Modernista summary document from the Modernista design folder in the exercise files. The premise is straightforward. You start out as the player in a gleaming modernist compound formed from 3 joined structures. They've been remodeled into a modern art gallery by a wealthy reclusive collector. At some point, the crowds have thinned out and you're alone in the quiet gallery, but you keep discovering new rooms and can't quite find your way out. And it feels like the art and the walls are moving around you. The base mechanic is fairly straightforward. We need to navigate from room to room and building to building, opening doors by proximity or touch plate. Walls will reconfigure at random out of sight of the player, animating over one frame, and art will also reposition in different rooms. The winning condition involves escaping, getting out the front door and onto the grass. The building will vanish by sinking under the ground behind the player's back, so when you turn around, there'll be nothing there. We'll use a standard first-person controller that reacts to physics materials and colliders. And we'll set the scene in a warm afternoon sunlight with the sun streaming through the south and western windows. We'll have cool light coming in the other windows. And in windowless sections of the galleries, or places where we need a little bit of light, we'll have evenly spaced, recessed, and surface-mounted can fixtures casting soft pools of light on the floor. There's 3 basic art types we'll see. Static paintings, abstract or modernist paintings on canvas varying in size. Static sculptures, freestanding and pedestal-mounted sculptures using mixed media. This is an opportunity, actually, even though they're static sculptures, to add in some physics and colliders so you can knock one over. Finally, we'll see kinetic art. Using the Unity 2D engine, we're going to have what looks like paintings on the wall, which are really planar elements, that will move, collide, and fall when activated by the player's proximity, as if you bumped into a painting and it fell apart. We'll get started in Autodesk Maya, setting the project, and then opening up the scene and exporting out assets. This way we can look at the asset pipeline and how to get things out efficiently into Unity. Here in Maya, I've set my project to the Modernista Assets project, and then open up the scene Modernista Building Assets. Typically what I'll do is have a separate Maya project and a separate Unity project. This way, in my Maya project, I have room for experimentation. I can work on scenes, save out pieces, mix between, and keep my textures organized in the source images folder. If you're working in 3ds Max, do the same. Keep a working 3ds Max project for producing assets, and then export very selectively what you want to bring over to the game when you're ready. I've got the scene open, and we can see here in the Viewport 2.0 display that there's 3 buildings joined by bridges. There's trellises over the bridges and varying materials. As we spin around, we can see that the flat roof buildings have some patios, or at least balconies, railings around them, and a collection of glass walls and some brick walls. We're going to surround the compound largely in water, as if it sits in a lake, with a small bit of grass to escape onto. We'll begin by taking out this whole structure. There's a few walls inside we need to hide before we select and export. I'll press 4 to go to a wireframe. Click on that wall with the hexes in the background and press F to focus in. This is one of the walls that will slide up, allowing the viewer to see through but not get to another area. I'll pick this one, hold Shift on the one it's next to, and finally hold Shift and click on the third wall. These are varying types of modern screens, we'll call them, and these will be some of our walls that pop in. I'll press Ctrl H to hide them, and then F to focus on my scene. I'll also select the stairs that are off to the side and hide them by pressing Ctrl H. Now I'm ready to export my assets. The big deal is to be very selective. I've taken all the pieces I don't want to bring across and hidden them. So when I select, I'm grabbing only what I want to come across in my FBX. If we take a Maya scene and import it straight into Unity, Unity will actually open Maya behind the scenes, export out an FBX, and bring it in for us. So it's better to choose very carefully what we'd like to export out of 3ds Max or Maya, and bring it in very selectively when we're ready. This way, we also have control over, in that FBX file, what we're bringing in. I'll select all 3 of the buildings and choose File and Export Selection. In the Export Selection dialog, I've set my export type out as FBX, and I'm going to export this straight into my Meshes folder in my Unity project. I need to configure my FBX file a little bit, so I get all the things that I want to have come across in that file correctly. First, in the Geometry rollout, make sure that Smoothing Groups is checked. This way, hard and soft edges in Maya, or smoothing groups in 3ds Max, transfer correctly. Preserving what should be flat surfaces is flat, round is round, and not having a mushy difference that winks at you between. In animation, I've turned off animation. This way, in case I accidentally animated something that should be staying still, it won't come across with animation. I've also turned off cameras and lights, making sure that even if I have a working camera or light in the scene, it won't come across. Remember, FBX can transfer cameras, lights, animation, models, UVs, rigs, and skin weights. And now in Unity 4.3, blend shapes will come across as well. So we need to be very selective about what we do and do not want to come in. Finally, down in Units, I've unchecked Automatic and set the unit type to meters. Unity's units are meters. So if we export this out as meters, we can bring it in with a scale of 1. Alternately, if you're working in Maya's native units of centimeters, Unity is configured to accept centimeters coming in and scale those objects up correctly to real size. We need to make sure we're working in real-world scale, so things like our physics work properly. I'll browse over to the Meshes folder in my Unity project and export out this gallery as an FBX. Here in the Meshes folder, I'm ready to export. I'll name this file and click the Export Selection button when I'm done. Maya exported out this FBX file. When I go back over to Unity, we'll see Unity pause and automatically import that file in. Here in the Meshes folder, that FBX has shown up automatically. Anything we drop in the Assets folder in Unity is automatically imported, even if it's in a subdirectory. It also created a folder in here called Materials, and I'll need to make sure I do some organization on the materials once I get ready. This FBX, when I select it, actually has multiple components to it: a model, a rig, and animations section. And the FBX, as I can see by the twirl down arrow here, actually has a number of different objects in it. What happens is that each object retains its own identity, so we can select it uniquely, and they're all part of this main FBX object. It's not yet in the scene, but only in the project window because I haven't brought it into my game yet. It's very reasonable in a game to have several dozen FBXs coming in for different things. Characters may be in FBX, different scene pieces or different objects that we need to animate, be able to destroy, or collide with. We want to keep organized and make sure that we are selecting only what we want to have come across, choosing only the properties we want to have come over, and putting those pieces in, thinking always about how we're going to save draw calls by instancing prefabs wherever possible. In Unity, once we've imported in our FBX files, we need to do some configuring before we make them part of prefabs. I'll select my 0303 Gallery FBX. These come in with a scale factor set for Maya's centimeters, a scale of 0.01. This is an automatic compensation for leaving the linear units in Maya set to centimeters. And this way, things will scale up 100 times so that they're the right size in the scene. Because we've exported out our meshes in meters, we can set this scale factor to 1 and we'll have the right size. I'll also check Generate Lightmap UVs. What this does in a mesh is generate a second set of UV coordinates that are automatically flattened. And we can use this when we're baking the lighting or pre-calculating the lighting for our game. We have the option in here to import blend shapes and also to generate colliders. Blend shapes then allow us to morph between different models or different states of a model from Maya and are particularly useful for facial animation, for example. There's no blend shapes with these models, so it doesn't really matter if I leave it off or on. However, generating colliders is important. I'm going to make the choice here, because this is such a complex model, to not generate colliders automatically. Checking the Generate Colliders checkbox puts a mesh collider on, using every polygon as a collider. And many of the objects in this gallery are much more efficiently, generated with a box collider, where we have the mesh looking correct, but the overall volume of what you can pass through or not is defined by a box or a cylinder or a capsule, for example. I'll scroll down and click Apply, and then repeat this with the other 3 meshes I brought in. I've exported out each of the 3 walls, hex, stagger, and waves, that we'll use as blocking walls that spring up when the player contacts a painting. With each of them set to a scale of 1 and Lightmap UVs on, I'm ready to bring in my textures. I'll go into the Textures folder in the Assets folder first to make sure I import in the right place. Here in Textures, I have 2 ways of importing in the textures I'm going to use. You can import in single assets by right-clicking and choosing Import New Asset. Alternately, you can copy and paste files into this directory, simply using a file explorer and taking a bunch of pieces. I'll import in 1 texture asset and then bring in a whole bunch more by simply copying and pasting. In the Import New Asset dialog, I've browsed into the Modernista Assets folder in Chapter 3. This is my working Maya project I'm simply pulling pieces from. I'll go into Source Images, and this is where I put the textures I'm going to use. There's 2 subdirectories here, Art and Building, that contain the respective textures for each section. I'll go into the Building Textures, and there we can see the different building textures, bricks, normals, waves, and so on. I'll pick Brick C. What I've done here in the naming, and this is an important point in terms of organization, is to put a tag at the end of each name. This way, I know that Bricks C, for example, is the color map for a brick. Screen CS denotes color and specularity. And actually, that specular does double duty as a cutout, so we get a perforated metal screen. There's N for normal, and NH for normal and height, where I've tucked a height map in the alpha channel of that normal for parallax mapping. So the brick really stands out from the wall, even if we're tangent to it in the view. I've named all of my textures this way, so that in looking through a directory, I have a very clear idea of which texture goes in what part of a material. I'll click Import, and those bricks will import in, and I'll be able to deal with them in my inspector. The bricks have imported in, and I can see in the inspector that they came in as a texture. Their wrap mode is set to repeat, and the filter mode, or how do they blur close or in distance, is set to bilinear. I've also got options available for different kinds of compression and different platforms if I need. Finally, in the lower right of the UI, there's a preview window where I can see its maximum size, how it's compressed, and how big it is, 0.7 of a megabyte. I'll bring in the rest of my textures this way, taking in all of them at once by copying and pasting into the textures folder and allowing Unity to batch import all of those pieces. Then I'll configure them for different platforms and different sizes and get ready to start authoring my game. One of the greatest strengths of Unity is the ability to author once and export to multiple platforms. We can easily make a game and port it to iOS or Android very quickly. One of the big things we need to be concerned with is when we're bringing in assets, how big are they? How are they down-resing for each platform and compressing? I'll go into the Textures folder, and I've brought in my two folders, Art and Building, for this game. I'll go into the Art folder and look at the configuration in the inspector for one of the art assets. I'll pick Bars 1979 CS. And this tells me the title of the art is Bars 1979, and the CS denotes it's got color and specular. I've tucked a grayscale in the alpha channel for specular roll-off, describing how shiny this is, so I have the ability in the material to make that paint look a little more metallic if I need. In the inspector, the texture type is set to texture. We have some options in here, setting it, for example, as a normal map if we brought in a normal. We can also bring in GUI elements or sprites and reflections. We can bring in cookies and light maps, and even advanced where we have control over many different properties in our texture. I'm going to leave the alpha alone and not take it from a grayscale, because I've already described the alpha in Photoshop as I want. The filter mode for me describes how that filters when we get up close or far away if the texture is blurring, and I'll leave it at bilinear until I see it in the game. Down below are my defaults for different platforms, and I can see here I've got defaults available for all manner of different places. I have defaults available for iPhone, Android, standalone, web, BlackBerry, Flash, Windows Store apps, and even Windows Phone 8. Depending on where you'd like to develop for, you can set overrides for each. For example, working for an iPhone, I can check Override for iPhone and down-res the max size of this texture. It was authored very large and brought in at a default of 1024 by 1024. If I'm working for an iPhone, knowing I'll be working on a smaller screen, I might choose to down-res this texture so it maxes out at 512. I can also choose compression or uncompressed if I need, and play with the compression quality. What this lets me do is really optimize each of my assets prior to authoring. So when I say, let's put out a build for the iPhone, the textures are already set and will down-res appropriately. It's important to know what platform you're authoring for, but it's very easy if you find out later, gee, we need to author incidentally for Android, to put that into the textures and have them down-res correctly. Instead of simply mashing arbitrarily, we can be very specific about how pieces look and preserve the immersion in our game. I'll turn off the override for iPhone, as we're going to make a standalone or web build at the moment. What I will do, though, is make sure my normals are reading correctly. I'll pick the Bars 1979N and revert what I had done on the other one, as I don't need to change anything on the texture. This normal map didn't quite come in right, or rather it came in right, but Unity is not regarding it correctly. What I'll do for a normal map is drop down under Texture Type and choose Normal Map, and turn off Create from Grayscale. I'll open up the inspector a little bit, and we can see there's the option, if we need, to create a normal from a grayscale, which means we can paint a grayscale bump, tell it to be a normal map, and have Unity handle the conversion. I've made these in a number of different places, starting out as a grayscale in Photoshop and running through XNormal or Nulled, for example. I'll use a number of different tools to create my normal maps and test them out before, so I want to make sure that Unity leaves them alone. I'm going to leave the wrap mode and filter mode alone for the moment, and I'll check my defaults for standalone and web here, and looks pretty good at 1024. I'll leave these alone, as I can see the size when compressed is 0.7 of a meg. This should let me get really close, enough to observe the stitching and oil on the canvas when I get up close in my game. If I need later to down-res this, it's very easy to come back to these assets and simply change how big it is. But for now, I'll leave it alone and click Apply. I'll go through the rest of my normal maps and make sure they're checked correctly. It's important to make sure that your normals are fixed, although if you put one in without fixing it, Unity will give you a note and say, wait a minute, would you like to fix these because they're not coming in correctly? However, as part of this import process, before placing anything into the game, make sure your assets are as organized and interpreted correctly as possible. This will save you time and headache later, leaving your troubleshooting to more fun things, like finding out why code isn't working. I'll fix up these assets, make sure they're all ready to start to bring into a game, and then get on with placing things in my scene. I'm ready to begin construction of my game in Unity. I've imported in my assets and tagged my normal maps as normal maps. I've set the size of all my FBXs to 1 and turned on Generate Light Map UVs. I'm ready to start bringing assets into this scene, and I'll begin with the gallery itself. I'll pick the 0401 Gallery FBX. And there's two ways to bring this in. The first is to drag from the assets into the scene, placing this arbitrarily. The second is to drag it into the hierarchy, and this places it in the exact place it was in Maya. I'll choose the second option, as I want this placed where I had created it. It makes a prefab, and we can tell it's a prefab because of the blue writing here in that hierarchy. We can see in here all the different objects are also prefabs within that gallery mesh. I'm also going to do a little bit of cleanup here in my meshes folder. In the meshes, there's a materials folder, and these are the materials as they came across assigned in Maya. I'll double click on them, and there's all the different materials that were in my scene, plus Lambert 1, the default material in Maya, and a few extras here and there. Picking any one of these materials shows that it's not really formed yet. It's a flat diffuse shader, simply having an RGB color and a slot for a texture. Later we'll go through and actually put in specular properties and put in the normal maps and the materials. For now though, the materials are assigned in the correct places from Maya. What I'm going to do is to put these in my materials folder so my meshes folder stays clean. I'll pick the top one, scroll down, and hold Shift and pick the bottom, and then drag them over into the hierarchy here under Assets, choosing the Materials folder and letting go. Now the Materials folder in Meshes is blank and I can delete it by hitting Delete. My Meshes folder is clean, containing just meshes. The meshes are still assigned their materials, but the materials are in my Materials folder. I may end up making other materials later, so I'd rather have my materials separated from the Meshes folder. If it seems like I'm being a bit of a neat freak about the organization, it's worth it. Like I've said previously, it's very easy for a game to have thousands of objects and materials and assets very quickly, and we need to be able to find them. And more importantly, multiple team members need to be able to find all of the different pieces and not have to go hunting around. My mesh is imported, and now in the inspector, when I select that object in the hierarchy, I can see it has a transform, where it is, and an animator controller that was created automatically. I can remove that component if I need, because this is a non-animating mesh. I don't really want the building to get up and walk around. But an animator controller is placed automatically, so if we need to bring this into Mechanim to create an animation or behavior tree, we can. What I'll do is to select it, and then click in my scene window and press F. And there's my gallery. I've brought my pieces in. And I can see here, especially by turning off textured plus wire and choosing just textured, that the objects are in, but their materials are not showing yet. I do need to tune these up, but my scene is created and is the right size. A quick way to verify if this is imported correctly is by the player controller. I'll select it and drag it over into the scene. Pressing F to focus shows us that, well, unfortunately this poor guy has his head through the roof. That's a minor deal. I'll pull him down, but more importantly, the default player controller in Unity is 2 meters high. So as a rough gauge for size, this is a very tall person, about 6'7", does it look right in the scene? And the answer is yes. I'll compare it visually to the doors, and it looks pretty good. As another gauge, these railings are modeled in Maya at 3 feet high. So for the controller to be probably a little tall for the railings, looks about right. Always check when you're bringing things in if they came across correctly. Make sure that the scale works and that they're placing in where you want. Now that I've got this in here, I can configure my player controller and start to get my environment in shape. Then I can start to work on materials and lights. But getting that first scene in and verifying the size and placement is really crucial. Placing a player controller is highly important. The simple act of placing the controller is easy, but the consideration of where that player controller is placed is crucial to gameplay because it determines the spawn point of that player. We will be populating the gallery at some point, but right now these buildings are simply open, so I'm going to hazard a guess at least where this player should be placed. I've put my controller simply in the scene and verified that the height is working right of all the objects around. For now though, I need to place that controller, so I'll select the player controller in my 0402 scene and go into the top view by clicking on the Y-axis. Then I'll switch over to an isometric view and change over from textured to wireframe. I'll zoom out and I can see my buildings in plan view from the top down. I'm going to start out the player over here in the corner of the farthest gallery. This way they have to go through one building, into the second, and the third, and maybe even back to the second, to finally get out. So I've looked at the player controller as an opportunity to give them some good gameplay. With that player controller placed, I'm ready to test out the game. Pressing play, however, shows me an odd result. I fall right through the floor because I need to get some colliders in. To put quick colliders on, I'll select this mesh and go back into my perspective view so I can see a little bit clearer what I'm doing. I'll tumble around with Alt on the mouse wheel and switch over to textured so it shows up a little better. Now remember, I haven't got all the materials on, that a lot of the objects are simply showing white and may not render correctly at all when displayed. But at least they're there, and I verified they came in correctly. I'll select the podium by clicking once on the FBX and then again on that particular object. I can see it's got its materials and a mesh renderer, but no colliders. I'll choose Component, Physics, and Box Collider for this object. A box collider is the simplest kind of collider, and we can see the box collider component has been added in the inspector for Podium 3. What this does is to create a box around the bounding box of that object. We can see this by the center and the size in the box collider properties. Right now it doesn't have a physic material on it, which means it's not going to react like metal or ice or anything particular at the moment. It's also not a trigger, meaning that if I bump into it, it won't trigger an animation somewhere else. However, at least in this building, I won't fall through the floor. I've scrolled up, rolled up the gallery, and selected that first-person controller. I'll at least verify that I can run around decently and see what it looks like from the inside. I'll press play, and this will take me straight to the game. Here in my game, it's exactly not lit, and so it looks rather odd. What I can see here is that some of the scene is white, or maybe it's gray, and because it's not lit, it's all blending together. Because it's also missing its texture in a lot of places, it's defaulting to a white or gray color. And so it looks like the walls, ceiling, and floor have sort of merged, and there's an occasional column in there. The blue I'm seeing outside is the default sky color, not a sky box, but just blue background. I'll make sure it's working though by using my WAS and D keys to navigate around. Going forward in the space, turning around to look back, pressing S to move backwards, and A and D for side to side. It looks like my space came in nicely. I'll jump right through the glass, burst through the other glass, and check out the bridge by falling right through it. I've placed in my player controller at least, and considered very carefully where it belongs so that I've maximized the length of gameplay in here. Placing the actual controller is easy, but the consideration of where it goes is a big deal. Depending on how we place the player and where we're facing, we're setting the stage for what's going to happen. Are we starting out with a close view or looking far off through the scene and foretelling what's coming? It's up to you where to place this player, and we can always tweak it later. It's just a simple matter of grabbing that first-person controller in the scene view. But placing in that first-person controller and getting the first collider on to test it out early and test often is crucial. In Unity, as we've seen, we have a lot of control over the quality for different platforms, that we can dictate in here how this should look on different devices such as iOS or Android or similar. To change some of the player settings, we'll choose Edit, Project Settings, and Player. In here, we can set things like the default resolution and does it go full screen or not, and also start to play with things like cursors and splash images. To start out, we can put in a company name and set up the product name if we need. We can also choose a default cursor. It's just another texture we'd bring in, and we can even set a hotspot for that cursor that's off-center if we'd like. So if we need a crosshair that has longer sides on the right and bottom, we can put that in. What I'll do is open up the Resolution and Presentation section. We can open up any of the sections simply by clicking on the header. I'll turn off Default as Full Screen and put in a size of 1280 by 720. I'm going to force this game to play in a 16 by 9 aspect, so that when it's viewed on high-definition TVs, it looks good. I'll scroll down and look in the supported aspect ratios as well. In here, we can dictate which aspect ratios we support in a standalone, and we can also change this for different OSs. I'll choose for my standalone to turn off 4:3, 5:4, and 16:10. I'll also turn off others. So essentially, I'm forcing this game to play in a 16 by 9. Part of building a game world that's believable in its immersion is to have a sky. We can only build so much, and after a while we need to actually be able to look up and see something besides the default Unity blue. Now, if you're making a game that's set all in caves or only inside and can avoid a sky, that's fine. But chances are, even if we're dealing in the insides of buildings like we will be in these galleries, we're going to see outside and see a sky at some point. What we'll use then is a skybox, and the idea is essentially we have 6 images that form a box that are infinitely far away from the camera. They don't really exist as an object, but are visible depending on where we look, and they change. Like, well, on Earth, when we look around, the sky is different from every viewpoint. The skybox does the same. You may also find sky domes being used, and even lapping domes to get moving clouds. For now, though, we'll use a simple skybox to get one established. Later, we'll get terrain in and see how our skybox looks, and if we need to fine-tune it, and also balance out the colors. To start, though, I'll import in a skybox package. I'll go into the Assets folder, and I have my other folders for animations, meshes, and so on. And in Standard Assets are things that I brought in as packages, my character controllers and my scripts. The skyboxes will import into here initially, although we can move them around. What I'll do is right-click in the Standard Assets folder and choose Import Package and Skyboxes. With skyboxes, we get a bunch of different pieces. There's the skyboxes themselves, which are materials that are made to have 6 textures, and then there's the 6 textures for each one. Now, we don't need to bring all of these skyboxes in, unless we'd like to experiment around with them. However, we know we're dealing in daylight, so we can eliminate things like the eerie background in Dawn to Dusk, and probably the moonshine as well in Starry Night. To do this, to be selective in importing a package then, we can check None, and then find just the ones we want. I'll bring in Sunny 3. It's a good, bright blue sunny day with clouds in the sky and a sun. In addition to the material Sunny 3 skybox, I'll scroll down, and there's Sunny 3, and I'll check under Standard Assets the textures. This checks all the textures that go with that skybox. We can be very selective then with a package. Although we may make a package that has lots of different pieces that we'll use regularly, we can bring in just the ones we want, and thereby keep our project size down. I'll click Import, and Unity will bring in those textures and that skybox. It made a folder automatically in the Standard Assets folder called Skyboxes. And in here, in Skyboxes, is the Sunny 3 skybox material and a folder called Textures. Now, we can move these around as needed or keep them separate, depending on how we want to categorize what we're doing. Right now, I've got all the default or standard Unity pieces still in Standard Assets, and anything I'm doing or bringing in uniquely for this game is going in my other folders. Let's take a look at the Sunny 3 skybox material over in the inspector. It's a Render Effects skybox shader. And what that means is it's made to look like a sky. It's not a standard material with 6 textures. It is a special material on its own. Essentially, it is, we can call it either unlit or self-illuminated, depending on how you want to judge it. But all it does is display these images, and they don't shade, because it would be kind of weird to see a sky shade and have a corner. Each texture slot has the texture for that particular place. Front has the front texture and so on, and they're set to tile at 1 by 1. Again, we don't want to see the clouds in our sky repeat. Now, what I'll do is tint this a little bit. We have a tint color here, and by clicking on that color swatch, we can bring up the color picker. It's up to you how you'd like to work in this. We can either work by RGB or click on the slider choice icon and change over to HSV. Personally, I prefer to work in hue, saturation, and value. I'm going to look actually at value and saturation first, and then come back to hue. When we start to tint then, we can slide around hue, and then bring up saturation. And as we bring in this tint, we'll see our sky change. If the sky value is bright, that sky gets brighter, and we can see in that preview. As we bring up saturation, we get more and more of that tint color coming in. What I'll do is leave saturation fairly low, but bring the hue a little more towards purple. It's going to balance out some of the blue-green in the sky. I'll bring value down a touch, and then I'll click and drag in that preview to see how it looks. There's the sun and some of the clouds. It's working nicely, and I'm ready to get my sky implemented. So keep in mind, even with the defaults, we can always tint them or alter them. If you'd like to make your own, you can paint the 6 images that wrap around the skybox and stitch them together. We can do this in a program such as Adobe Photoshop, or even stitch together photos and have a custom sky, even from a certain locale if we'd like to get that detailed. I'll implement my skybox, choosing Edit and Render Settings. Here in the Render Settings, at the moment there's no skybox material. We can see in the skybox material slot it says None. I'll click on this Choice button next to the None, and in my Select Material dialog, I've got Assets and Scene, so I can actually choose from a scene if I need. In Assets, though, there's my Sunny 3 skybox, and I'll click to select it. The sky around changes, and I can see I've got that bright blue sky going. It actually flows completely around, well, everything, because I haven't put in any terrain yet, but I have my sunny skybox in my scene. Now I'm going to add some fog in to complement the sky. We use fog for a couple of reasons in a game. The obvious one is there's a fog in the distance, but really it's that our environment is technically a vacuum. There is absolutely nothing in there until we put it in. So what we'll do a lot of times with fog is use it really as a tint in distance to add atmospheric perspective, a little bit of desaturation and blue tint, just so things get a little murkier as they're far away. Not that there's a thick fog in the scene, but just we don't want everything to read with the same clarity. For fog then, I'll check fog here in the render settings and eyedropper the sky color. Then I'll click on that fog color and just pull out the saturation. Instead of being a bright blue fog, it's going to be, well, a pale gray with a little bit of blue. We can always adjust the linear fog end as well if we're getting too much blue in there. I'll close this color picker and hit play to see how it looks. I'm still inside my building, which is exactly unlit and hence kind of gray. I'll run right through the doors and take a look out. Looking over the railing, I can see my sky. And everywhere I look, that sky seems to move and change. And it appears to be infinitely out there. It's working nicely and I can see that tint. I can also just barely see, especially in the far-off parts of the building, a little bit of that blue fog coming in. I may need to edit that linear fog end at some point, but I'll reserve that fine-tuning until I get the terrain or other far-off objects in place. That linear fog end is 300 meters out, which may be too much at the moment, but it's adding a little bit of, well, blue shift and atmospheric perspective in my rendering. It looks good so far. I'm still able to fall right off the world, but the sky is in, and I've got a color tint that really adds a richness to the scene. I'll press play again to stop playing, and I'm back in my scene editor. And I'm ready to fine-tune my character controller and probably start getting some material and lights in, because the gray is getting to be a little bit much. Part of crafting a game and really promoting that immersion in the game environment is thinking about how that player moves around and how they react and interact with their world. We know we're going to do things like triggers that open doors, for example, and move walls around. But we also need to think about the player controller itself. How big is it? What are the movement options available? And how does it move around? Is it fast? Is it slow? Is it a creep? What are we really after here? I'll select the first-person controller in the hierarchy and look at its properties in the inspector. Remember, this first-person controller is instanced from the assets, so changes made here will reflect back on the original. And I can tell it's an instance because that text is in blue in the hierarchy. In the inspector then, that first-person controller comes with controls for looking around and moving and so forth and jumping and sliding, and we can change these as we need. The first thing I'll look at is the height. This height of 2 is 2 meters, and that's 6'7", which is Darth Vader tall. It's a very, very tall person, so tall that this person or this controller will brush the tops of doorways in a lot of standard doors. If we're dealing in an 8-foot door, it looks okay, but this really tall person will look odd next to a 3-foot railing, which the railings in this gallery are. So we want to change the height of our player controller. I'll put this height at, well, let's try 1.6 meters, and this will reduce that size a bit. I'll click in the scene and press F to focus in, and there's that player Terrain in a game is its own special animal to make. The reason for this is that there's, well, a lot of it. That quite possibly, even in a small game like this, we can deal in a square kilometer or two of Earth. It's very reasonable in a game, depending on the size and expansiveness of the world, as well as how fast the player can move, that we'll deal in several square miles of terrain. If we're dealing in a game such as a train simulator, for example, it's quite possible we need hundreds of miles of terrain. However, depending on how fast you go, you can adjust the level of detail you need, and also depending on how high you are. If you're playing a plane sim game, for example, you may be dealing in pretty much flat terrain with just a few large mountains, and we don't need nearly the detail that our slow walking game in the gallery does. We'll start out by creating some terrain here in Unity. It's a native Unity object, and it subdivides as we brush in features like mountains. It's different from a modeled object we bring in from Maya. So we're going to make it here and form it around the buildings to add a backdrop against that sky. I'll choose Game Object, Create Other, and Terrain, and make a terrain object. I'll press F to focus, and here it is in my scene view. My buildings are the small gray cluster on the left side of my terrain, and it really gives a good idea of the scale of this terrain. It starts out at a kilometer square, and we can always upsize it if we need. This will work pretty nicely. I'll make some low rolling hills around this gallery cluster and depress the middle of the terrain to form a lake bed. Later I'll put in water, and the terrain will bound the view all the way around. It's perfectly natural to not see through a hill. Now this may sound odd to say, but if we have hills, it's okay that they are blocking the view of whatever is beyond them. It's a reasonable way to end the scene. And so this is a great way to kind of bound this entire world. I've got the terrain selected, and I'll pull it over on the X and Z axes, roughly centering it around my gallery. I'll focus in again by pressing F. And it's a little difficult to see exactly where that gallery is. What I'll do is to turn off the effects. What we're seeing here, and why everything is gray, is because of that fog we added in. The fog distance was 300 meters, and so with a kilometer square of terrain, we're seeing quite a good bit of fog, essentially obscuring things. Up on the top of the scene view, there's the effects button, and we can either drop it down and turn off effects selectively, or just toggle them all off. And now we're back to our gray, game-colored world, and ready to manipulate the terrain a little more clearly. I'll also turn off the grid. We can just see that grid when we orbit around. And I'll drop down under Gizmos and uncheck Show Grid for now. Now I'll switch over to Textured plus Wire, and I can really see that terrain. That little dark cluster is my gallery, and there's the default terrain subdivision. It starts out actually fairly coarse, and as we brush in with the terrain we can see over here in the inspector under Script, we'll get more subdivision very iteratively and on the fly. For now, though, I've got terrain in place, and I'm ready to start sculpting my mountains. And I'll work with broad strokes first, then add detail, color, and finally trees and grasses. Once you've created a terrain object and put it in the right place, you can start to brush in major land features. We need to do one more bit of moving around first, and here's why. When we select this terrain object, we have the option to brush in our landforms. For example, this first tool here is the Raise and Lower Terrain tool. What this lets us do is brush in hills or push them down. But we can't take the terrain and brush it below its original level. Even if we move this terrain to a different Y height, we still can't push it flatter. So what I'll do is move the gallery up a little bit and let the lowest level of the terrain actually be the lake bed around. Then I'll sculpt up all the hills and flat areas around the galleries. This way I'll get around that can't brush below zero limitation. I'll pick my gallery object here in the hierarchy, and there's its Y position at 0. I'll put the Y for the gallery up at, well, let's say 4, and it jumps up a little bit. Here's my first-person controller, and I'll need to move that up as well. Because I know I moved up 4, I'll click and drag on that first-person Y and simply pull it up higher to about 5 or so. I'll press play and just see how this looks. Now remember, we had turned off the sky and the environment and the fog in the scene, but in the game here I can still see my sky outside. And it looks like we do still land on the floor in the game, so the moves worked and we're ready to brush in the terrain. I'll select the terrain object, and the first thing I'll do is start to brush in some hills around, which is actually forming the lake bed, but again, we can only go up from the original terrain base. In the terrain script then, we've got brushes we can choose from, and brush sizes and opacity. What this lets us do is say, are we affecting it a lot or just a little bit? We can see that I've put the brush size up to 100, and that blue dot is actually my brush. I'll zoom in on my gallery by selecting it, pressing F to focus, and then reselecting that terrain, and then back out a little bit and start to brush in the lake. As I start to brush this around, I can see that those hills raise up very quickly. I'll press Ctrl Z and pull them up just a little bit by pulling back the opacity on that brush. As I start to brush in hills, I can see that that subdivision is taking place, and it's difficult to see in a textured wire view. I'll change back from textured wire to textured and brush in the first low hills. This is the start of that lake bed, and I'll zoom in on the gallery and make sure it's not submerged. It looks good. I've got a little bit of a hill going on around, enough so that when I put in water, this gallery should sit in water nicely. What we can do for something like this, because we haven't made water yet, is to put a plane in. I'll choose Game Object, Create Other, and Plane. I'll take this plane and scale it by pressing R, and simply scale it out. This object starts out with a height of 5, and so I'll pull it down to where my water should be, just under the surface of those floors, and this will give me a measure. I'll make sure that the podiums are submerged just a bit, and that's the water level. It's a rough marker that I can delete later, but at least I have a good idea of where that water will go. I'll scale this out just a bit more, and then put a blue color on it. What I'll do is go into the Materials, right-click, and choose Create, Material, and I'll call this new material Temp Water. I'll click on the main color and just put some blue in there. Then I'll pick this plane and drag that material onto it. Now, it's a fairly screaming blue, but I have a really clear idea of where that water will go, so I don't accidentally submerge or erode too much of the lake. And now back to brushing the terrain. I'll pick the terrain object, go back to my Raise and Lower tool, and brush in around here, doing and undoing as needed, lowering the brush size just a little bit. There we go. And brush in that lake, eroding the edges of that plane and giving it a small pond feel, as if this was purposefully set in the water. Now I'll back out and start to make some larger hills. I'll take that brush size back up, bring up the opacity just a bit, pull back, and add in some mountains. With my brush up and my opacity moderate strength, I'll start to add in some hills. We can see that terrain subdividing, and this brings up an important point here. When we're brushing in terrain, we need to work in broad strokes, adding in detail in layers, as if the mountains had formed over time. We don't want to take the opacity all the way up and simply make giant spikes, because that'll look kind of odd. We want to add these in, so that we're adding in bit by bit, ridges and hills and so on. I'll let these blend together a little bit on one side, and leave the edge of my terrain alone. Now over here, I'll start to add in more hills. This side gets a little bit taller, and then finally, I'll bring in another mountain range beyond. Now these are low rolling hills, nothing really drastic yet, but it's enough in here to end the view without feeling like we're trapped on a mountainside. I'll make sure to erode in and brush out any corners in here. If you find you need to start to push things down as well, you can hold Shift and push that terrain in. I'll push down some of those mountains, bring up others, and put in some ridges in my low-rolling hills. The big thing with the terrain is to make sure we don't add in obvious cones or other very symmetric features. We can use different brushes in here to really be able to sculpt this around. I'll switch over to a different, more spattery brush and brush in some other terrain features. Now we can see in this, it starts to add in considerable detail. And this is okay because my brush is fairly large. I'll make sure that opacity is nice and low and run this over. When we do this, this gives us the idea of nubbly hills and detail, rather than simply having these smooth, soft, sort of melted ice cream looking hills. I'll test this out by pressing play, and I'll see what it looks like when I go out on the balcony. I'll go forward, right through the door, up to the railing, and I can see in here my, well, unnaturally blue lake, and there's a mountain range around. It looks like it still needs a little bit of work, as they are kind of smooth looking, but I definitely get the idea of being on the water in this gallery. I'll go out and look at one other place here. Standing on a balcony and looking past the building, the mountains really nicely block the view, and it's okay to see the sky above. So my terrain brushing is working. I'll use my other brushes and sharpen up some of the hills just a bit, making sure that they're not all smooth and flowing. I'll play with the opacity and brush size, and I'll show what it looks like when I'm done. I've brushed in more terrain features, and I can start to look at some of the other tools here besides raise and lower. The paint height allows us to paint in additional height. One of the things we can see is that these hills tend to be very smooth, and switching over here to a paint height really lets us raise and lower parts of that terrain a little bit more. I'll pull these up even more. Rather than simply brushing in and raising and lowering, I'm adding in more and more height, and even ridging some of the mountains. It's okay if some of them plateau a little bit, and more of them start to, well, peak up. I'll pull up a few more, and we can see that terrain up-resing and down-resing as I brush. Once I do this, I'll switch brushes again and paint in that height. In the settings, I've got brush size, opacity, and a height. Flatten actually flattens out all the terrain, so be careful of that. But if you realize your terrain isn't quite working and you'd like to change it, you can flatten it. I'll bring up my height a little bit more and really start to brush out some of those areas that got flattened. I'll use that height to brush in an area, making sure that I don't have a perfect ring around my terrain. It looks pretty good, and I can also smooth this out by choosing the smooth height. What this will let me do is if I've got any areas that are perhaps accidentally a little bit too flat, smooth them. I'll switch back to a soft brush and paint those out a little bit. It's working, and I'm ready to get in and start adding detail and color in my terrain. I'll give it one more play test and see how this looks. Much better. I've got some low hills around in 2 stages. We can really see where that fog on the second hill is giving them some good distance back there. The low hills around the lake really kind of bound it, and I definitely feel like I'm in a small valley. More importantly, as I smash through the doors again, the terrain is really ending the view. It's providing a nice way to look through and see, well, mountains and sky, and gets the serenity of the place across as I smash through the window, but doesn't show that this is the only part of the game that exists. We assume there's more world, and so it's working very nicely. Now that we've got the terrain in, we can start to add some color, because those matte gray hills really need some life to them. When we're painting terrain, we have the option of adding color really at any point. We can rough out the terrain and then put in some color to see how it looks, starting out in gray so we can really see how the model contours look. Or we can start out with color and brush the terrain into it. It's up to you which way you'd like to proceed. I've chosen the first route here, brushing in at least the general hills around the valley, and now I'll add in some basic dirt and then brush on some cliff color. I'll start out in my terrain by selecting it, and I'll go over to the brush tool. As we can see, I have no terrain textures defined here in the inspector, so I need to bring in some terrain textures. What I've done is to put in the Assets folder in the Textures a couple of cliffs and some dirt. These are textures I've created in Photoshop, using a combination of custom brushes, lighting effects, some clouds here and there, and a few other tricks up my sleeve. You can make your own fairly easily, and I'd highly encourage that. Unity does come with a couple of cliff textures and dirt, but remember that everybody has them. So craft your own work, and that way you can use it in your game and really fine-tune the look of your terrain to your world. There's 2 cliffs, Cliff 1 and Cliff 2, and they're a slightly different color. One's a little darker, one's a little yellower and a little brighter. The dirt then is a rich red dirt with just some slight variation. It'll serve as my base color until I can get the cliffs on. With my terrain selected then, I'll click on the Edit Textures button and Add Texture. In the Add Terrain Texture dialog, I can choose both a color and a normal for this terrain texture. I'll click the Select button in the texture, And in the Assets folder, I'll browse down to pick dirt. I don't have a normal map for the moment, but it's easy enough to come back and add one in. What I will do is make this dirt texture bigger. It's uniform enough, I don't mind it being pretty big on the world, and then I'll add detail at a smaller size. I'll put in the size at 50 by 50 and click the Add button. When that goes on, I get terrain in, well, dirt color, and I'm ready to get some cliffs in. I'll zoom in on one of the more vertical faces here. This looks like a good place to start to get some rock. Right here where my brush is highlighting is nubbly enough it really would support a rock texture well. I'll add in another one of my rock textures. I'll click the Edit Textures button, Add Texture, click Select, and pick Cliff 1C. I'll make the size on this 30 by 30 and see how it looks. I'll click Add, and add in one more. They select when they're in blue, and so I'll Edit Textures, add one more, and pick the other cliff. Here's Cliff 2, and I'll put it in at the same size, 30 by 30. And I'll click Add, and now I've got two different cliffs available and some dirt. What I'll do then is keep my brush size fairly big. I'll try it around 80. Keep the opacity up, maybe towards 50%, and raise up that target strength. These may be set to whatever default they were on or whatever you used last, so don't be afraid to push them around. Now I'll start brushing in those cliffs, spinning around so I can see. I've got the cliffs selected here in blue, and as I brush, I get that texture. We can see in here that the cliff is tiling, that I'm getting a lot of repetition in it, and I probably need to raise up the size of that rock as well. I'll undo those brush strokes. And in here, I'll lower the brush size and then edit this texture. I'll click Edit Textures and Edit Texture, and I'm going to make the size of this rock 50 by 50, and I'll see how it looks. Now I'll lower that opacity a bit, and that way it blends over the dirt. I'll brush in a little bit of cliff, and it's working pretty nicely. At some point, if I edit that texture and get rid of that dark rock that's tiling, it should look pretty good. But it's a good way to get in and really add some life in here by brushing that across. I'll put some rock in other places, letting some of my hills be rolling and some of them be rock. Here's another good place for some cliffs, and I'll brush some rock into it. It's working nicely, although I could probably stand to have this be a little more vertical. We can always come back and start to sculpt things and flatten them if we need. I'll pick my Raise Lower Terrain brush, switch over to a harder brush, and see how it looks if I raise this up a bit, making those a little more vertical here. This should look a little better, and the paint flows right along with it. Now I'll come back to my brush, pick the other cliff, pull back the opacity, and vary that color across. This way we can get the idea of veining and color in the rock. So far it seems to be working. I'll hit play and see if I can tell. It works decently, although the fog is a little thick, and I don't have enough light. But definitely the dark cliffs and dark rock and dark dirt are making a difference. We can also tell that that fog is really too big, that it's really getting in there and just whiting out those hills. So I'll change it and test one more time. I'll go under Edit and Render Settings. And there's that linear fog end and that fog color. What I'll do is take this linear fog end out to, well, let's try 600 and see how it looks. I'll hit play one more time and run outside. This is a little better, but I still just have too much fog off in the distance. I'll pause and bring this out to 1500 on the linear fog end. There's also a fog density, and we can really take this down if we need. In that fog mode, we can say it's linear exponential, or EXP2, where it gets exponentially squared and gets very, very big very quick. I'll try it as linear and play one more time. Much better. I've got rolling brown hills ready for some trees and obviously some daylight. I can just see some variation back there in the fog where I've painted in those cliffs, and the idea of that rock is really reading nicely. I've got good variation and density going in that fog, and when it's pulled back to be perhaps not quite so thick, I get the idea of being surrounded by gentle rolling hills in this lake. I'll brush in some more rock on these cliffs and vary that color up. When you're brushing terrain, really try to make it vary. We don't need to see one texture over everything, unless we're dealing in, of course, a desert where it's all one color sand, we could say. But outside of that, really add some color variation as a base before your forest or your trees. It'll really read nicely if you've got some rock and dirt color going on, and feel like things are organic and natural and random as they should be. Trees are a major component of any successful landscape. Unless we're dealing in rolling fields of grass or a barren rockscape on a moon, chances are we're going to need some trees. We can make trees, or we can use the ones that come with Unity and modify them quite easily. Making a tree is an art in itself, and we need to think about all the different variations within that species, and how it should look, not just one, but when we have many of them on screen at any one time. Trees are a part of the terrain, and are sprayed on terrain objects. This way, they can function with the terrain, plant along the terrain, and randomize on that terrain. Before I get to making trees, I'm going to get a working light in my scene. After I got the color on the ground and the cliffs, it started to get a little dark, and I'll put in a directional light just to be able to really see what's going on. Later we can fine-tune the lighting and really get the mood going. But quite often I'll get some working lights in just so things, well, show up in the view. I'll choose Game Object, Create Other, Directional Light. This light is placed here at, well, wherever it landed. I'll move this light up, and what really matters is where it's aiming, not where it is. It's just a locator, and it's infinitely wide. I'll press E to rotate and spin this light around. Next, I'll crank up the intensity. Clicking and dragging on any of the titles here with a value scrolls that value up. So we don't have to go and grab the slider necessarily, although we can, or we can enter a value in exactly. But just dragging on intensity rolls that up for us. Now I've got some bright light. I'm going to leave shadows off because I don't really care to adjust their performance for the moment, and I don't want to see large flickering shadows when I'm trying to edit trees. I can see my hills and all the detail of my, well, tiling cliffs at the moment. Now for some trees. I'll import in the Tree Creator package and then get started on modifying an existing tree. I'll go in my standard assets, right-click, and choose Import Package, Tree Creator. In the Importing Package dialog, we've got materials and a bunch of textures for different kinds of trees. I'll turn off some I know I'm not going to use to save a little bit of space in the project. I'll uncheck all of the palm textures. With those off, I can look at any others and see if I'm going to use them. We can switch out textures if we need. And for the moment, this looks pretty good. I'm going to leave in the sycamore leaves, pine branches, and big tree materials. I'll click Import and let Unity bring this in. Now in my Standard Assets folder, I have a Tree Creator folder. And in Tree Creator, I've got Trees and Sources. In Sources, I have Materials and Textures, and these are all my different tree materials. Back here in Standard Assets in the Tree Creator under Trees, I've got a big tree and big tree textures. Selecting Big Tree shows us a node-based tree over in the inspector. Trees here in Unity are node-based. They're not necessarily modeled as we'd think of modeling a polygonal model in 3ds Max or Maya. These trees are constructed by starting out with a tree, adding branches, and then leaf groups. And we can tell by the numbers on each node that there are more than one of those nodes, 25 of those branches, 9 of the one below it, 225 leaf groups, and so on. What I'll do is to clone this big tree, bring it into the scene, and then modify it. With the big tree selected, I'll press Ctrl-D to duplicate. It'll duplicate the tree, naming it Big Tree 1. I'm going to rename it to Oak so I can find it easily. This may not be exactly an oak tree, but I'll try to approximate the spread as well as I can. Now with the oak selected, I've got the oak available in the inspector, and I can start to modify it. What I'll do is press F to focus in, clicking out on my terrain and even zooming back further. I'm going to take this oak and land it in the scene almost off camera on one of the corners. I'll pull this in, land it on a corner, press F to focus, and there's that oak tree. Now I can modify it and leave this tree alone. I'm never going to see it in my game because we'll simply never get this far. What I'll do now is to stretch this out. I'll go into my oak tree and start picking those branches. Picking this first branch, the main trunk here, shows the spline and its knots or handles. We can take each of these, press W to move, and pull them to stretch out that tree. I'll make it a little bit taller, and the tree will up-res and restitch itself. Then I'll add a little bit of a wiggle along here and slim out that trunk. Now I've got a taller tree. I can even start to move and rotate and scale pieces as needed. We can continue editing if we'd like, but I just wanted a little bit taller of a tree. I'll use this one and use the controls in the tree brushes to add hue variation. I'll scroll back, reselect my terrain and press F to focus. I'll focus in on it, picking the terrain, and zooming around until I can see everything. It's okay if F doesn't focus correctly to scroll around to where you need. Now I'm ready to paint in the tree. I'll click on the tree brush, and in the Place Trees tool I need to define a tree. I'll click Edit Trees and Add Tree. In the Add Tree dialog, I need to assign a tree, as it's telling me with a stop sign. I'll click on the picker next to the None Game Object slot, and there's my trees. I'll take from my scene the oak tree. Here's oak, and I'll close the Select Game Object. I'm taking this tree because I had modified it, stretched it out in the scene, and that's the one I want to use. If these trees need to bend, you can add in that bend factor. I'm going to leave it alone for now and let my trees be fairly vertical. I'll click Add, and I'm ready to brush this oak tree around. When we brush a tree, we want to think of how big of a swath of trees are we putting in, what's their density, and how much variation can we get in there. In those tree settings, we've got a brush size as shown by this blue circle on my terrain. There's a tree density, and clicking and dragging with this gives us a very dense forest. I'll press Ctrl-Z to undo, and pull that density back down. Here's a density around 60, give or take, and a decent sized brush. Now I'll crank up the color variation. We want to make sure that they've really got some life to them, because it's very obvious if they're all really close in color. Next, I'll crank up the variation for tree height. This way, I get a large range here in the size of tree. I'll also crank up the width variation and try to put in as much randomness as possible. I'll try a test brush and see how it looks. There's a good-sized grove of trees, and we can definitely see that hue variation kicking in. Zooming down to, well, ground level, we can really see that range and height as well, and it looks like these are working. I'll brush in some more. I'll put some down here by the lake, and then around. I'll leave some patches open here and there, but put some in behind. It's okay to have some variation. We can also increase the brush size as we get farther away, adding in trees sporadically in some groves and clearings and so forth, and then taking down the density as well. It's okay to vary it, and that's what really makes it look natural, if we really take some pains to move around what we're doing. I'll brush in some more trees, leaving some occasional clearings here. Maybe these are meadows or something similar. I'll forest in most of the valley floor, we'll call it, and start to put some in up the hills. I'm going to get some of the hills with trees, but some I'm going to leave bare. I'll bring back that brush size and just catch some of the top of this one. Now I'll put a few more trees up the side over here, because I might see this hill, but I'll leave the ones beyond fairly open. Just a few more trees in here, trying to stay off those rock cliffs. If you miss and accidentally brush some rock with trees like I've done here, you can erase them. I'll take my brush size down, hold Shift, and start erasing trees. Now if you've got multiple tree species going, let's say it's a mixed forest, you can erase those species of trees with a type selected by holding Control. So we have some options in how we place trees and what we're doing. I'll give this a quick test play and see if my trees are holding up in my view. With my new directional light in the scene, instead of my scene being a warm oatmeal gray inside, I've blown out the floor, and at least I can see the ceiling. I'll press W, smash through the wall, and take a look at the tree. And yes, in case you hadn't gathered, there is a good bit of humor in the making of a game, because we do things that are fairly ridiculous in real life, but really wonderfully silly while we're running around here in Unity. This looks pretty good. I've got some really nice forest going on, and the trees recede into that fog. I can definitely see where that fog needs a little bit of adjusting, but I like the density I'm getting. And I like how the trees off in the distance, even though they're in the fog, are really breaking up the silhouette of that hill. I'll run around to the other side of the platform, through the wall, across the blown-out floor, out through the other wall, and take a look. It looks good. If you haven't noticed, I test things a lot, and there's a method to that madness. We can't really tell from an overhead perspective if it's going to work. We've got to get in and test this game, and test this game again. And along the way, even before we add in collision and interactivity, we've got to run around and check it out and make sure it looks reasonable. I'll drop down onto the water. If you're wondering how I'm walking on water, no, I'm not possessed of any superpowers or something similar. This is a plane I had made in Unity. It's a Unity game object, and so it's automatically got a collider on it. That's how I'm able to walk through water, or actually on water, but actually passing right through the concrete platform of this building. For the purposes of my test and simply getting over here, this works pretty nice. I'll run through, clothesline myself on the bridge, and come back over to the building with a collider on it. I'll press the spacebar to jump through the steel column, smash through the windows, and check it out from this balcony. My trees look good. I may add in a few more here and there, but I like the density, and I like how they're leaving the lake shore fairly open. Grasses and other shrubs, detail meshes, are an important part of terrain along with the trees. What they let us do is ground those trees. Right now, I've got, well, trees in a barren landscape, and I could use to flesh it out, especially down by the edge of the pond, so it really looks lush and natural. I'll bring in some grass assets, and then start to paint them in, much like I painted in the trees. What I'll do is go into my standard assets, right-click, and choose Import Package, and I'll pick Terrain Assets. These are some standard terrain assets that ship with Unity. You can always make your own grasses, and I'd highly encourage that. This way you can have your own custom-made pieces that really match your world. We can also customize and randomize these somewhat in the editor, allowing us to add variation across a field of like grass. What I'll do is to uncheck all the items here. I'm going to avoid the palms and avoid some of the rock and cliff because I've already put that in. What I'll bring in, though, are my two grass textures here. Checking both, and standard terrain assets grass. I'll leave off the cliff, leave off the good dirt, and leave off the terrain textures of grass hill, because that's actually a flat grass that we paint on. Lastly, I'll check grass and rock. This will help give me a little bit of camouflage under the grass, instead of grass coming down to just bare dirt. I'll click Import. I have yet another new folder in my standard assets, and it's called Terrain Assets, and this has my grasses. I'll take a quick look at what these are before I start using them. When we look in the terrain grass, we can see Grass 1 and Grass 2, and each one of these, as we can see in the preview window, is grass and it has an alpha channel. And the grass color has been extended out and mats that grass against that alpha. That way, we don't get a halo in the grass of black or white or another color. That where the grass fades to transparent, especially in fine detail, it does so against that green that is its color, and so it looks correct. If you'd like to see how these look, you can also check out the alpha channel in the preview, clicking on the button to switch between color and alpha, and that's actually the shape of the grass we're going to use. Grass 2 is similar, a little more of a solid reed versus kind of a thin grass. And again, its alpha channel is pretty concise, but it's matted against its own green, so it looks correct when it anti-aliases against the alpha. Now I'll paint some grass in. I'm going to go in and select my plane, which is my stand-in lake, press F to focus, and then zoom in on it. When we paint in grass, it won't show up unless we're close enough, so we need to make sure we zoom in and paint accurately. I'll go into the terrain, and then into the terrain script, I'll click on the Paint Details tool. In here, like with our other terrain objects, we have a selection of brushes, and we can add in detail objects to paint in. So if you'd like to have multiple species of grass, for example, or grass and mushrooms, or something similar, you can add those in. I'll click Edit Details, and add a grass texture. In my Add Grass texture, I need to assign a texture to it, and I'll pick one of the grasses that I had just brought in. I'll click on the button for choosing the detail texture. And in my assets here, in the Select Texture 2D dialog, I'll scroll down and there's grass. I'll start out by picking the first grass, close the dialog, and look at the parameters. We've got a minimum and maximum width and height, a noise spread, and a healthy and dry color, and the option to billboard. Billboard for us means that this will always face the camera, and so it will always look full. It's still just a plane, but it'll look a little more volumetric. I'm going to bring up the max height to, let's say 3, so the grass really has some range to it. I'm going to make this healthy color a little bit dimmer. We'll see that if we paint the grass on with this really screaming neon, it will be far too bright. I'll click that healthy color and back off that color a bit, pulling it down and graying it out slightly. I'll leave the dry color alone and see how it looks, and then click Add to add that grass in. My detail meshes will show up here in the Details section, and I can pick and choose what to paint on. I'll zoom in on the lake edge and start to paint in some grass. We can see that that grass gets very, very full very quickly, so I'm going to pull it back just a little bit. I'll undo that paint stroke and pull back the opacity. My brush size is nice and small, and I'll pull back the target strength as well. Now I'll stroke in some of the grass, and I've got some obvious bare spots, which are okay. I'll fill in the grass around the lake, and I can come back later and erase grass, much like I was erasing trees. I've got a really good variation here between the two colors, between that yellow dry color and the nice dark green alive color or bright color. I'll paint in my grass, zooming in to make sure it looks good. I'm going to leave some areas unpainted and paint up some of the hills here and there, letting some of the grass disappear in depth in the view. I'll paint in some grass down at the lake and pull back that brush size even more, just filling in the edges as if it was nice and full where the water seeped into the soil. This is a section that's more of a clearing, and so I'll bring up that brush size and really grassify it. That's a highly technical term. Now I'll give it a quick test play before I start editing the grass. Along the way, I also need to take out some trees that got submerged in the water accidentally. I'll play first and see how this looks. I've hit play, and I'm inside the bright blown-out exterior. Dashing through a wall and falling down onto the water surface, I can see that the grass seeps into the water very nicely, and even has its own wind that waves it gently. And this way it doesn't look exactly static, and therefore a little bit odd. It looks good. The grass comes into view as we get closer. So I definitely need to make sure I've got some camouflage in the surrounding soil, so it's not just brown. I like how it's looking. I like how there's bits of soil poking through, and the color really varies, as does the height. It's definitely rolling fields and then trees beyond. And as I go around, walking on the water, I can see that the trees recede occasionally, and there's more of a meadow. I'll stop playing and do some erasing really quickly. I'll zoom in first, switch over to the trees, downsize that brush, hold Shift, and take out the trees that accidentally grew in the water. Now I'll go back to the grasses, my detail meshes, and add one more in, editing details, adding in another grass texture, choosing the other grass, cranking up the max height just a bit, pulling back that healthy color. Again, I like it a little bit darker. I'll make the dry color a little bit whiter so it's an obvious mismatch with the other grass, and leave it to billboard. I'll add this in and paint away. For this grass, I'm going to pull back that opacity. This way I'm just painting in a little bit of it. I need to make sure that I've chosen the right grass, and I can paint in the alternate. Now I'm ready for some lakeside editing. What I'll do is, again, downsize that brush, choose a harder brush, pull up that opacity, and hold Shift and gently remove grass. Holding Control while you do this erases a selected detail type, so if you want to take out just some of a species, you can. I'll pull this back and give my lake edge a bit of a haircut. Grass is a terrific way to camouflage what would be otherwise just a plane hitting the terrain. I'll let some of that grass grow into the water, work my way along, and trim it gently. Because these are just textures, You may find it very easy to make several different kinds of grasses and bring them in. You could bring in a situation like this, cattails, for example, or other kind of water reeds. Maybe there's some that are more dry looking and some that are definitely wetter. We can use this approach on anything. Really, anything we want could be a grass. It's only limited by your imagination and what you'd like to paint. You could also take pictures of an existing grass and make it into a texture, cutting around it and making it your own. I've trimmed my grass back from the water, and I'll take one final look at it and see if it works. As I walk on the water, again, I can see that the grass really has some good variety. Now, we may not get this close, so it's okay that it's just really waving planes in the wind. But I like the color variation and how it really helps to fill that in. I'll come back and add in some more green in places to kind of camouflage those hills. But it looks pretty good, and I like how things recede into the fog and the grass reveals as we get close. Some of the grass has grown into the water, but most of it is huddled back on the lake edge. When you're painting a landscape, one of the greatest things that you can do is make your own pieces. We need trees, we need grass, we need rock, and we need things in the landscape. Other species of plants, for example, or other things that are scattered around. And in Unity, these are called detail meshes. We'll use them in the same way, brushing them onto the landscape, but they can be meshes that are more dimensional. What I've done is to model out some quick cattails. I've used a combination of bent planes and bent planes that are crossed. They look like fluffy hot dogs on sticks, and they've got some leaves that are bent at the end. This is a quick model I put together in Maya, and then I've exported it out as an FBX and dropped it in the Meshes folder in my Unity assets. I'll go over to Unity and show how to bring this in as a custom detail mesh to paint on. Here in Unity, because I've dropped that Cattails FBX into the Meshes folder in my Assets folder, it automatically imported. I did this one in centimeters, and so I'm going to leave the scale factor at 0.01 so it doesn't make giant cattails all over the landscape. I'm not going to save any light map UVs in this one, as it's going to be lit differently. It'll light like the grass, where it's somewhat, we'll call it self-illuminating, but that's not quite the right term. But really it doesn't respond to the lighting in quite the same way. It also doesn't need any colliders, as I'm not really going to wade through these. Now I'll get a material on. It came in with a material from the FBX called Cattails, and this is a basic transparent diffuse, where the alpha channel triggers the material to be transparent roughly around the cattails themselves and their fluffy seed pods. I'm going to switch this material, dropping down the shader here from Transparent Diffuse and choosing Nature, and I'll use the Tree Creator Leaves Fast. These are special shaders here for nature that are made for the purpose of being sprayed around. And they've got a main color as well as a texture we can put in with an alpha and an alpha cutoff. This is primarily made for leaves, so that there's a real difference in the alpha between black not leaf and white leaf, and not much gray or fuzziness in the difference. The translucency color then allows us to have the idea of translucency when it is backlit. That is, if we're looking through this and the sun is on the other side, it will go translucent in this color. It's not quite a full subsurface scatter, but it's definitely an improvement over rendering really dark. And so it looks like it's, well, translucent plant material. I'm going to leave this alone for now, and I'll see how it looks and if I need to adjust anything. I think it'll be pretty reasonable. I may end up taking down the shadow strength, only because these are going to shadow on everything else and probably won't need much of a shadow at all. I'll take this material and rename it though, and move it over to my materials folder. Remember, we should always stay organized, even if it seems like the tiniest detail. I've renamed that material Cattails, and I'll drag it into the Materials folder. Then here in the Meshes folder, I'll delete that Materials folder. Now I'm ready to put these in. I'll take my cattails and put them into the scene much like I did the tree. I'll put this one way over on the other side where I'm never going to see them, zooming in on that lone tree out on the flat plain and pulling in the cattails into my plant making place. There's my cattails. I'll focus in and see how they look. They look good so far. The cross planes hold up nicely, and I think they look like, well, cattails. Now I'm ready to get these in the scene. What I'll do is to select that terrain, press F to focus, and zoom back in on the lake. By the way, If you press F to focus and you say, wait a sec, that really isn't the area I'd like to look at, try picking something else. I'll pick my plane here, that's my water, and then use that to zoom in on. Sometimes focusing on the terrain throws Unity a little bit, and it has a little trouble keeping pace and finding the right place. I'll zoom in so I can see the grass I put in earlier, and I'm ready to spray in the cattails. I'll select the terrain once more and go into the Detail Mesh section. In the Paint Details, we have our standard brushes, and I've already got the grasses I put in earlier. I'll click Edit Details and add a Detail Mesh. The difference between the two is that a grass texture then is really a flat plane, and they wave like grass, whereas a Detail Mesh allows you to select a custom object and spray it around. It can be a more dimensional object. You could even have detail rocks, for example, if you needed to make a boulder-strewn landscape. I'll use my cattails, selecting Add Detail Mesh, and in the Add Detail Mesh section, I'll pick that game object. I'll make sure I'm selecting from the scene, and there's cattails, those ones I dragged in out by the tree. In the Detail Mesh, we have a healthy color and a dry color, and that healthy color would make my cattails neon green and rather odd looking. So what I'll do is take that healthy color and gray it out. I'll leave some green in, but otherwise I'm going to let it be a really muted gray. I'll also take the dry color and do the same. I don't want these to run to yellow as much as, well, neutral gray-brown. Maybe I'll even bring a little more green in so that there's always some version of green in there, and kind of contrasting with any grass that's dried out. I'll leave the render mode as grass. Now I've got a random width and height to deal with, and I'll put the random width and height at, let's try 1.1, just so it varies a little bit. I'll click Add, and my cattails should be ready. I'll try it out, working with a small brush, starting out with a soft brush and looking at the brush size. I'll try a brush size of 10 and brush in some cattails. It seems to be working, although they're kind of small. I'd like to fix this, and so what I'll do is to fix it by editing that Detail Mesh. Back here in Edit, I'll put up that random width and height. I'll try 3 and 3, and they seem to stick up nicely. I'll click Apply and brush in some more. I'll put a few of these down by the water's edge, move around to another place, spray in a couple more, lower the opacity on that brush considerably, almost to nothing, 0.01. And this way when I spray, I just get a few in here to stick up. I don't want a giant intrusive flock of them as much as a few of them in the reeds here and there. And I'll put them down by the water's edge, and even some of them in the water. I'll spin around, make sure I'm in on the grass, land a few more in there, and populate with the cattails. It's that easy. You can make a detail mesh, or even multiple detail meshes, and spray them around, and really fill out that terrain nicely. I'll leave some of them in the water, but some I'll go back and erase in the same way. These that are just barely sticking out of the surface need a little work. So I'll hold Shift and just take them out, but I'll leave some of the ones sort of in the marshy edge alone. I'll spin around more to the more grass, spray in a few more, kind of stay on the dirt and see if any of them need a little pickup here and there. And I've got cattails. I'll erase some that are too deep in the water and keep going. It's pretty easy to make a detail mesh and to simply land it where you need, and it can really help fill out a landscape. What we expect to see when we're making a landscape are usually multiple species, and they kind of commingle in a lot of places. Now, some places may be a little more monospecies. Things like a birch forest or a pine forest, places where the conditions or the plants drive out other species. And you may not need as much of a detail mesh of another plant, but that's a great place to use a detail mesh of something different. Maybe clumps of leaves or rocks or fallen bark or whatever it is that really help fill out your scene. I've got my cattails in, and I'll give it a quick play test to see how noticeable they are. One of the things I'll do before I hit play is to go into my game window and choose Maximize on Play, and that way I can see it full screen. Now that I'm playing, running around the building, through the wall, out onto the water, I can see my cattails, and they're waving in the wind with the grass. It holds up pretty nicely. I haven't really adjusted the wind much. They do kind of sway quite a bit, primarily because they're reacting as a grass. However, they look good. They stick out. Their shapes are clearly visible. They've turned, rotated, and scaled randomly, so they all look different even though it's one model. and I have a custom detail mesh in my scene. Designing a landscape is like any other design. It's an iterative process of trial and error, rinse, repeat, and do more. Well, maybe not rinse. But we're going to get in there and put stuff in and adjust and test it out and see how it looks. So don't be afraid to get in and really move things around once you've got it kind of set. What I'll do is once I get some of the terrain features in, go back through and see what needs adjusting and keep going on it, often getting a fresh pair of eyes to look and see if there's anything obvious I missed while I'm worrying about the details. So far, I've got in trees, grass, and a detail mesh for cattails. I'm ready for the actual water and probably some additional terrain texture at some point because that brown dirt is looking a little bit on the barren side. I'll give it a quick play test and see if I notice anything else that really sticks out, and then go back through and catch some of the items on that list. My terrain looks neat, although it's a little bit brown. There's a clipping distance on the grass that's a little too short because the grass seems to materialize as we get closer. And I know that I painted it up those hillsides, so at least the foreground wet areas next to the lake have grass on them. Then the trees themselves can stand on more of the dirt. The wind is also a little bit too strong. I can really see the cattails sliding around as well as the grass waving a lot in the wind, and I'd like it to be a little more still. Eventually, I'll need to make a wet texture for the dirt to paint along the shoreline, but I'd rather have the real water in first to see how much I need and what I can camouflage. My trees look good, although the fog is still a little heavy, so I need to adjust that in the render settings. As I run along the lake surface here, the grass does seem to materialize, so that's probably a big one to hit. There's some grass growing out of the water here and there, and as long as I take down the wind, that's okay. It really gets the idea of that marshy lake across. There's that wind in action in the cattails, and it's a little bit on the big side, so that'll be the biggest one to look at. I think that the bright color on my grass, the dead color, is a little too strong as well. It's a little bit on the yellow side, and I'd like it to read more of a dark green overall. So I'll go back and do some adjusting and look at some global parameters in the terrain to be able to tweak everything. Back here in the scene, I've selected my terrain object and gone into the last tool over here in the terrain script, the terrain settings. There's our base terrain, and this is really a question of casting shadows, map distance, and is there a material on it? At the moment, there's not. It's just the textures I put on, but I could actually put in a material if needed. There is a tree detail distance and a density, and I'm okay with the way that's looking, although the distance in trees is a little short. I feel like I'm seeing some of them disappear. I'll leave it alone and see how it looks once I adjust the fog. There's a billboard start, and this is really for the trees to billboard or become flat planes at a certain distance. I'll set them to billboard at about, let's try 100, so they're a little more dimensional out there. Now look at the wind. There's our wind speed and size, and I'm going to take this way down. I'll try 0.1 for both wind speed and size, and see if that mutes down the grass moving a little bit. There's also bending, and I'll pull it down to 0.2, so it stays fairly straight with a little bit of wave, but doesn't have this giant overall sway. Here's our terrain width, height, and length, and we can adjust as needed. There's also our height map resolution and a detail resolution. What this lets us do is control the terrain detail when we're getting into it and make sure we're not seeing too many pixels showing. I'll leave that alone because I think it'll look okay in the resolution I have planned. Now, there is a section for a height map, and that's one we haven't brought in. If you've got a height map for a terrain, maybe generated in another program, such as Mudbox or World Builder or something similar, and you'd like to bring that in, you can. You can even draw one straight in Photoshop as a grayscale. A height map brings in a raw file, so it's got a full color range, or rather a full luminance range is what we're going to use, and pops out the terrain based on that. You can also even export out a height map of the terrain you've sculpted by clicking on Export Raw and exporting out an image that is your actual terrain as a height map, so you can use it somewhere else if you need, or reapply it as needed. Where this is especially useful is if you're trying to match a height map for a particular known locale. Let's say your game is set in the Grand Canyon, and you've actually got a height map for a section of it. And so you want it to really match into the real geometry that real people have seen and thereby might recognize. So you can bring in true data. I'm going to try this out and see if the settings I've put in make a difference. I did want to adjust that grass, and I'll go back in and tweak that here in my detail settings. There's my grass 1 and grass 2. I'll click on Edit Details with grass selected, and Edit. And there's that dry color. What I'll do a lot of times is to eyedropper straight from the scene. And this way, I get a really nice match all the way through. It's a slight variation in green, and I'll just take a little bit of color out of it. So I have a little bit of variation across what is dry and not, but not this really screaming yellow. I'll apply it, and see how the other one looks left alone. I like how my cattails are working, and now I'll see if it's a little more lush looking and a little more still. I'll hit play, and run through the building, and there's my serene lake. My grass maybe has a little wave to it here and there, and not much bend at all. In fact, it feels eerily still, which is really what I want for this game. My cattails are barely moving, which is good. They're not swaying back and forth in the wind like they were. It's working like I'd want. There's just a little bit of waft to the grass, so it's not perfectly still, but it's definitely not this giant zig that I had earlier. My trees are holding up nicely, and I still need to reduce that fog, but I like the way that the trees are handling themselves. Now I've got to work on that clipping distance. I'll exit out of playing, go back into those settings one more time, and see if there's a place to take care of how those are clipping. There's a detail distance in the Tree and Detail Objects section. This detail distance draws those details out to that number of units, 80 meters. I'm going to boost this up a little bit and see how, let's say, about 175 or so looks. I'll play it one more time. It'll take a minute. And now I'm seeing a little more of my grass. This is working nicely, so if I can get a green texture under some of it, it'll hold up really well as it fades off into the trees. This is a case where in the design, we need to plan for the distances we'll see things. I've got this nice marshy grass at the edge of the lake and the cattails, and then trees beyond. And as long as I've got some camouflage in the texture so it's sort of green and grassy enough under the close trees, the illusion will hold up that it seems like these trees are growing in a grassy area. In reality, I've painted grass on and only left some of the grass where I really need it. It's a balance in here, so don't be afraid to, again, do it, test it, do it and test it, and do it and test it again to make sure it's really working. Now I'm out here on my lake, and there's my gallery, which eventually should vanish once I make it out this far. Materials and shaders are a huge part of a game. They give us the overall look and provide us a way to show our textures, adding detail and realism to our objects. We do a lot with material and texture because we're constrained in the number of polygons we can push around, and so we've got to get the most we can out of each of those, material and texture, to really bring some realism or some stylization to our game. When we import our objects, materials do come across, at least where they're placed, and some of the properties come in, but we need to adjust them and make sure all the materials are assigned and named correctly. What I've done is to open up the scene 0601 and rename the gallery mesh back to gallery. This way, I'm using one mesh consistently, and it won't re-import materials every time. Renaming an FBX causes a re-import, and if you've already changed a material or renamed, it may automatically import a material again. This gallery mesh is part of the 0601 gallery prefab, and it's perfectly fine to have different names there. In the gallery, what I'll do is select it and look at the inspector, and I've got the scale factor at 1 and generate lightmap UVs on. When we scroll farther down, we have some material choices. Are we importing materials? If not, Unity will assign the default Unity white to everything. Because I've created and assigned materials in Maya for this object, I want those materials to come in because I've placed them on a polygon level. What I'll do is change that material naming, and instead of working by base texture name, I might choose from models material. And how are we searching? Is it a recursive search? Are we looking project-wide or just in the local materials folder? I'll leave it alone as it is now and click apply. Here's what Unity has done. It created some new materials on import for my objects and put them in a materials folder in the meshes folder. Now I had already moved previously my materials over to the materials folder, so I need to do a little bit of syncing up here to make sure things work. One way to see what's applied in a material is to select that material and change its properties. I'll pick the brick for example, and we can see when this material imported, it came across as a bump diffuse. This is the equivalent in Maya of a Lambert material with a bump in it. Unless we choose a specular shader in Unity, a diffuse material is the default, meaning it basically is a soft, powdery-looking material that has no specular highlight. Because I had put maps or textures into the diffuse color and the normal or bump slot in Maya, those came across here. And because those textures were present in my textures folder in my assets, they were imported into this material and placed automatically. This may not always happen, depending on where we need the texture and how we've assigned things in our other program like 3ds Max or Maya. What I'll do, though, is to select the main color of this brick and put a red in there. What this lets me do, aside from giving me garish red walls and floors, is show where that material is assigned. I can always take that color out. What I've got here is brick on the patio and brick walls surrounding the building, and that looks like it, and this is good. So it's a good way to check and make sure things got assigned correctly, especially if we're dealing in duplicated materials. We can see over here in the materials folder then that there's a Bricks C material. This came in without its texture and just as a diffuse shader. And so selecting the main color and putting in something different like a blue shows it's not assigned anywhere. I'll go through here, make sure I take out any duplicates, check where the materials are assigned, and make sure the naming is correct as I want it. Then I can start assigning shaders and finally textures in my materials. I'll pick Brick C and delete that actual material. It's not actually assigned anywhere in the scene. Then I'll go back to my materials and take my brick and pull it over to my materials folder. Next, I'll pick Brushed Bronze. This looks like it's assigned and uses the same texture map or texture atlas that shows up on the white walls. It's got a small section in here for bronze and a light fixture, as well as a bit of a vent we can see on a wall. Again, I'll take this material and tint it and see where it's applied here in green. It's applied correctly. The brushed bronze shows up on the railings and some of the door handles. That means it's good and I can leave it alone. I'll make sure I pull that white out and move this one over to my materials folder. Here's my metal screen. This came in sort of correctly. It's a metal screen material that goes on the perforated metal sections of the railings. It showed up as a transparent diffuse shader because there's an alpha channel in that texture that came across. But it's not quite behaving as I'd like because that texture's alpha channel also covers shine or specular highlights as well as the cutout for the punched out sections. I'll need to tune this one up later, but it looks like it's in a good place. And again, I'll do my test with the color. When the railings are purple, we can just see little bits of them showing up, and so it's working nicely. Here's my white wall, my dark wood, and my wood flooring. I'll take these and pull them over, and dragging them into the materials folder shows me it's available. If there was a duplicate material in there, it wouldn't let me drag them across, so I don't have any duplicate names at least. Now here in the materials, and I'll slide up this asset bar a little bit to be able to show all of them, I can see I've got a couple of different things going. There's a wood flooring CS, and I think I can delete it. Here's also wood blackened CS, and I'll do my color test one more time. When this is blue, I don't see anything in blue, so I'm in good shape. Finally, here's white wall CS, and again, that color test will tell me if things are working. When I put in that green, pull this project console bar down, and look around, I don't see any green. So again, this is a duplicate material I can take out. Next, I'll tune up the names. Waves here is a material that goes on one of my blocking walls that'll pop up, and it got the name from its texture when it came in. I'll rename this back to Waves Molded. And this is a molded wave material that's a wall cover on just a single polygon. Screen CS, again, is an unused material. I've already got my metal screen that came in, and so it looks like I'm in good shape. I'll delete that one. What I can also watch out for in deleting a material is that things go bright purple. That means that there's no material assigned. So far, everything is in good shape, and I'm ready to take the red out of that wall and get the right shaders on. I'll pick one of my walls, and we can see when we select one object that it's got its material listed here in the inspector. I'll pull that white out of my tan brick wall, and now I can start to change shaders. For this brick, I'm going to drop down under Bump Diffuse, and I have an array of materials available. A bump diffuse is a Lambert essentially with a bump or a normal map in it. I'm going to use a parallax specular, and the difference here is really that diffuse is a straight flat color. Bumped specular and bumped diffuse have a normal map, and the specular can shine. Parallax materials allow for an additional texture slot using an alpha channel for height. So I'll pick parallax specular, and I can see now that I've got a color, a normal map, and a height map from an alpha from somewhere that gives this material parallax, makes it look like it's really standing out, especially as we're close or oblique in the view. And that way things don't flatten out as much, showing off that they're only textures. With my shaders in, I'm ready to start assigning textures. If you need, you can always make a new material by right-clicking, choosing Create and Material. Make a new material, name it, and then start to put in other properties or change the shaders or even add textures. I'll call this new material Dark Iron and see if I have a place to use a dark iron color. For now, I'm going to make its main color nearly black. It'll be a deep dark wrought iron that'll match in well with my scene. I'm ready to get some texture in and keep fine-tuning the materials. Remember that in Unity, we can only assign material down to the object level, and so working by polygon needs to be done in another application such as 3ds Max or Maya. So get your materials assigned there and keep in mind what comes across: material placement, material names, and if there are color and normal textures assigned, those should show up, but you can always go put them in once you're here in Unity. Assigning multiple materials to an object needs to take place in another application. We'll use 3ds Max or Maya, for example, as our authoring application for our assets. We'll model the pieces we need and assign materials and unwrap or texture those objects. For example, I've put on the railings multiple materials. When I zoom in here in Maya, we can see by looking in the attribute editor that there's a material called metal screen, there's brushed bronze, and finally wood dark for the cap. I've modeled these objects as multiple pieces and then gone through and assigned materials before combining. Alternately, you can pick select faces and assign materials in both 3ds Max and Maya. I've done that for the floor, putting in the edge loops for the different places, and then selecting polygons and assigning the scored concrete, brick, and wood flooring, and so on. This way it's one object with one collider that looks like different materials. When I export this over, these materials will show up on that object in Unity. I'll go over to Unity and take a look. Here in Unity, I'll take a look at an object that has multiple materials and see how it came across. I'll pick that podium object. Picking once selects the whole FBX, and one more time selects that unique object, in this case podium 03. It's got a boxed collider on it that I had put on earlier so I could actually walk on the floor without falling through. We can see that the materials come across just as they were assigned. Concrete smooth is my outside edges and base, probably a polygon underneath as Lambert 1. Concrete scored is the walkway around, and there's the brick for the paving. Further down I see wood flooring, and that's the interior floor. For each of these, we can put in a shader and textures. Some have already come across because they were assigned in Maya. I'll change over the wood flooring to start. When we change an object's material when it's got multiple materials assigned, any other objects that share that material get changed as well. I'll drop down under wood flooring, for example, and pick specular. A specular shader changes from a Lambert shade to a Blin Phong shading model, and it has the capacity to shine. In here, then, I get a color with a gloss in the alpha channel, a main color and a specular color, and finally, the shininess. What I'll do so I can see this a little better is go over to my Materials folder in my Assets. If you notice, by the way, I have an extra blank Materials folder in my Meshes. That's because Unity created this upon import. I'll go back in Meshes, right-click on that folder, and delete it. Now I'll look in my Materials folder, and I'll scroll down to look at wood flooring. The reason that I chose to do this is that the preview window is larger when looking at the material on its own in the inspector versus a small thumbnail when it's part of an object's view. In here, in the wood flooring in the specular shader, I'm going to pick a different color for the specular color, clicking on the eyedropper, grabbing it straight from the wood color, then clicking on that color swatch and going lighter. Personally, I prefer to work in hue, saturation, and value for my colors. Alternately, if you'd like to work in RGB, you can click on this little icon here for the color sliders and change them back and forth. I'll take the value of my specular color and go brighter and add a little bit of saturation in. So when this shines, it's got a little bit of a warmth to it. I'll take this color and just add a little more yellow in the hue, so it's got a rich, bright warmth to it. A little bit of yellow in the floor, not quite so much pink. I'll back off the saturation just a touch, and it looks pretty good. In any of our materials, whether they're part of multiple materials on an object or single materials on one object, applying a color in the main color tints that material. So if this floor needed to have some red to it, for example, we could put that in, and it's tinted, overlaid on that base color. Because I crafted the texture as I wanted it, I'm going to pull out the saturation and up the value, so a tint of white does nothing to that material. We can use that color to kind of unify materials, especially when they're on one object. That's the wood floor, and now it's a nice, bright, shiny wood. I'll look at the railing, because that's also got multiple materials assigned. I'll press F to focus in and zoom in further. Here's my metal screen, and I'm going to change this over from a transparent diffuse to a cutout. This is the polygons that are on this railing, and there's one set facing us and one set facing the other way. Because they're single-sided, I chose to make extra polygons versus making a double-sided material. I'll drop down under Transparent Diffuse, choose Transparent, and instead of Transparent Diffuse, where it relies on the alpha to determine transparency, I'll choose Cutout Specular. A cutout material is different, as a cutout says at or below a certain threshold in the alpha cutoff, that material is exactly gone and will not shine. When I zoom in, I can see that perforated metal screen, and I'll pull down that alpha cutoff until it shows exactly like I want. With the alpha cutoff all the way down, I can definitely see where the shine is across that material. Pulling up the alpha cutoff a little bit lets the holes show, and lets the alpha channel where it's varied above that value dictate the shininess in this brushed metal screen. Here's what that alpha channel looks like, so you get a clear idea of how this is behaving. In my Textures folder under Building, I've got Screen CS. In Screen CS, it looks like a brushed metal. Switching over to the alpha channel shows that it's a varied gray, so it's got kind of a brushed texture in the shine as well, and then it's exactly black where it needs to be cut out. And this is a tiling pattern mapped at 3 inches square. Looking at the material then, selecting that object, we can see that the alpha cutoff being low allows that shine to vary from the alpha, and then below there clips out those holes cleanly. This material is on this object just in those screen sections, and I've got my brushed bronze and other pieces I can adjust. The last thing I'll do is change brushed bronze over to a specular shader, and what I typically do for metals is I'll take that main color and eyedropper straight from another color I like. Then I'll take this main color and darken it down. And finally, I'll take my specular color, eyedropper, right from the main color, and boost up that value. So more of the specular color and more of the diffuse is evident in the shine than it is in the main color, which is much darker. Now I'll boost up the shininess, and I've got my brushed bronze applied on just the frame sections on this railing. And any other railing that has this material got those changes as well. Make sure you get your materials assigned per polygon as you want them before you import. Although if you find you need to do a little bit of a change and want to re-import that file by exporting the FBX and bringing it over, Unity will update and change just those parts that you had changed. You can bring in those materials and adjust them to your heart's content, making it look as real and rich and subtle as you'd like. Textures are a giant component of materials in a game because we're limited in the shaders we have available and what each platform will accommodate. We can really get some mileage and detail out of our textures we apply. Your shaders may range anywhere from a full parallax specular with a cubic reflection map, simulating materials that have bumps that stick out and a reflection, all the way down to a diffuse material where it's just simply the main color in general light of that material, and it has to look, well, as real as possible. It depends on the platform you're after, and so we need to look at how to get our textures in and what we can do with texture to really make that material pop out. I've got my scene open, and I'm going to put some textures in places that need them. I'll pick this podium first, Podium 03, the podium on one of my buildings. All 3 podiums are fairly similar in their materials, and so changing one should change all of them. First, I'll work on the concrete smooth. This color is the default 50% gray of a Lambert in Maya. What I typically do for concrete is to take that hue into the warm yellows, we'll call it, bring up the saturation just a touch, and I'll raise up the value just a little bit. I'll put these values in somewhere I can remember. Here's 40, 20, and 145, so it's easy to put in another place. Now I'll work on the concrete scored. I'll scroll down and put that main color in. Here's 40, 20, 145. And now I'm ready to get a texture in for the normal map. There's a couple ways to get a texture into a material in Unity. In any slot where there's a texture available, you can click Select and browse into your Assets folder to pick a texture. I'll scroll down and pick Concrete Scored N, a normal map at 512 square with a square pattern in it. Now when I look at this scored concrete on the walkway, zooming in, we can see it's got a good score but has a consistent color in the concrete. Alternately, to get a texture in, such as the height map in the alpha, we can drag a map in. I'll work on the brick next. I'll jump over into the Textures folder in my Assets, and from there, I'll bring in that brick from the Building folder. With that podium selected, I'll scroll down, and there's my brick material. I'll take my bricks NH, bricks normal and height for parallax, and simply drag it right over into that height. Either way is acceptable. We can either drag textures in or select them. I'm going to make a new material called Waves, and I'll be using it later on one of my textured walls. First, I'll go in my Assets folder and into Materials. Right-click and create a new material. I'll call this new material Waves Wall. I'll change Waves Wall over from a diffuse to a bump specular. And now I'm going to get my textures in, but I'm going to search for them a little bit. I'll click the Select button to select for a texture. And up here in the search field, I'll put in WA. Unity will isolate down any textures whose names begin with WA, and I can pick Wave C for color. I can also do it with a normal map, clicking Select and typing in W, for example, and there's Waves N for normal. And there's that Waves material. This is especially handy when you have lots of like-named materials or a list that's getting prohibitively long to look for. So keep in mind when you're getting in your textures, there's any number of ways to pull it in. You can either drag or you can select, and you can filter down by name. And again, naming is very important because as you've seen in the filter, it lets you find things. It's very reasonable in a game to have dozens of assets, if not hundreds. So concise naming and finding things easily will make your life a lot easier and make the authoring of your game go smoother. Textures, as we know, are a major component of materials, and we can really get a lot of mileage out of them. And we also have a lot of control over how they're applied and what they do in-game, and especially on each platform. I'm going to tile this wood flooring texture twice within its UV space. I want smaller boards in there, because right now these are a little bit big, and I think it would look better with smaller strip flooring. I'll select the podium object, and there's its material, wood flooring. And in that wood flooring, in the texture, I can choose tiling and offset. I'll zoom in to get a closer look. Here's our wood flooring, and those planks are just a little bit big. I'll change the tiling up to 2 by 2. What this does is it repeats that texture twice within whatever the UV mapping size is. In this case, this was mapped at 144 square, or 12 feet. It looks better. The planks are smaller, and although I see more of the repetition, I think it'll go away when I have more walls, art, and more light in the scene. Beyond simply changing how big a texture is when it's applied, we have control within each texture over MIP mapping and how it filters depending on where we're looking at it. I'll select that wood flooring texture and take a look at the texture in the inspector on its own. In my Assets folder, I'll go into Textures, and in Textures, I'll go into Building. And here in Building, I'll pick Wood Flooring CS. There's my wood flooring. I can see here's the color, and switching over to look at the alpha shows me the alpha channel. Right now, this is simply tagged as a texture, and the filter mode is bilinear. The wrap mode is repeat, and the alternate here is clamp. Changing from repeat to clamp clamps that texture. We can see where it was originally mapped once over there, and then smears from there out. I'm going to leave it at repeat. That way I get the wood floor across the entire gallery. And in the texture type, tagging it as a texture is just fine. It's a main color of the material, so I don't need to mark it as a normal map or GUI texture or something similar. Finally, I made an alpha for this texture in Photoshop and saved it as part of that file. So I don't want to generate an alpha from a grayscale necessarily, although we can if you'd like to save space. We can do that if the texture will work. I'd like to leave it alone because I went through a bit of length to craft that shine. Now look at the filter mode. Where this really comes into play is when you're up close, what happens? Point filters tend to go fairly blocky. Bilinear tends to go blurry when you're up close to a texture, and trilinear differentiates between the mip-map levels, the levels of detail in the texture depending on the size we're seeing it. I'm going to leave it at bilinear, and that does a pretty good job all around with this texture. The aniso level for us is an important one, especially for things like floors. What this does is it takes a texture that we may see in a flat view like this, where we're looking straight out and the texture is spreading away from us, and makes it sharper as we need. I'll crank up the aniso level, and we can really see that texture get sharp all the way out. I'll pull this back just a little bit so there's a little bit of blur and distance. But now the floor planks aren't unnaturally blurring as they spread away from us. Leaving the aniso level all the way down really blurs that out. And in somewhere where the texture is a lot softer looking, that blur may be okay. But I'm going to pull that back up because I want those planks to really read as part of that floor, that we can really see the distinct color variation across it. I'll click Apply, and for all of the textures, we can always look in our defaults and change for another platform. So if you're running in iPhone, for example, or iOS, you can override and play with the compression quality, and also play with the format, and even spec a max size. What this means is you can say, well, gee, for a phone, this texture will down-res to 256 from 1024. So that way it's not swamping the phone trying to display a wood floor. I'll turn that off and go back to my standalone. If we'd like to get deeper into texture, we can also change the type over from texture to advanced. In advanced, we have a lot more control over things like mipmaps and import types. Some of the properties are the same, alpha from grayscale and transparency. But we also have the ability in here to say, let's make a cube map out of this to fake a reflection, for example. It generates mipmaps automatically, and what this lets me do is decide, as this is reducing in scale, how does it look? What kind of blur am I using to filter or blur those mipmaps together? And what kind of color space are we working in? Most of the time, you can stay within the standard inspector for the texture. When we deal in advanced, we need to get in and really fix something that's looking odd in distance or odd in different sizes. We may also want to get in and change things around, like for a skybox, for example, where we'll change over from repeat to clamp and really let that texture, well, clamp once and be totally bright so our sky looks correct. For now, though, I'll leave this texture back at texture and hit apply, and I'm ready to adjust any other textures in the scene. Reflections are a vital part of many materials, but how much reflection we need varies widely depending on the material we're using. I'm going to add a subtle reflection to my metals outside, my door handles and railing frames. The big deal with reflections is that they're computationally intensive, that a real-time, ray-traced reflection on the floor, for example, would bring many game engines to their knees, and doing this on a mobile device is out of the question. They simply don't have the power. So we'll use some creative fakery in here, pre-calculated images that move around and change dynamically. I'll scroll back in my scene and go select one of those railing elements. I'll pick a corner one here and press F to focus in on it. This object has three materials: dark wood, a metal screen, and a brushed bronze. I'm going to add a subtle reflection into the brushed bronze. First, I'll scroll down and change the shader over from a specular shader. I'll drop down to my shaders, and I'll choose under Reflective, Specular. We can see in the reflections we have a lot of our standard material types, bump diffuse and specular and so on, all the way up through parallax, so we can even add a reflection into our shiny, bumpy, nubbly surfaces. I'll choose a specular because this is a smooth metal. When you choose a reflective shader, Unity inserts a reflection color and a reflection cube map slot. A cube map, as the name suggests, has 6 images, one for each side of the cube, so that as we move around, it appears to move with us and change dynamically. Here's how I'll put this in. I'll go into the Materials folder in my Assets folder, right-click, and choose Create and Cube Map. I'll name this cube map Reflection Sky, and then I'll get images of my sky in there. Now that I've named it, I'm going to bring in the same sky images I used earlier. You may end up wanting to either paint cubes, draw cubes, photo manipulate some cubes, or render cubes in another application like Maya. For now though, because these pieces are so small, I'm going to use pieces of my sky and tint them using the reflection color. So I get the idea of stuff happening that sort of matches in the scene. First, I'll get those images in, clicking on the select button for the right image and going into the sky. I'll scroll down, and in the Assets folder, here's my sunny sky. I'll limit this down by typing in SUN, and there's my sunny sky, and I'll scroll this out so I can see their full names. Here's Sunny 3 right, and then I'll pick, moving this over, the top, and again, here's SU and Sunny 3 up. Here's the front, filter down, and Sunny 3 front, left, bottom, and back, in the same way. This filter is a great tool because it lets me get in and really pick things quickly. Now that I've picked all of my images, I can see in the preview a sphere, and dragging that sphere around shows that cube apparently moving. In reality, we're just looking at different images that are made to blend together. I've got in the cube map a face size and the choice of MIP maps in here. I'll check MIP maps so that as I get farther away it down reses, and I can limit down the face size if needed. I'll leave it right now at 64 and see how this looks. This will also let us reduce that and blur it down a little bit, which can be handy because again in a reflection we need stuff, not necessarily something clear. I'll go back and select this object and scroll down to that brushed bronze. Now in the Reflection Cube Map slot, I'll click Select, and there's my reflection sky. Once that's in, my bronze is rather blue looking. I'll use that reflection color to bias it down and reduce the amount of reflection a bit. In the reflection color, I'll click on the eyedropper and grab that main color, and the reflection changes over to be a bronze color reflection. I'll bring this up just a little bit, bringing up the value and just the saturation a touch. I'll see if this works and then see if I need to adjust more. What we get in here is a little something going on. It's not much, but it's just enough in there to get the idea of something happening. We can just see some movement in that surface, especially when we pan up like this to look at the sky. It really has that feel of bronze in there. In this case, perhaps a little too polished. I'm going to pull down the shininess on my bronze, and I'll also darken that specular color. One thing to note, you may end up darkening your main color as well when you're putting in a reflection. It's okay for metals for that main color to be almost black, so that the material really reads as that dark metal with some of the color contribution coming from the reflection. Now it's got a good reflection to it. I backed off the shine a little bit, and it really reads as that bronze color for those railings. It's got a subtlety, and really what I'm after here is that there's stuff happening in the reflection. It's not necessarily that they're stunningly reflective, as much as changing as I move around. I'll put this same image into the window frames as well, so that they've got a little bit of sky reflection from the cube. I'll pick any one of the window frame objects and go look at the material. Here's a window frame joining bar, and it's got an anodized bronze on it. I'll focus in, and we can see it's that material that's across all of these Mondrian-esque window frames. I'll do the same thing, changing from a diffuse over to a reflective specular. They go white, and that's okay. First, I'll grab that specular color from the main color, and then darken down the main color. Now I'll get the cube map in, clicking Select in the Reflection Cube Map, and choosing my reflection sky. Finally, I'll take that reflection color, borrow that specular color so it darkens out, and maybe even go a little bit darker. This material is usually a very dark one, so I really want that reflection to mute down. I'll saturate it, and I'm going to darken my main color almost to black here. And now here's the test. As I move around, there's definitely something happening in there, but it's so mellow that it just barely shows when I look at the biggest piece, but it definitely feels more like a metal. I'll give it a quick play test to see how it behaves. As I move around and go look at this window frame, it has a rich bronzy look, and it's definitely kind of a oil-rubbed or brushed surface or something similar. And I can see where the glass goes in. And there's a little something moving that just gives it the idea of being a metal. The same goes for the railings. I can see, as I walk right through them, movement in their metal. I should probably put the same reflection cube onto that metal screen. I'll jump out onto the water and take a look. And again, we can see it really behaving like a brushed metal or a very subtly soft, shiny metal, that there's a little difference in that reflection, and it's a great way to bring things to life. You may end up wanting to make a custom cube map, as I said, or simply borrowing one of your existing ones and tinting it. We want to save our reflections to things that really need them. We'll put a reflection in the water, for example, or maybe use a really good reflection on the floor, or even a custom-made cube map, to really make it look like that wood floor is glossy. But for things that need a little bit of reflection on a little surface, a small cube map that gets the idea of stuff moving is a great way to go. Materials and shaders can go a long way in helping the lighting look correct in a scene. Beyond simply colored in the right way and shining, maybe with a reflection, we have a class of materials called self-illuminating, and what these do is look like they're giving off light. This is really important when we're trying to light a space, that the light fixtures look like they're on, and they add a tremendous amount of believability if the lights that appear to be on are pretty close to illuminating the room, or at least so we think. I've made a can light, and it's a surface mount can. What those are cans that are stuck to the ceiling versus recessed into it. We're going to put these all over the gallery, and we need to get the materials dialed in so that they look like they're giving off light. Whether every one of them actually has a light or not is really up to us in how we light the space, but they need to look at least softly lit. I'll go into the Meshes folder in the Assets, and there's Can Light Surface Mount. It comes in with a scale factor that needs tweaking, as it's very, very small at the moment. I'll put this scale up to 1 and generate Light Map UVs. Then I'll scroll down and change the material naming from the base text or name to From Models Material. This has 2 materials assigned, a bronze and underneath a gradient where it's supposed to look lit. By changing this over, I'll make sure I get both materials in, and I'll hit Apply and let those changes take effect. Now in the Materials folder in the Meshes, where Unity creates automatically materials upon import, I've got a leftover from something or other, White Wall CS, and then Lit Bulb and Bronze. Actually, this leftover was here from the initial import, and then once I changed over how Unity was perceiving those materials, it was still there. It just created 2 new materials for me. I can delete the White Wall CS by pressing Delete, and now I'm ready to adjust these lit materials. What I've also done, and I'll look in the Texture folder to show this, is to update the White Wall material. Here in the Building Textures is my White Wall CS, and I'll enlarge the preview and take a look at the alpha channel. Instead of merely black in the alpha, now it has a specular channel, and what this does is gives the wall a little bit of a sheen. The vent has a little bit more of a sheen, and the baseboard's a little shinier. Up in the top left, we can see a gray and white gradient, and that's actually what will determine how this light looks lit in that bulb section. The square to the right of it, then, is a brushed shine surface that will give the bronze in there, whenever I use it, a little bit of a striping in the specular highlight. I'll jump back over to the Meshes directory, pick that Can Light surface mount, and drag it into the scene. I'll pull it actually right into the scene view, and this way I don't have to hunt for it. Because we're going to place this object as a prefab and then let it batch or define once and just reference the definition, we can actually place it in versus actually taking the place it was in Maya, which is actually flung out into the lake somewhere. Now with this light in, I'll pull it up and snap it onto the ceiling. I'll zoom out in my scene view, switch over to a wire, and hide a few things to make it easier to see. I'll pick the oak, the plane, and the terrain, and the cattails, and uncheck their visibility again. Now I'll pick my Can Light surface mount, press F to focus in on it, V to snap, and snap it up to the top of a wall. Then I'll pull it over on the ceiling. I'm not sure where it's going to land yet, but I at least want it up on the ceiling in the right place. I'll switch back to a textured view, and there's the start of my can light. Here's how the materials will work. With that can selected, I can see I've got two materials, lit bulb and bronze. I'll take the lit bulb material, which is just applied to the faces inside that can, and change its shader, choosing self-illumine and diffuse. I don't really need this to shine, and it's going to look totally lit, so it wouldn't really show a specular highlight or reflection. So a diffuse is the simplest possible shader to use here. By changing to a diffuse, I get an additional slot here in the material. It accepts another alpha channel, and this is where I can define where it looks like it's emitting light. I'll go in and pick, by clicking on the Select button, that same white wall, scrolling down and picking White Wall CS. Now, the whole material looks lit, and we can tell here in the sample sphere that the wall is actually softly glowing. That's okay because I've assigned by polygon just these lit faces. If you have a more complex object, you may want to make sure that your alpha channel is really set for self-illumination. That is, if it shouldn't look lit, it should be black. My light is pretty good, but I need to eliminate that bronze material. I've already defined a bronze that I'd like to use, and so rather than have yet another bronze, I'm going to borrow one of my existing ones. I'll open up my materials folder, and there's a brushed bronze. This brushed bronze actually uses that same texture. So what I'll do is to select that can light and drag this brush bronze right onto it. It lands in the place where that bronze was. I'm making sure to hit those polygons that I already had assigned the bronze to. Now I've got my same brushed bronze material on the exterior of the can light, but I still have the self-illumine shader on the actual lit bulb. And when I deselect it, it looks at least like that can light is lit. I'll press play and take a quick look at it. But before I do that, I'll make sure I turn on the shadows of my directional light, dropping down under Shadow Type and choosing, soft shadows for now. This way I'll get some shadow through the window and won't get inadvertent light around the top of the can or in other places where light might leak. When I play my scene, I can see the can light in the distance. I'll zoom down to it and take a look up. Now obviously the scene is not lit inside yet, but it definitely looks like that light is on, at least from the light bulb. And so when I get a light in on the floor here, it'll really reinforce that, yes, this part of the gallery is lit by that can light, and I believe it because of the self-illume material. In making games, beyond simply bringing in assets, we need to add interactivity and really make this a place we can run around and do things in, not just run around. So far, we brought in our gallery, got the materials on, at least got a working light, and got most of the lake and terrain around. Still needs the water, but that'll come in a bit. The big deal, though, is we need to start getting the collision and interactivity in place. We need to make game objects. Right now, these are all actually game objects. Anything that we can select here in the hierarchy is a game object and something that can be called directly in a script and affected in some way. Picking, for example, the can light surface mount shows in the inspector that this has a name, and we may want to put on a number. We can tag it and put on a layer, and it is a model. And what are the model's properties? Well, it's here. It's got an animator controller on it. It's got a mesh renderer, so it does show up. It's got materials, and we can even get into casting and receiving shadows and so forth. This is already a game object, but there's a few other game object types we may want to use as part of making our game and adding on the interactivity. Under game object, we can create an empty game object, and this is equivalent in 3ds Max or Maya to a dummy or a null. What this means is that it's a named object with its own transform that actually doesn't have a mesh renderer of its own. I'll make one and explore its properties and how we can use it. I've made my game object, and it really just appears in the center of the view. We can see it by its transform and its name, game object. Right now, it actually doesn't have anything on it. It simply exists as another point in space. If you've done some rigging, perhaps, in 3ds Max or Maya, the idea of an extra transform should be a familiar one. A lot of times we use this as a reference. Calculate the distance between two game objects and look between them, for example. We might see that in a script, where we're saying, tell the player or something else to look between and interpolate. What we'll do with this game object is start to parent things under it. This way, when we have the whole place sink out of sight through the lake, we can move one object instead of trying to move everything all at once. I'm going to rename this game object over to Master Building. And now I'll take my other pieces and drop them onto it here in the hierarchy. I'll take the gallery, the CanLight surface mount, holding Control to select multiples, and that should be it for the moment, I think, but I can always add more. I'll drag them under Master Building. Unity shows for me a blue oval, which denotes, yes, it's going to parent under there. When I let go, everything is parented under Master Building, and opening that up shows those objects. For example, if I pick the CanLight, press Ctrl-D to duplicate it and clone it, that parenting relationship is maintained. So when we start to populate this building through with art and walls and so forth, we'll make sure it's parented under Master Building. In the end, we'll pick Master Building, focus out on everything in here, and we'll take Master Building and drop it under the lake. This way, when the player steps out or collides outside of the building with a trigger, this animation is activated and the building will disappear. I'll press undo before I sink my building too far below the lake bed. A game object then is a very valuable component, even though itself it may not have anything in it. Now if you'd like to be able to see these game objects, you can add a tag on. Right up here in the inspector, next to the visibility checkbox and the name is a cube. I'll click that cube and select an icon for the game object. In this case, I'm going to make the master here yellow. And now Master Building is visible wherever I go in the scene view. Anywhere that I pan around, that tag will show, and I can center it if I'd like on the buildings. This is a handy technique because now I've got full control over everything in here by one object, at least to move it around. The other game objects we'll end up using, some of which we've already seen, are under Create Other. The idea then is that these are native objects in Unity versus imported objects, but really anything in the scene is a game object. We'll start to put in other pieces, such as particle systems and other lights. We may make a few more primitives, and we'll also see things like an audio reverb zone, defining in here where does the audio sit in a particular location, maybe a hiss or a hum as we pass by the air conditioning. So let's get started adding some collision and interactivity into this space, transforming it from simply a place to run around to a place to play in and bring our game mechanic to life. Components in Unity are very valuable pieces for adding in gameplay and interactivity. A component is, as the name suggests, part of something, and you're actually already using them. We'll put a component, like we did on the first podium, on the second and third, selecting that podium object and choosing either from the top menu, Component, Physics, and Box Collider, or down in the bottom, picking the last podium, scrolling down, and choosing Add Component, and again, Physics and Box Collider. What we're doing here is adding on a component that dictates some element of gameplay. In this case, instead of using a mesh collider, because we don't really need to collide with every face of this, we're adding the simplest collider possible, a box collider, defining the overall volume as something we cannot pass through. And this is easier for the game engine to think about as we're playing. The idea of a component then is it's a piece of an object or attached to an object that is part of the gameplay. Components are attached to game objects, and we need to think of them in that way. What makes components neat is that they don't break a prefab connection necessarily. Removing one may cause issues, but adding on a box collider to the podiums is perfectly fine. Now, when I select the podium object, we can see other components on here, such as a mesh renderer and a mesh filter. We've already seen the most basic, a game object, which is simply a transform. It has no other components, and we can add them on as we need. In our components, we have choices we can make over how they behave and what we can do with them, and also how to size them. For example, in this box collider, I can put on a physic material, but I'll need to import that package first. What physic materials do is let this component react like a true material. Is it metal or wood or ice or whatever, and things will slide correctly across it if need be. In our other components then, we've got lots of choices to make. We'll look under the component menu, and we can add in things like, for example, mesh filters or a mesh renderer. So we could put a mesh renderer on our game object for the master building if we actually want to see something. We can add on effects, such as particle systems and trails. We've got our physics and our physics 2D, new in Unity 3D, which lets us attach physics to objects, and also things like joints and hinges if we want to get into ragdolls and similar rigs and interactions. We can put in things like nav meshes as components on objects. What these let us do is take NPCs, or non-player characters, and designate areas for them to navigate in. Finally, we can put in audio, and there's all kinds of audio filters and zones to add in. What these let us do is define, for example, an audio zone where maybe we can hear the vents more than in other places. In rendering, we can get into our lights, our flares, additional skyboxes, and even our GUIs, and a sprite renderer when we're working in a 2D game. We've got scripts, and scripts are a component that's attached to a game object as well. The idea being that a script will very rarely run on its own. At the very least, if there's a script in the game and not connected to an object we need to see, we'll put this script onto a game object and probably put a label on so we can find it. This way, the script will run maybe when the game starts and judge if something is going on. Finally, there's our character and camera control, letting the camera look at things or look around and take input. A lot of these components are already on the first-person controller we're using, but these exist if we need to remake it in some way or make our own version. So keep in mind then that a component for us is attached to an object, and we can add and subtract them as we need, and add gameplay and interactivity, taking just standard static assets we've brought in and really bring some life to them. I'll add on the last two components here, the bridges, by selecting them and putting on the same box colliders. Here's my last bridge, and for this one, I'm going to scale that component a bit once it's on. I'll choose Component, Physics, Box Collider. This would overlap with the colliders on the podium. So what I'll do is take this box collider on its Z-axis here and click and drag to scale it in. It's scaling, but not quite fast enough. I'll drag more, or just drop down this number, and I'll pull this collider down so it just matches up with the edge of that podium. A little bit of overlap or underlap is reasonable, as long as it's not a giant meeting. That looks pretty good, and now I can't fall through the bridge. I'll fix this on the other one as well. Selecting the bridge, focusing in, zooming in when focus maybe doesn't quite do it, choosing Component, Physics, Box Collider. Again, I'll take the Z size of that collider and just pull it in to match. Many components have their own unique transforms or sizes like this, and so we can attach colliders to multiple objects and really think about optimizing our collision. What we see versus what we interact with may vary wildly. We may have a lot of boxes we collide with, but they're on complex meshes that really look like the buildings we're navigating around in. I'll give it a quick test play and see how this looks. I've still got to light up this space. It's very gray inside because it's all in shadow. There's my can lights up at the ceiling and smashing through the doors, running outside on the balcony. There's my screens and all their metals. My brick, still a little blown out because I haven't adjusted the lighting, but more importantly, I'm running across the bridge, and I'm jumping right through the ceiling. I'm going to smash through the wall and run across the other bridge, and into the next building, and through the doors. Okay, I realize this may be just stunningly exciting to see a guy running around on a bridge, but it's really neat to be able to get those components in and start to add in the sense of place by seeing where we can go and limiting, well, the player from falling through the floor. In a game, we use colliders for two main purposes. The first is to limit what a player can and can't get to. We can keep a player from, thankfully, passing through walls this way. The second, then, is we'll use our colliders as triggers. If we enter a collider, or collide with it, something will happen. We'll use the colliders as triggers to help with the animation in the building. But first we need to get in our fixed colliders. The colliders that are put in place so we can't simply walk through any surface, but are instead bounded along a player path. A player path in a game, then, is the area we want our player to go. Even in an open world, where the player in theory can wander anywhere in here in the gallery, we need to make sure our players simply can't get through some things, and are eventually herded by the colliders and what they open up out to the exit, or so they'd hope. And in the meantime, hopefully there's some fun gameplay as well. What I'll do for my colliders is try to use a box collider in as many places as possible, optimizing the colliders as frequently as I can. A box collider is one of the cheapest, and a mesh collider is the most expensive. And most of the objects in here will work nicely with a box collider, and we simply can't tell that we're hitting a box instead of the actual object. For my bridge, I'll start out by selecting the middle railing section, and I'll choose Component, Physics, Box Collider. Now I can scale out this box collider by increasing the Z size, or take the value from the bridge collider I added earlier. I'll pick the bridge collider, and there's a Z of 1217. I'll copy that number, and come back in here and paste that in. Now I've got a box collider that spans that entire bridge railing. The two side sections of railing are there only as mesh renderers. They're there to look nice, really, but not to keep the player in. I'll copy this component as well, dropping down next to the gear and choosing Copy Component, and then picking the other railing side and pasting in. This will work in many places, although it depends how an object was cloned around. Now I have a collider on the bridge, and so I can't fall through it, and I can't pass through the railings. Well, there's that collider. And I'm ready to look at the other pieces. I'll pick the next railing section over and put a box collider on it. For this long railing section, I'll pick that middle section and add a box collider, and then scale it out. I'll put in a size as a guess to start. I'll try 920 and see how it looks. Then I'll move this collider. It doesn't have to necessarily be centered on that object. I'll pull it back here, and there's a rough fit. It looks pretty good. What I'll go in and do is check and make sure that the collider has a small enough gap to the next railing that when I get a collider over here, the player can't really squeeze through, and it looks pretty good. I'll get a box collider on this cruciform column as well. I'll choose Component, Physics, Box Collider, and I'll repeat with the next one over, again, Component, Physics, Box Collider, and finally this last column. If it's difficult to see in here, you can always turn off the light, toggling off and on the built-in lighting, and seeing things in a flat shade. I've put on box colliders on the column and railing sections, and now I need one on this last screen here, because it does sort of pop into that space. I'll choose Component, Physics, Box Collider, and later I'll be adding a box collider that takes up most of this windowed wall inside. This way, the player can hit the column here and probably catch that corner if they really decide to bump around into things, but it won't feel like they're being arbitrarily kept out of this area. I've got box colliders on the bridge, and along here on the floor of the bridge, the podium, and most of the railings in this section. I'm going to put in another game object as a marker for my spawn point, and then I'll get in and test out this game. I'll choose Game Object, Create Empty. Add a label in by clicking on the cube and giving it a color, and I'll name this Spawn Marker. Now I'll borrow the coordinates from the player controller, rolling up the master building group and choosing the first person. And there's its position, -74, 5, and -12. I'll pick my spawn marker and put those coordinates in, -74, 5, and -12. And now I've got the spawn marker positioned back here with the first person controller. So I can move that first person around and know where to put it back to. I'll pick my first person controller. It may take some navigation here in the hierarchy, and I'll pull it over onto that bridge and give this a quick test. I'll start out on the balcony, and I'll hit play and see how it looks. Here in my game, with all the terrain hidden, I'm back to floating in the blue sky. But as I come forward here, I hit that railing. I simply can't walk right off it, and I can bang into the pole and into the next railing. I actually have to navigate around and across the bridge, and I can't jump off the bridge anymore. My colliders are working. Over here, forgot to put the collider on, and I'm falling off the world. So you can see in here where thinking through the colliders very carefully is important. We want to avoid places where the player dies inadvertently by falling off the world. Gravity exists inherently in Unity, And your player controller has mass, so if you fall off the world because somebody forgot a collider, you're out of the game. So put the colliders in. I'll go through and finish out all the box colliders on this, scaling and sizing them out and adding them in anywhere I need to hem in that player. Then we'll get going on putting the triggers in and getting our game more playable, not just a place to run around. We can use colliders to activate animations and trigger things. Beyond simply fencing the player in, colliders can provide a way for the player to interact with the game and their environment. What I've done so far is to add on the master building all kinds of different box colliders. They're on all the different objects, such as the cruciform columns, the railings, and spanning the windows. The only place where there's a mesh collider is on some of the white walls inside. As being just a couple of polygons, those were cheaper as a mesh than as a box. Everything else, though, is done with a box collider so that the player can no longer walk through the walls. What we'll do now is add a box collider in as a trigger to open French door 11, the leftmost door of the four seen here. This way, the player can finally get out onto this balcony as one door is unlocked. We could have multiple doors swing open and do it with either multiple colliders or a script that triggers all kinds of animations. But for the moment, I'd like to keep it simple and to hem the player in, to add a little more anxiety, finding all the doors but one locked. What I've done then is to take this object, French door 11, and to add on an animation component. This animation is an older component, but it's useful for simple animations. What it lets us do then is say, there is an animation on this object, and does it play automatically? In this case, there's an animation on here called French door 11 swing. The door swings open, holds for a few seconds, and swings closed. Now I'm ready to get a box collider in, and to do this, I'll make a new game object. I'll choose Game Object, Create Other, and Cube. I'll take this cube, move it over into the space, forward onto the door, and scale it out to the size I need. I'll sit it in the middle, press R to scale it up, and scale it out a little bit more, so that if the player triggers it from either side, hopefully they won't smash into the door. The door will actually open in time. I'll even push it out just a little bit more in the door swing, so that before they are smacked by the door should open because of the collider. I'll name this Door Open or something similar, and that way I can find it here in the hierarchy. I've called it Door Opener 11, and that way it's associated with French door 11. It's up to you how you'd like to name things so you can find them, but as long as you're using a consistent naming convention, that should be okay. Keep in mind, in many games, you may have an alphanumeric naming convention that really doesn't read well in plain English. But when we're dealing in thousands, if not millions of assets, we need some way to organize. Now I'll turn off the mesh renderer on this. Dragging down the preview window a little bit on the material, and turning off the mesh renderer, and turning off cast shadows and receive shadows as well. This way, it absolutely will not participate in the rendering or display, but simply trigger that animation. Now I'll set it as a trigger by checking Is Trigger in the Box Collider component, and I'm ready to get an Activate Trigger script on. I'll scroll down to the bottom of the inspector, click Add Component, choose Scripts, and Activate Trigger. These are ready-made scripts that come with Unity that we can use to activate simple things. This is a terrific way to get into scripting. Rather than simply jumping headlong into writing code, you can look at a script like this, open it up in MonoDevelop. It's a C# script, we can tell by the icon here, and see what it does. It's a neat way to start to learn the syntax and how the code is thinking, and then you can start copying and pasting and writing your own. Now I'm going to set this up to animate that door. First, I'll put the target in. For my target, I'll click on the pick icon, make sure I'm in the scene view, and filter down to find that French door. Putting up in the filter in the top, FRE, and there's French door 11. I'll select it, and now I need a source, which is going to be our first-person controller. Again, I'll click on the pick button, make sure I'm in the scene view, and type in FI for first-person controller. With that selected, I can set a repeat trigger. This way we can go back and forth in the door. It's a trigger count of 1, so if we're counting how many times this was accessed later in a script, that's our value for it. Lastly, I need to set it to animate. We have choices here in the action. Are we triggering something, replacing? We can use this, for example, if we are destroying an object. You collide with, destroy, replace it with something else. Activate or enable, animate, and deactivate. These different choices let us do different things, such as, well, replacing things, enabling or letting something come to life, deactivating, turning it off so we can no longer interact, and so on. I'll choose Animate, and now it should work, animating that door when the first-person controller collides with it. I'll drag my first-person controller over closer in the scene, because now there's colliders on all the doors, and then I'll press play and see how this looks. I put the first-person controller in the adjacent bay in the lobby, and I'll see how this plays by pressing play, spin around, walk forward. Still need to light this space, but at least I have the can lights. And over we go, and there's the door opening. I go right through. Wait a sec. Okay, so here's the neat part to it. We get close, we can squeeze through, but we're stuck on the width of the door. This is a neat exercise in realizing the size of the game controller versus the size of the animation and the size of the objects. The game controller is, well, a rather portly fellow, actually. If we look at the capsule, it's actually very wide. So I'm going to reduce the size of that capsule just a bit. And this way, I can keep my doors feeling human-scaled. Here's my first-person controller, and there's a radius and a height. I'll pull this radius back down from 0.4 meters to 0.25. It'll make the collider a little skinnier, and should let us get through that door. Much better. When we're not quite so round in the middle, we can get through a single door nicely. This is an important point here. You may be looking going, wait a sec, I thought the game controller was just fine as it was. The lesson to learn from that exercise is that we often need to look at who we are as a player and the world we're in to make things feel a certain way. In this case, I'm shooting for a very realistically modeled space. That I've got a single door, and these are 3 foot wide, by the way. And so if a person can't fit comfortably through a 3 foot wide door, I have to consider either the nature of the person or the nature of that space and adjust. Now, there's not a bias here in any way, but simply what I'm saying is, our game controller starts out rather oversized, and we need to take into account who we are in our space and possibly adjust who we are, essentially, to fit our environment so that the gameplay feels, in this case, more natural. I'll try it one more time. Coming up to the door, it opens, and I walk through comfortably. A little adjustment in the size of the game controller worked, and there's the door swinging closed, and I can trigger it again. Now, the fun part is the player will get up to the other doors, try to open them, and can't. And we'll have a little fear introduced in the situation. I've used that box collider as a trigger then, activating that animation, and the animation takes care of opening and closing the door as if there's a self-closer on it. Alternately, we could have it trigger different animations from either side. We can get more complex with multiple colliders, or find other ways to trigger an entire tree of behavior. For now, though, a simple collider like that, opening up that one door, will work nicely in our gameplay. Physics in a game engine provides a terrific way to add interactivity and fun in the environment. What physics lets you do is attach rigid bodies or similar colliders to an object and tell them, yes, please react when you're hit, you have a mass, and so forth. And so you can do things like knock over art, for example, in this gallery. We can also do things like crash into doors and fling them open, and even get as far as dealing with hinged objects and chains and so on. We'll start out by putting some art into the gallery that we can knock over. I've brought in a new FBX called Tower Sculpture, and it's exported out in centimeters so the scale of 0.01 is correct. It's 3 abstract modern tower sculptures made of plaster, and we're going to place them in here, get some colliders on, and let the player knock them over. What I'll do to start is take this tower sculpture and drag it into the scene. I'll put it in, spin around, and move it through the doors. I'll press F to focus in, and there's my sculpture. This is a place a lot of times where I'll turn off the lighting, and that way I can see things in a default shading mode a little more clearly, because I haven't really lit the space yet. I'll pull this sculpture into place where I'd like it, probably over here, right in the sun, and by this big wall. Now, we're going to let the player knock these over, so we need to add a couple of components on. I'll pick the first tower sculpture and add a box collider. When you're dealing with physics, two mesh colliders can't collide together, so we need to use other colliders. And this is where if you need child colliders, such as multiple boxes to approximate the shape of an object, you can use them. These towers are close enough to boxes and have enough edges that stick out that I'll use a box. There's 1, and 2, and finally 3. Now with all of them having a box collider, I need to put one more component on. I'll put on a rigid body, choosing under Component, Physics, and Rigid Body. The rigid body then specifies a mass, a drag, an angular drag. The possibility of using gravity is kinematic, and we'll deal with that if we have animation that needs to turn off and on and then react with physics. And then we have different interpolation and collision detection methods. We'll use the default here, no interpolation and discrete collision. Basically what that says is, when you are collided with, please do something. And that's different from continuously looking or looking dynamically and some other different ways of checking. We're going to say it's discrete because it's when the player knocks into this object, they will knock over the art. Under constraints in the rigid body then, we can say, well, you can't rotate, and maybe on a certain axis, or you can't move, but you can only rotate. And this is handy for making things that are hinged, for example. I'll leave it alone because I'd like the player to be able to accidentally knock over the art. A big no-no in an art gallery usually is to touch the art. And so we're going to let these be here and the player can bumble into them. I'll add a rigid body onto the other pieces, choosing Component, Physics, Rigid Body, and one more time, Component, Physics, Rigid Body. This works so far, and everything is set. I want gravity on, and I'm going to leave the mass alone and see how it behaves. However, our character controller won't collide with it initially. I'll play this to show how it looks. I'm in my scene, dark though it is, and there's my towers, and I can bump into them. It's working at least, they're box colliders, because I can not pass through them, but I'm not knocking them over yet. What I need to do to make this work with the character specifically, the player, is to add a script onto that character that acknowledges that the character's collider is hitting another collider. This is from the Unity help, and I've included it in a Word document in the Assets folder in the scripts here, so we can simply copy and paste into a new JavaScript in MonoDevelop. I'll put a new script on, selecting that first-person controller, scrolling down to the bottom to add a component, and I'll roll up some of the other pieces so I have a little more real estate to work on, choosing Add Component, New Script, and in the new script, I'll set my language to JavaScript, and I'll call this new script Character Hit. I'll hit Create and Add, and now I've got the script, which is blank, and I can get those script elements in. To edit a script, you can drop down on the gear and choose Edit Script, and Unity will pull up MonoDevelop. MonoDevelop is a powerful scripting and programming application that comes with Unity and works in multiple languages and is tremendously handy for scripting in things here for your game. The default script in JavaScript for Character Hit looks like this. Basically, it says we're working in a strict pragma, strict language we'll call it, and do something. Function start and function update. When the game starts, do something, and when the update happens, do something. We're going to replace that with this character controller script. What I'll do is open up that Word document and just copy and paste over. I've opened up the Word document from the scripts directory in the project assets, and this is what this script looks like. In scripting, in short, because we'll get into more scripting later, when things are preceded by a double slash, they are commented out. And therefore, the lines of the script we're looking at to start are variable push power. How much power does the character have? Function, on character controller collider hit. When we hit something, do something. We have an attached rigid body. Basically what that says is when you hit something, you have a rigid body because the character controller does not have one initially. And then if you hit it, what do? What it also says is we have a variable push direction and a vector 3. That's our x, y, z. And this is restricted so we don't push things that are below us. And then the last part of it, apply the push. The velocity of the character plus the push direction times the push power. And that gives us the application of that push. I'll take this and copy and paste it into MonoDevelop by pressing Ctrl-A, Ctrl-C for copy. switching over to MonoDevelop and pasting in. I've pasted straight in, taking out the functions section, and now my JavaScript is ready. I'll save this script by pressing Ctrl S and go back to Unity, where that script will automatically be updated and loaded. Back here in Unity, with the script updated, I can see now I have a push power section, and that's the push power I can add to that character. I'll try this out again, and what I'll also do is put a light in so I can actually see what's going on. I'll choose Game Object, Create Other, and Point Light. I'll move this point light over. As long as I've got something to see beyond gray, that'll work. I'll pick my character controller, and there's a push power of 2. I'll try it out at 4 and see if this works. I'll press play and go knock over the art. It worked. I jumped over one and knocked into the others, and they fell over. I'll try this one more time from a different angle and see how it looks. I'll press play, go into my scene, come around to the other side. I'll go look at these neat modern sculptures and accidentally, whoops, knock one over. Now, this should freak out the player just a little bit, which should bring a smile to you as the game designer. Because what do we do in an art gallery? Typically, we look. And so to have somebody be able to knock it over and not know how to pick it up adds a unique element to this game. And more importantly, we put some physics in our world. What we've done is not just put a collider on, where we can simply bump into them and stop, but we've told them, yes, please react. And you've got a rigid body so you fall and don't break, and you don't bend, and react with gravity. And so we can make it fall over, and now we have fallen art in the gallery. Working with physics opens up all kinds of neat possibilities in our game, because we can have things collide, knock over, move, slide, roll, and even get into hinges and joints and chains. Once we've added physics on an object, we can get further into the properties of those physic materials. And what I'll do is import in my physic material package and get some materials on these towers so they behave a little more realistically. Now, the physic materials are different from the materials that are on the object. Right now, these towers have a different material on them. I'll select one, and we can see in here it's called white plaster. I'll take a second, tune that up before I get into a physic material. I'll click on Diffuse and change the shader over to a bumped specular. This way, I can get a normal map in, and I'll roll up the rigid body for now and open up that material. It's supposed to be white, and so there's not really a color texture with it, but there is a normal map that was also imported, and it's in the Textures folder. I'll click Select in the Normal Map section, scroll down, and pick Plaster N. It's a gently cracked and varied surface for that plaster, and so these are mapped and should show a little bit of variety as if they were molded. As a note, it's saying, would you like to fix that normal map now? And I'll click Fix Now. It fixed it, or so I think, but I'll make sure I go and check that in my Textures folder. In the Art Textures, there's Plaster N. And yes, it is a normal map, created from a grayscale, and we're in good shape. Now for the physic materials. I'll go into my standard assets, right-click, and choose Import Package. In the packages, I'll bring in my physic materials. And there's a reason it's not physics. It's a naming convention from Unity. In our physic materials, we've got some by default, and we can always go to the Unity store and get more if we need. I'll use these to start out. I think wood will work nicely. I'll click Import and bring them all in. And now I've got my physic materials. Going into those physic materials and selecting one shows us the properties. Each physic material has a static and dynamic friction, a bounciness, and combinations. What happens with the frictions? Is there a direction? And so on. What this lets us do, for example, is stack objects using the static friction so they don't start off sliding off each other. And then we can add in dynamic friction. For example, if things are made of rough wood and they need to fall down and skid to a stop, we can crank that up. I'll try it as it is at the moment and see how it looks. I'll pick my first tower, and in the box collider there's a material section. What this is not a standard material, it's a physic material, and so I'll click on the selection button and go pick wood for that particular one. I'll repeat it with my other towers, again adding wood in the physic material section in the box collider. I'll also put a material onto the floor, selecting the floor or the podium here, And in its box collider in the physics material, I'll add in wood as well. It's a wood floor, and this will work fairly nicely for the outside too. I'll look again at the rigid body on these as well. Right now, in their rigid body, when I open it up, I can see it's got a mass, a drag, is using gravity, and so on. I'm going to bring up the mass a little bit. I'll put a mass of 2 in and see how it behaves. I'll make the smaller one 1.5, and the bigger one I'll try out at 3. We can put some drag in as well if they're skidding too much, but I'll leave it alone for the moment. Adding some friction to the floor should help, and I'll play this one more time and see how it looks. That's a little better. I ran into the art, and it fell over and stacked. In fact, I think because of the geometry in the art and the friction, it stacked a little too perfectly. I'll knock over this one, and they knock over nicely. I like the way that's reacting. They're not sliding across the floor anymore, and the mass is really helping them fall over. I'll do one last bit of tuning here. I'm going to pick the small one and add a little bit more drag into it. I'll put the drag at 0.1. I'll also do this with the bigger ones, giving them just a touch of drag, and that way they'll fall and skid a little bit, but not much. It's very easy to have floating objects, and so we want these things to come across as if they have a mass to them. I've knocked over the art. I can also play with the floor, maybe even creating a duplicate of the wood material, renaming it, and changing its parameters so it's a little bit smoother and these skid. I like the way it's behaving though, because I've got these materials now really falling and clunking correctly. When we're working with physics, one of the powerful things we can do is to chain objects together. What this will let us do, for example, is take this mobile sculpture and link the pieces together so it hangs from the ceiling. And when the player knocks into it, it will wobble back and forth. The pieces can rotate and will move but are fixed by their rods on that wooden hanger. It's a collection of spheres and very, very small cylinders for the rods and a roughly modeled series of arcs in wood with a wood base that goes onto the ceiling. I've already put in the correct materials, so the eyes are on the spheres, there's chrome, and there's the same dark wood we've used elsewhere. I'm ready to get the colliders on. In this object, I've avoided putting on a mesh collider in the FBX, and so instead I'm going to put on custom sphere and box colliders so it collides with the rigid bodies correctly. I'll start out by getting the spherical colliders on all the eyes, picking them, choosing Component, Physics, and Sphere Collider. Now with the spherical colliders on, I'll get box colliders on the rods. They're actually 5-sided cylinders made in Maya and then softened so they look round, but they're small enough that a box will work nicely. I'll pick the first one, choose Component, Physics, Box Collider, and then I'll repeat it with the other 3. Finally, I'll get a box collider on the hanger. Although it's actually 2 boxes that are bent, one big box will work nicely because it's at the same level all the way around, roughly. I'll put a box collider on the hanger rod at the top, and finally, one on the top mounting block. Now I'll get rigid bodies on everything. It's simply a matter of going through and picking each one and putting a rigid body component on. Once all the pieces have a rigid body component on, I can go through and set up the hinges. I also should get a material on so that they react correctly with the right friction and the right mass. It's really up to you what order you'd like to do it in. As long as everything is on, it'll work nicely. One note here on the top, this mounting block. Although it's a box collider and has that rigid body onto it, I'm going to turn off gravity and freeze the position. This way, it's fixed at the ceiling, and I'll freeze position on all 3 axes and rotation. It's supposed to stick in place, but let that first hanger rod hang from it correctly. Now I'll get my hinge joints on. I'll start out with the first sphere, and I'm going to turn off the lighting so I can see a little better. On this sphere, then, I'll choose Component, Physics, and Hinge Joint. We've got a couple different joints here. Hinge joints, fixed joints, spring joints, and then characters and configurables. A hinge is one of the simplest ones. It simply allows freedom of movement and rotation on multiple axes as needed. Things can be hinged together. A fixed joint, then, joins rigidly rigid bodies. And finally, a spring, as the name suggests, is springy and allows objects to snap out and come back. I'll pick hinge joint here. And in that hinge joint, we can see it's got an anchor, it's got a spring, and a motor. And there's also limits for braking force. If we need objects to actually break and fly apart, we can put in that force there. Right now, the brake force and torque are infinity, meaning it can't be broken. This way, we'll knock into it, but it can't come apart. The hinge joint is noticeable by the small orange arrow, and it's right up here at the base of the connecting rod. This is where I had set the pivot for that sphere, and so it defaults to there until we move it around using the anchor or axis. Now in the connected body in the hinge joint, I'll pick that connecting rod. This is I01, and so it connects to hanger rod 01. I'll click to select, and the only thing that's available in the rigid bodies section are objects that I put a rigid body onto. So I'll pick hanger rod 1, and now there's that connection. Then I'll pick the hanger rod and do the same. Component, physics, hinge joint. I had put the pivot for this up at the top, and that's where that hinge joint originates. Then I'll pick its wood hanger as its connecting piece. I'll repeat this process with the other ones, and then connect in the top hanger. I've added hinge joints onto all the eyes, hangers, wood hanger, rods, and up to the ceiling base. This way, everything should hang, and I'll give it a quick test once I turn back on the building, and then see what I need to add in my physics materials. I'll pick the master building and turn on its visibility again. I'll make sure that this is up at the ceiling by selecting that whole sculpture and pulling it up. Now I'll press play and see how it looks. The sculpture bobbles gently. It's already wobbling, and the eyes will come over and look around. I may want to start those in a different position, but it looks kind of neat. It works, and when I jump, I can bang into it and cause them to move around considerably. It does need a little damping. We can see in here it's getting a little crazy in the motion, and that's because those objects really don't have much mass. It's going to sit there and sort of bobble forever, and the colliders will freak out a bit and collide with each other. I'll put in some damping. I'll start out with the eyes. Scroll down and look in the rigid body. There's a drag there, and I'll put up the drag to 0.5. I'll add the drag to the other eyes and see how it looks. I've added drag onto all the eyes, and I'm ready to add drag and a little bit of resistance onto the wood hanger and other connecting rods. Part of dealing with physics materials then and our rigid bodies is making sure things don't fly around. So I'll put some drag on this hanger too. It's a little heavier, so a drag of 1 should work. I'll give it a test before I put the drag on the chrome hanger rods, and I'll see if it behaves any better. It looks better so far. The eyes look around, and it's not quite shaking in such a jittery way. I like the way it's looking, and we can just probably bump these as we go by, and they'll knock around a bit without getting too crazy. We should probably add drag on the other objects so that they really are kind of a little more stationary, but it looks like the drag is slowing it down nicely. Finally, let's get some physics materials on to complete this. I'll click on the eyes and go into the material in the sphere collider, and in my physics materials, I'm going to choose rubber. I'll put the rubber material on the other eyes here, and then try this one more time. Finally, before I try it, I'll get a physics material of wood on the hanger. We should really go through and make sure we have materials on anything that really counts here. These rods are probably okay on their own. Now in a test. My mobile is a little less jittery. I should probably bring up the mass on a few other things, but I like how it's moving, and when I knock into it, it definitely gets a little crazy but then settles down. So it's kind of neat to be able to bounce off the art a bit, knock into it accidentally. We can use our physics to add some life to the game, adding the ability to fling things, knock into things, push stuff over, and otherwise affect our world, and let the animation happen very naturally, being generated by the physics engine. Animation is what we use to bring life to a game. We've had a glimpse of it using physics to make art we can knock over. And now we're going to make components that are ready to animate. I want to look at the nature of prefabs and batching here in Unity first, and what that means, and how we should set up to animate a lot of objects. I'll go over to my game window, and here in the game, I've turned on Maximize on Play and Statistics. What this shows for us is the number of draw calls, the number of times we're asking the graphics card to display something, and then the number saved by batching, or defining an object once, and then referencing it again. When I hit play, we can see that draw call number change depending on where we're looking. If we're looking in a gallery and we can't really see out too many windows, the draw calls are low. We're saving 61 or 59 by batching, and then as we turn around, we can see the draw calls shoot up because we're looking at more objects, but we're batching a greater number. This means that there are more things that are defined once and then reused. We'd like the art to follow this, where we define a limited number of pieces, swap out the material, and have it batch as much as possible. What I've done then is to bring in a selection of FBX files, each one being one size of art. There's art painting rectangle large framed, for example, and rectangle large unframed. There's medium, and then also medium odd size, we'll call it, or medium tall, and even a small with 3 panels. These then correlate to the materials for those paintings. I've gone through the materials folder in the meshes and made sure all the names work. We've got in here Art P, art for painting, and here's all the different paintings available. There's a few that have imported doubly, and also a wood blackened, which is the frame. We'll use the dark wood material on those frames and swap them in and out easily. This way we can define a frame size once and have 3 or 4 paintings that use it. I'll take the Art P circles, for example, and tune up the material and then get it on a frame. In the main color, I'll go into Select and I'll pick Circles, Color and Shine. This tells me it should be a bump specular shader, and then I'll go into the normal map and pick the circle's normal that matches. Now I'll borrow that specular color right from the painting and just crank up the shine a little bit so it's got a little metalness to it. Art P Circles is ready, and I'll look at a table I created to tell me which art goes on which frame. This is a PDF included in the Modernista design folder in the exercise files. This table shows the name of the piece of art and the frame size it goes on, along with the dimension and framed or unframed. I've also included the Word document, so if you'd like to add to this another column, say maybe the building it's in or the wall it's on, you can add that in. It's very common to have lists of what the assets are and what kind of prefab they fit on, especially as we get into many, many assets. Keeping things straight requires some kind of list or table. I can see that Circles goes on a rectangle large unframed, and so I'll put that material on that prefab. Back here in Unity, I've got my Circles material ready, and I'll go into Meshes and pick Art, Rectangle, Large, Unframed. I'll drag it into the scene and press F to focus in. I'll make sure I'm in the scene view, and there's that painting. If you notice here, I was in the game and it wouldn't let me drag it in. You can't pull things into the game view. This is where you view what's going on. Back here in the scene view, there's my painting, and I'm going to attach a box collider to it. It looks like this material came in as a transparent bump, so I'll make sure I get that on so we don't see through the painting. Here's my Art P Circles, and finally, Component, Physics, Box Collider. Now this painting is ready to instance around. I've made a prefab, and it's called Art P, Rectangle, Large, Unframed. And so swapping in another material is easy, and it'll reference the same file over and over. I'll duplicate it, slide the duplicate to the side, and get another painting on there. The next one I'll use is my desert. I'll pick the desert material, make sure it's a bump specular shader, and get the right maps in. Here's Desert 1993 Color and Shine, and I'll get the normal map in as well. I'll eyedropper the specular color, and now I'm ready to put this on. I'll drag it right on, and now that prefab has switched, and I'll turn off the lighting so we can see it a little better. This is now using one prefab twice, and I'll get batching or saving of draw calls out of it. It's important to do this before we get into animation, because we're going to clone these objects all over, and any components that are on those objects will clone as well. So by putting the collider on once, I save myself that work. Making sure the art is on the walls and the walls are cloned as prefabs as well will save me the work of dragging it in over and over. And in this case, I can simply swap out the art, clone the wall, and get it ready to animate. Animation is a powerful way to bring your environment to life. Beyond using the physics, we can keyframe animation right here in Unity, sparing us the need to make it in another program such as 3ds Max or Maya. Now, there will be a lot of places where we'd like to animate somewhere else. There may be more robust tools or better rigging control. But for a lot of simple animations, such as doors opening, lights turning on, and fans spinning, for example, we can animate it right here. And that way we can use one model in multiple ways. Some are static, and some are animated. What I've done so far is to bring in the rest of the art, get it on those prefabs and get the right materials in. I've also brought in one of the solid walls that the art will stand on. And this way I can start to place these walls around, put their art on, nest them underneath or parent them, and animate them. But I'll begin by looking at the animation window in animating a simple door opening. We need to make other doors operable so the player can navigate in and out of the buildings. I'll take a look at another one of the French doors, showing how to make it swing open, hold for a second or two, and then swing closed gently. I'll open up the master building and then the gallery, and I'll scroll down to find the French doors. I'll pick French door 18 and press F to focus in. This is a French door on one of the balconies. In keeping with the other animations set to trigger earlier, I'm going to animate one of the 4 doors in each bay. I'll randomize which one this is, and that way the player has tension in trying to find a way out. Instead of 18, which is the same pattern as the previous animation, I'll pick 20. This way they have to hunt around, trying each one, and this will heighten the tension. I'll choose Window and Animation. In the animation window, we start out with what looks like not a lot. We need to add in an animation curve, and we can add these in as separate objects we can call for multiple prefabs. To start out then, I can either click Add Curve and choose what to add in. Alternately, I can simply jump in and start animating, and Unity will ask me to save this as an anim file. I'll go into the Assets folder and into the Animations, and there's my earlier French Door 11 Swing anim. I'll name this one French Door 20 Swing.anim. That way it's got its own swing, and it'll have position and rotation keyed. I'll click Save. What this does, in addition to saving a separate file we can call, is allow us to stack in animations on an object. That way we can have multiple animations called in a script or sequence through them as we need. Now in the Add Curve, I'll scroll down and find that door. Here's French Door 20, and I'll open it up, and there's the transform. In the transform, I'll pick Rotation and click on the plus next to it. Now I'm ready to animate. It starts out with a key at 0 and a key at 1 second. Unity runs at 30 frames per second, and we can really have as much time to animate as we'd like. What I'll do is go in and delete this key at 1 by selecting it and right-clicking and choosing Delete Keys. Then I'll go over to 130, and I'm ready to animate. I can either add in more keys here in the animation window or simply animate in the view. Up on top, the red play, pause, and forward buttons let us know that we're animating, that we're recording what we're doing, much like Auto Key in 3ds Max or Maya. I'll press E to rotate and hold Control to snap this open. I'll rotate that door open, just a little past 90, and Unity makes a key automatically for me. It puts in a position and rotation key, and that's okay. That's why I named this anim file specifically for this door. Now I'll add in some more time and set it to hold for a bit and then swing closed. I'll hold Control and scroll back in the anim window. And this way I can add more time and see more. I'll click over at 430. Looking at the frames, I'm at roughly 270. It's okay to be a little off here. It'll add some character to it. Now I can either click Add a new key or just scrub the door back and forwards and put a key in. I'll click Add Keyframe, and it puts one in position. The default for this is to add in a position key, and while that's okay, I need a rotation key in here. What I'll do then is just hold Control, click the door over and back. Later I'll come back and fix the tangents on those. Finally, I'll scroll back more, drag the timeline over to 630 or so, and close this door. Again, holding Control so it snaps closed and animating the door closed. Now it's got an animation where the door starts out, swings open, rubber bands a bit, and swings closed. It's good, but it needs a little fine-tuning. I'll pick these keys here at 130 and 430, picking one and holding Control to select the other. Right-click, and I've got my tangent types available. I'll pull this window up a little bit and zoom in so we can see a little better. By right-clicking, I can choose different tangents: auto, free smooth, flat, and broken. And I've also got left and right tangent control for each. I'll choose flat, and this way it will smooth into those keys and they'll be flat between, having no motion. Right now we're working in the dope sheet, where we can see the keyframes simply placed on the timeline, and we can't actually see the curves. If we'd like to get in and adjust the curves individually, we can click on the Curves button at the bottom of the Animation UI, and there we've got a traditional graph. We've got our keys available, and we can get in and move them around as we need. If we zoom in far enough, we'll be able to see their handles, and selecting the keys shows us those Bezier handles. We can custom tune that animation to whatever we need. For now though, flat tangents will work nicely, and I'll close this animation window. My door is ready. Now what I've got on here is an animation. I'll add an animation controller onto the door by scrolling down and choosing Add Component and Miscellaneous Animation. There's Animation and Animator. Animator goes into Mecanim for behaviors and trees and states. Animation is far simpler and usable for things like this. I'll pick Animation and then choose that animation. I'll uncheck Play Automatically, and I'm ready to tie this into a trigger collider, letting the door open when the player gets close enough. Animation takes time and patience to finesse and get right. Once we've got an animation on an object, we can adjust its timing in the animation editor. For example, we'll take this door, French door 20, and smoothly open it. Right now it kind of jerks as it opens. When I pick that door, I can see there's an animation already on it, French door 20 swing. It's unchecked to play automatically, and I can also set the loop type depending on how I want to trigger it. For these animations, if we look in the Animations section where we put that animation, and select the actual animation, there's a loop time in there. I'm going to leave that checked because I want it to play once when I trigger it. It's not set to play automatically. And so the difference in here is really, is it playing automatically and looping? Is it playing automatically and not looping? Is it not looping and not playing automatically, and hence triggered by something else? Now I'll edit that animation. I'll select it and choose Window and Animation. This is a legacy mode here in Unity. Most of the task of taking on animations and setting up behaviors has been taken over by Mecanim, but this is still useful for simple work. There's the rotation, and I'll go into the Curves menu in the Animation window, open up Rotation, and select my Y rotation. There's no rotation on X and Z, but as part of creating keyframes for rotation, I got them there. I'll leave them alone as they're not affecting anything, and go back to the Y rotation. The curve into 130 looks pretty good. It's a nice, smooth open on the door. However, back here at 0, the door kind of jerks into motion. It's basically a linear tangent there, and I'd like it to smooth out a bit. I'll pick that key and right-click on it, and I've got some options available. I can tell it to be free smooth, flat, broken, where the left and right tangents are independent. Or I can go into both tangents and choose how they operate. What I'll do is set this out as a flat or free smooth to start, and now I've got a Bezier handle available. This handle, or tangent, will let me manipulate this curve. It's already smoother because it's a slow in to that motion. I'll pull that handle down a little bit and just smooth out that motion, starting it a little bit slower even. If you're familiar with working in Maya, these tangents are locked. That means we can't extend them out. For those of you familiar with 3ds Max, you'll find that you expect the tangent handle to move freely and affect the weight, but in fact they're locked and simply affect direction. This is an important distinction to make here, in that if we can't get an animation good enough here, we should do it in another application and bring it in. However, for most things, this kind of subtlety we have available will work nicely, and so I've got a smooth animation into that door. Just keep that in mind, that there are programs that are built for animating. And if you're finding you're not getting the right results here in Unity, you can always bring in that animation. Now go look at the end. Scrolling back and going into that frame at 6. I'll select it, right-click, and choose Flat again. And that's going to flatten out that tangent, smoothing out that motion. Lastly, we can choose how our keys are behaving. If we're finding we'd like to work in step tangents or constant, to be able to block out an animation, we can do that. For example, I'll pick this key here at 430 and right-click, and I'll put the right tangent to constant. Now it holds that value and then drops into that motion. This is useful for blocking out an animation, or if we need something to change over one frame quickly. I'll return that tangent back, choosing right tangent and linear, and then flattening it out again. Now I've got some smooth motion in there, and my door will open, come to a nice stop and hold, and then close. We can animate just about anything we'd like here in Unity. We're not limited to animating simply objects and rotations and positions and so on. We can animate lights and materials if we'd like, really bringing our scene to life by turning on lights in our gallery, for example. I want to note that warning down on the bottom of my screen as well. It's in yellow, and it says the animation clip French Door 20 Swing, used by the animation component French Door 20, must be marked as legacy. What that simply says is that they've added in a new feature in recent versions of Unity called Mechanim, and although the animation component is perfectly fine to use and very good for simple things like this, for more complex animations and transitions between states, Mechanim with Animator components is available. It's a warning in yellow. It's not a showstopper in red. If it was in red, saying, for example, this syntax in the code doesn't work, we have to fix it before we compile. But a warning like that just says, wait a sec, note this, and if you need to do something about it, that's fine. I'll add a spotlight into that can light, choosing Game Object, Create Other, and Spotlight. I'll move my spotlight up and go into a bottom view to align it with the can. I'll click on the bottom arrow here on my view cube and switch over from a perspective to an orthographic view. I'll pull this light over, aligning as well as I can. I'll switch back to a perspective and orbit back around. That's pretty good. As long as it's fairly close, it'll be fine. I'll pull that light up just underneath that fixture. And that's an important one in lighting. When we're lighting, we need to make sure that our lights are not submerged in geometry. Otherwise, we'll have some very odd results. We'll get weird shadows and things. So just as a preemptive move to handle problems before they happen, we'll make sure the light is just below. We really can't tell once we see the circle on the floor exactly where it's coming from beyond generally that place. Now I'm going to make an animation for that light to turn on. I'll choose Window and Animation. And here I can create a new curve first or just start animating and name the curve as it's created. I'll go over to, let's say 130. And as soon as I do, Unity says, would you like to create a new animation? And I will, and I'll call it Spot Light On. And I'll put this in my Assets Animations folder. Now I'm ready to animate. For this light, I'll change that intensity. I'll crank up the intensity to, about 1.2 or so, and then come back here to frame 0 and pull that intensity almost all the way down. I'll put it in here at 0.1, so the light's just a little bit on. Now I can go into the curves and adjust those tangents if needed. I'll pull my animation window up, click on curves and take a look. And although it's a very slight adjustment, those are actually flat tangents. I'll pick both of those keys, right-click, and choose Flat. Now instead of a linear light turning on, it does a slow in and slow out, smoothly easing on in the scene. I'll pull this down and play that animation to see if it worked. There's the light turning on, and I'll adjust the spot angle of that light to be a little bit bigger, and my animation will be in good shape. I'll turn off the animation window so I don't animate that spot angle increasing. I'll pull this up to, about 55 or so, and it's just enough to catch that art. My light is animated, and I can trigger this animation and animations on other lights if needed through box colliders, just like with the French door. This way my player can, just in time to knock over the art, have the light come on. As a side note, if you'd like to explore more, we can animate materials as well. I'll look at the material on this object in the animation window. Bearing in mind, I need to have probably a separate material if there's other can lights that are always going to be on. But I'll at least check out what can I animate on the material itself. I'll pick that can light surface mount object, and we can see it's got two materials, lit bulb and brushed bronze. I'll go into my animation window and make another new curve. I've named this new anim file CanLight Matte On, CanLight Material On, and I'll save it in the Animations folder. Now I can add in a curve, clicking Add Curve, and under Mesh Renderer, there's my various material properties. Things like color, emission, illumination, reflection color, and so on. I'll pick Material Color and hit the plus next to it. Now in this material color, opening it up, I can animate the main color of this material to multiply over that self-illuminating light. I'm going to leave this alone for now. If you'd like to play with this, you can. We need to create a new material for CanLights that stay on, so bear that in mind when you're animating, that because it's a material animation, anything having this material will get that animation. I'm going to take off this animation here and just let that spotlight turn on, while the lights generally look lit, but we can only really tell if we're underneath them. A major new feature in recent releases of Unity is the Mecanim animation system. It's a terrific way to take in animation, break it up into different states, and designate transitions between those states. It lets us take in, for example, character animation, break it up into different animations mapped onto a character, and trigger them depending on events or inputs that we choose. It supersedes the animation component and provides a much easier way, actually, to get in and manipulate when animations happen, and also what comes after each one. I've made a few additions to the gallery. I've put in both wall solid, wall hex, and wall waves. The wall solid objects are the walls where the art is actually mounted. We can see them here in this building, and there's similar walls in all the others. I've also placed the art onto those walls, so that now when we walk around, we have a fairly populated gallery. The wall stagger and wall waves objects are walls that'll pop in. I'll turn them on here in the inspector, and we can just see their outlines below the floor. Switching to a wireframe shows those objects, and they're ready to move up an exact 5 meters to pop into place depending on how they're triggered. I'll turn these off again, and turn off the stagger and waves too. Now I'm ready to bring in my Waiting Emma's sculpture. It's a sculpture of 3 women waiting for perhaps a bus. It's based roughly on the Waiting for the Interurban sculpture found in the Fremont area of Seattle. I've imported that FBX into the Meshes folder, and there's my Waiting Emmas. I'll open up the inspector a little bit and press play on the preview. The middle Emma raises her hand, and then pauses, and then we'll look over, stop, and look back. I want to break up these animations into 2 parts here, and that way I can have a wave or a head turn triggered by the player. What we can see here in the inspector is that the Model tab is, well, as it has been. It concerns importing things, generating colliders, scale factor, and so on. The Rig tab then, when we're bringing in an animation, deals with what kind of a rig it is. Are we dealing in a generic rig? Are we dealing in a humanoid or a legacy? Humanoid maps very nicely to Human IK in Maya and Cat rigs and Character Studio rigs in 3ds Max, and allows us to take an animation from one character and define it, map it onto another. The Animations tab then is where we'll start to break up these pieces, or this take, into frames and apply it in different places. I'll rename Take 1 to Start, calling it Handwave. I'll scroll down, and what it says here is that the clip range is outside of the range of the source take. I'll check Clamp Range, and now my start and end correspond to the frame range of that animation. This clip, Handwave, actually takes place from frame 0 to 120, so I'll put the end range in at 120. Now it's clamped down, and I'll make another one. I'll click the plus here on the clips, name this clip from Take 1 over to Head Turn, and then I'll set the range for Head Turn. Head Turn again gives me that message. The clip range is outside of the range of the source take. I'll clamp down that range and start out Head Turn at 140. I'll test this out, previewing this one clip, clicking and dragging to see it, and pressing play. There's the head turn, isolated down nicely. And if we select the other clip, Handwave, and press play, we'll see just that handwave. It's supposed to be a stiff mechanical motion. This is a sculpture that's come to life just enough to notice the player. Now I'll get this into Mecanim. I'll take my Waiting Emmas, select them here in the meshes, and drag them into my scene. I'm going to put the Waiting Emmas right in the middle here of this floor. I'll apply those settings and give it a minute to import. I'll focus in on the Waiting Emmas, and what we can see here is that they are in the scene, facing to the back or facing to look out the windows, and ready to move. We have an animator controller on them already, but we actually need to get a separate controller in that animator. In Assets, I'll right-click and choose Create and Animator Controller. This new animator controller then allows us to bring this into Mecanim, and I'll call this controller Waiting Emmas. It's in my Meshes section, and now I can pick those emmas, and here in their Animator component, choose from the Assets the Waiting Emmas controller. Now I can open them up in the Animator window, clicking on the Animator tab or choosing Window and Animator. I'll select my Waiting Emmas, and now I can get them into the base layer in Mecanim. In my Animator window, then, I can start to break up their animations and set up the transitions between. When we're segmenting an animation in Mecanim, we need an Animator controller so we can view that object in the Animator window. I'll select my Waiting Emmas, and there's their Animator controller called Waiting Emmas, and now I can view it here. What I'll do to make those Waiting Emmas wave and turn their heads is to create states here in the Animator. I'll right-click, choose Create State and Empty. I'll name this first new state Head Turn up here in the inspector. For this state, I'll go into the Motion and go pick that animation. In the Assets folder, there's the Head Turn animation, and I'll select it. Now I'll make a new state for the hand wave. Right-clicking, choosing Create State and Empty. I'll pick my new empty state and name it over here to Hand Wave. Now I'll get the motion in that hand wave state, again by clicking on the Pick button, going to the Assets section, and picking Hand Wave. I need one more state here. What I've got right now is an any state, meaning start from anywhere. I've got Head Turn and Hand Wave, but I need an idle. Otherwise, we'd transition just between Head Turn and Hand Wave, and it would look odd because there's no downtime, no wait. In an idle state, characters will often stand, maybe shift from hip to hip, blink, and maybe look around or look at their watch. It's a neutral, and then we can add other motions onto it. Emma's neutral is perfectly still. So what I'll do is go grab frames that are between the other two states as my idle. This way, when I transition back to idle from either head turn or hand wave, she's perfectly still. First, I'll make a new idle state by right-clicking, choosing Create State and Empty. I'll name this new state Still Idle. Now I'll go back into the Meshes folder, reselect the Emma's FBX, and add in one more clip. Here in Meshes, I'll select my Waiting Emmas and make sure I have the right one by selecting the FBX. If you notice here, I had made an animator controller called Waiting Emmas, and it's got a different icon than the FBX. Now in the animation section of the inspector for the Waiting Emmas, I'll make one more clip. Clicking on the plus sign and making a new take, I'll rename it to Still Idle. And now I'll set out a frame range, again clamping that range and putting in a start of 125 and an end of 130. This should leave her still, and I'll check in the preview. It's looping very fast, but there's no motion in there, so it's a good idle for my statues. Now I'll go back into my animator, again picking head turn, applying those settings, then choosing Still Idle. It's fine to jump around like that. I clicked on, well, something, and it said, do you want to apply what you've done? And I said yes, and then I'll go pick the correct one. Now here in Still Idle, I'll go into the motion, and in the assets, there's that motion available. Here's Still Idle. There's some default poses and animations that come with Unity, such as jump pose, run, and walk, and we can map these onto a character if we need. Now that I've got my state set out, I'm ready for transitions, and I can start to knit these together and then add in parameters to be able to change between them. Now that we've got states created in Mecanim, we can start to make transitions between and eventually script in some kind of interactivity for our character. We can do things like have that transition occur between states depending on characters' proximity or tags. Before I get into that, though, I'd like to look at something that's been noticeable and maybe a little nagging in the scene. As you can see, I've got open an any state in the animator with a French door 20 swing. At some point I had created this animation, and basically what we're seeing is that the default state for that French door number 20 is to swing. And that's why that door is opening and closing and opening and closing. Because there's no state set and no transition to, well, anything else, we end up seeing that animation over and over. I'm going to delete this animator controller off the door, as I'm controlling those doors through an activate trigger on a box collider. Now I'll look at my Waiting Emmas. I'll scroll down here, and select the waiting emmas in the hierarchy. I've got my states set up, and I'm going to set up a simple loop here, running between still idle and a head turn. What I'll do is to pick still idle, right-click, and choose Set as Default. This way, the first thing from an any state that Mecanim goes to is Emma idling, just standing there. Now I'll make a transition, picking any state, right-clicking, choosing Make Transition, and dragging onto still idle. Then I'll pick still idle, right-click, Make Transition, and head turn. From head turn, I'll right-click and make transition back to still idle. She'll idle for a sec, turn her head, then idle. It'll animate just enough we can gauge the repetitive motion and see if this is working. Now look at the transitions themselves. What happens is that the transition is governed by an exit time between events. What we can see here is that the exit time is 92% from head turn to still idle. That is, when head turn is 92% played, it will start to fade out and still idle will fade back in. We can adjust these transitions by dragging on the markers here on the timeline to pull those back and together. I'll run it so that it starts at 95 and out to 100, and then I'll look at the still idle to head turn transition as well. This one starts at 0 and transitions out to head turn. We can either leave it alone or stretch them out further. I'm going to pull over head turn a little bit, move the timeline over, and stretch out the markers just a bit. Now I'll pull out head turn so that it barely overlaps. There's just a little fade of head turn, which is slow anyway, and we hold our still idle just a bit. I'll try this out and see how it looks. I can always add in more states and more conditions in our parameters. If you'd like to explore it further, in our parameters, we've got float, int, bool, and trigger. Float accepting a floating point number, or integer, an integer, or enum. Boolean accepts, well, a yes or no, like a Boolean. And finally, a trigger can be a triggered event. I'd highly recommend Sue Blackman's course on Mecanim in Unity as a terrific way to get deep in the inner workings of making Mecanim and characters really come to life. For this course, though, we'll look at just having this character's head turn, and just enough that it's noticeable the statue looks over at us. I'll test this out by going into my game and playing, and I'll navigate over and see if it turns, looks, and turns again. Here in my scene, I'll scroll forward, and there's the statue looking over, looking back and pausing, looking over, looking back and pausing. It's working terrifically. The transition is working, and I've set up my first tree in Mecanim. I'm ready to add in more states and more behaviors with additional scripting work. Now I'm ready to light up the space. I'll get the sunlight streaming in through the windows and turn on the can lights, and look at both light baking and light probes, as well as working with all dynamic light and see what the differences are. Lighting can really bring a game to life. Bad lighting can really make even terrific models and textures look terrible. And so we need to think of lighting as the final polish all the way through that can really make our environment sparkle. To start in my lighting, I'll consider the ambient light or general scene tone. Then I'll work through the other kind of lights, my sun, and finally my can lights and other spots in the building. I'll begin by deleting my working lights and turning off my sun. I'll start out with my point lights, selecting both of them by picking one and hitting Control and pressing Delete. Then I'll pick that spotlight that I had animated. I'm not sure if I'm going to keep it, so for the moment I'll just turn down its intensity. Then I'll pick the sun, my directional light, and for this one I'll turn down the intensity as well. Now I'm running in a gray world, and I'll switch over to my scene view to see how it looks. I'll switch my view to textured and turn on the lighting. It's, well, ambient, as you'd expect. Everything is exactly ambiently lit with no other light sources. Now I'll choose Edit and Render Settings to look at my ambient light. I had put in my ambient light earlier, a soft gray. I'll tune this up a little bit. This is supposed to be a warm lit scene with warm sun coming in, and I'm going to reinforce this with my ambient light. I'll swing the hue over into the 30 range or so, and bring up saturation just a little bit, maybe 4 or 5 points. I'll leave the value low, and this is just the general lighting in the scene, lighting up the dimly lit areas, adding a little bit of scene tone in. There's different schools of thought in this. Some say you should use a complementary light in the ambient. If your sunlight is warm in the oranges, your ambient light should be blue. However, I think that adds a little too much blue tone and hence fear into this scene. I'll show what it looks like just so you can see. When I crank over that hue into the blue range and pull up saturation a little bit, we do start to get a blue tone in the scene. This is neat but it'll mute down any warmth of the sun and add fear in the shadows, and I'm not sure I want to introduce that in the viewer's mind. So I'll click on that ambient light and swing that hue back into the warm range. Now, if you're looking at this going, gee, that's gray. Well, yes, it is, but remember with lighting, a little goes a long way. And the way we want to think of our lighting is it's a bunch of small pushes from a bunch of directions to get in a general area. It's not one giant move, such as cranking up the saturation, to get the whole lighting right. That introduces, in this case, a rusty orange in everything, and mutes out any subtlety in the colors I've painted. So I'll make sure I back off the saturation, keeping it very low, let's say down in the 10 range here, and leave that hue in the 30s. It's a barely warm gray that adds a little bit of warmth in the general light in the scene before I introduce in any practical lights. When we're lighting a scene, we should start with the biggest, most prominent light first, and really get that established, and then let the other lights fill in the smaller spaces. For us in this scene, because we're working in daylight, the biggest light we're going to use is the sun. We've put one in as a working sun, a directional light, and we'll modify this, get it aimed correctly, and get the color tinted for our warm afternoon sun. What I'll do first is to zoom out, select that light, and move it in a little closer. It's way out in space, and when I select it here and press F to focus, we can see how far out it is. What I'll do is hold V for snap and just snap that light onto a building. Then when I zoom out, I can frame in my entire structure and my light without being way out in space. With that directional light selected, I'll pull it up. With a directional light, it matters where it's pointing, not where it is. Really, I can have this anywhere I want. It's infinitely wide. We can also consider it as having overshoot on, if you're familiar with directional lights from 3ds Max, for example. That is, the size of the light is infinitely big, or we can consider it as just always having parallel rays that way. Whichever way you want to think of it. Again, it matters which way it's pointing, and we can see that by those rays coming off the transform. If you need to make a new directional light, you can always choose Game Object, Create Other, and Directional Light, but I'll reuse this one. First, I'll name this light. I'll call it Sun, and this way I can recognize it easily. Now I'll rotate it. What I look for in a light when I'm rotating it over is that it's coming in diagonally in two views, that in a front or a side view, the light is streaming in diagonally, and that in a top view or bottom view, it's coming in diagonal. Then I look at the major windows in the scene. I'll switch over to a wireframe and look where the windows are. The back building actually has the most windows, and so as long as the light is coming in through most of these, we should be okay. This front building with the spawn point in it has windows on the, it could be the south or east side, depending on which way it's rotated. So again, as long as the sun streams in through those balconies, we'll be fine. This last building has mostly a solid wall presented to those same directions we'll have the light coming in. So we'll get some good sun shafts coming through some of the windows, and we'll do our best, but some of it may be in the shadow. Now I'll adjust my light. Again, I'll go in a top view and rotate it over, pressing E to rotate and using the global rotation for the tool handle. I'll spin this over a little bit, making sure it's not at a 45. Then I'll go back either in a front view or just orbit down and line this up as low as I can. I want those sunbeams to slink in through the windows, reach across the floor, and slide up the opposing wall. And I want to think of it in those very lush terms, actually. It may sound odd to think of it that way, but as directors of photography, we want to think of light as our actor we're directing. We need to add the feeling through the light in the space, so the audience, the players, are presented with a mood before anything happens. Now I'll turn on my textured view and crank up the intensity of this light. I'll put it back to about 1.1 or so, and then I'll click on the light color. Right now it's white, and it can look a little bit cold. What I'll typically do is bias it just a little bit towards a warm yellow. Again, with a hue in the 35 range will work, and here's a saturation of a grand 5. Now, it may look like, just another pale white, and it is, but it has a little bias in that color. Remember that with lighting, lots of little nudges get us in the direction we want to go. We can't just take this light and make it orange and have it look nice. It'll be, orange in our scene. I'll check this out before I adjust the shadow quality. Pressing play and taking a look in my game. I've got some pretty good reach in the sunbeams. especially right here, running around the Emmas and into the lobby. I can see I've got all that shadow play from those window mullions coming in, across the balcony, and all the way through. In this space, where it's mostly got walls in it, it's fairly dark, and so I'll need some interior lighting. This window doesn't have a lot going on. I think it's just out of view enough that we're not seeing enough of a sun shaft, because there's a little bit of one just on the sill. All in all, though, this looks pretty good. I'm getting a good shadow on the opposing buildings and some light coming in. The building across the way through the bridge also has sun streaming in those windows, and so I feel like it's in a pretty good place. I'm going to warm it up and dim it down just a little bit more, and my directional light from my sun should be set. I'll take this light back, pulling back the intensity to 0.9, and then I'll add a little more saturation in that color. It's still a pale orange with a saturation at 15. The value's up, and I'm just introducing a little warmth in there. I'll try it one more time. I'm really starting to see how the combination of the ambient light and the directional light is blowing out some of the surfaces. That's a little better. It's still a little hot on some of the brick because of the specularity, but I actually kind of like that little glow there. I've got soft, warm sun streaming in those windows. Even with the aliasing going on because I haven't upped the quality, I like the way it's looking on the wood floor and across that brick paving. Nothing in here is terribly blown out except for just that shine, and again, that looks pretty reasonable. It's okay to see some things be a little bit hot, and it kind of reinforces how decent the shadows look. After we get that major light in, the directional, we can start to work on our interior lights, our points and spots. Lighting for real-time applications has its own set of constraints, as different from rendering for visual effects, for example. In a rendering for a composite or a visual effect, I'll use as many lights as I need, putting in 50, 60, 70 lights that hit everything and bounce subtly off all the different surfaces. For games, I'm limited down to the number of lights I can display on an object, and anything beyond 8 really doesn't get shown. It's a DirectX-derived limit, where we simply are maxing out what we can do and show in real time on one surface. Some organization will really help here. The sun really needs to hit most everything, but beyond that, all the lights in one building don't need to touch the other buildings, and we can even limit them down further. So I'll set up some layers for my building's interiors that I can exclude from the other building's lights. What I'll do first is to go in and hide the roofs and the podium, zooming in the scene, selecting the roof, and turning off the visibility. With both roofs off, I'll hide the floor as well, and this is really so I don't accidentally select it. Now I'm ready to make some layers. For these buildings, I've got brick walls that really don't need to get hit by the interior lights at all. What I'll do is to select the brick walls on this first building here, picking one, holding Control and adding to that selection. And I'll drop down under the layers in the inspector and choose Add Layer. I'll put in under User Layer 8, Building A, Brick. This layer is now available to add those pieces to. When I select these objects then, I can drop down in the layer and choose Building A Brick. Later when I light, I can tell lights they cannot hit this, and thereby eliminate some of the things the lights need to think about. I'll work my way around this building, first adding that brick in, selecting it, holding Control to add to the selection, and changing the layer. Now that I've got the brick in Building A selected and on a layer I can find and exclude, I'll set up the interiors. I'll pick one of my interior walls and hold Control and add to that selection. It's important to make sure you have just those objects you want selected, because it's very easy to pick the entire nested bunch of prefabs. I'll pick this wall, drop down the layers, and choose Add Layer. In the layers, I'll call this one Building A Interior. Now I'll add the rest of the interior walls to this layer, picking them and choosing under Layer, Building A Interior. If you can pick a couple objects at a time and be able to select them consistently, that's fantastic. I end up being fairly deliberate and going through and grabbing just the ones I can see and grab easily, so I don't select anything else accidentally. I'll put on the cruciform columns and finally make sure I have the interior of the exterior walls. I've tagged all the interior walls and window frames, but not the glass, with the layer Building A Interior. I've also put the art onto it. If I missed something, I can always go back and add it later. But now I can tell lights, you are exclusive to Building A interior. What I'll do is go through and tag the rest of the objects with their own building tags. Interior and exterior for building B and C. And this way, I can limit down very specifically which objects are affected by which interior lights. I've run through and tagged everything with either interior or exterior for its own building. I've also added the podiums into the tag, those floors and their surrounding walkways. This one, for example, is Building A interior. What I've done in the layers is to make an interior and exterior building plus bridge layers, and this way I can sort things out very efficiently for lighting. I've also gone into that spotlight that I had animated earlier and disabled that default state or first play in the animator. Now it just has an any state, and instead of cycling off and on, this light will just stay on. I'll pull up the intensity and get it looking pretty reasonable. Here's an intensity of, around 1.5, and I'll crank out the size of that spot. A spotlight in Unity, then, is a cone of light, starting out from the transform and aiming straight down. It's got a spot angle, which, if you're looking for the controls from Maya, for example, for cone, penumbra, and drop-off, they're all included in here. That cone simply gets fuzzier as that light spreads out, and so we don't have to think about those factors together. A spotlight will also accept a cookie. It's an image with an alpha channel we can place over it to affect the shape of the light, adding a grid for a diffuser, for example. Finally, if needed, we can turn on shadows, and these are accessible when we bake the light. We can cull this light down, and right now it's hitting everything. That culling mask is very important, because the culling mask for this light lets us ignore different things. We can tell this light, you can only hit Building A interior, for example, and it simply won't think about the other pieces. I'll turn off everything for this light by checking Nothing, and then dropping down in the culling mask and choosing Building A interior. Now the light hits that floor, and I'll adjust the range and then clone it around. The range on a light is the equivalent to attenuation in 3ds Max. This is an absolute range on the light, after which it ceases exactly. This range is in meters, and so if we scroll this range back, pulling it back here, we can see that light decrease. I'll pull that range out, somewhere in the 7.5 range, so it actually does go through the floor, but hits it very nicely and leaves a warm pool of light around those sculptures. Now I'll nest this light under its can light, and then clone this around my space. That can light is called Can Light Surface Mount. And right now, it's on, well, the default layer. I'm going to make this particular one as well, Building A interior. Now I'll take this light and drag it under that can light, so it's parented under it. Now when I select one, they'll both select. I'm ready to clone this light around. I'll turn off the scene lighting so I can see what I'm doing a bit, go in under the ceiling, and press Ctrl-D to duplicate. I'll pull this light over on the X-axis into the next bay, making sure it glances on the walls. Then I'll duplicate again, pressing Ctrl-D, and put the next light in right over that next painting, making sure I grab the right axis, of course. You can always toggle on your lights and see if they're hitting things correctly. I'll pull this one back and up next to the art. This might be a place later to make some kind of aimable light, as it's kind of difficult to get the light to hit that painting. But at least giving me a good pool on the floor will work nicely. We're starting to see a limit on the objects here, how much that light can actually hit, and so I need to be careful of what I need to see on the floor here. I'll duplicate one or two more, and pull it over. We can see because the floor is one big object that the lights are having a harder and harder time showing on it. I can hit the walls just fine, and will hit anything in them. After a while, that rule of 8 is rearing its head. Now I've got can lights in the space, and I'm ready for some point lights for fill. What we want to do is to get our direct or practical lights in first, our sun, and then our interior fixtures, and make sure they look like they're on. Then we can get in there and add our theatrical lighting, our fills, and extra light to really buff out the space. Using the layers and tags is very important. We haven't tagged anything yet, but it'll be helpful in sorting out minor lighting issues. For now, though, being able to restrict down just to layers is immensely helpful, and that way these lights can only hit certain things. Now that I've got spotlights in my scene, I'm ready to get some point lights in for fill. We can really see where we run into some limitations in lights. This floor object has a limit of 8 lights on it, And being that it's already being hit by the sun and the others, we started to see that last light in the left corner really not show. Now what we can do in this is to tell different lights to be more important, and that may help in the lighting. For example, I'll pick this spot that's not showing up on the floor, and in the inspector, under Light, I have a render mode. The render mode then for auto chooses the lights in order of creation and displays them as well as possible. If I switch this over to important, that light displays and the one next to it winks off. Being that this light is not hitting anything directly, I'm going to leave it alone as auto and put a point light in the scene to fill this space. I'll choose Game Object, Create Other, and Point Light. A point then is a soft fill light in a sphere. It originates from the transform and goes equally in all directions. It's very easy with a point light to get a burn on the ceiling like I've got, so I need to use this judiciously. With lighting, keep in mind that it's perfectly fine to have dim, dark gray lights if they work correctly. So don't be afraid to really push around the values. Right now that's setting my ceiling on fire, and I'd like to avoid that. I'll pull this light back into that space, and the first thing I'll do with a point light is to crank down the range. We can see its range here as a large sphere, and I'll pull that range down around the maybe 6 range. Back off the intensity and back off the color. With a little more intensity, I can tell this light you can only hit certain things and have it gently fill that space. I'll make this only able to hit Building A interior, and I'll tag this light in the render mode as important. Now it's gently softly lit in here, and it looks pretty decent. A couple more of these, all set to important, will really perk up the space. I'll duplicate it by pressing Ctrl D and slide the duplicate into the next area. For this, I'll pull down the range just a little and crank up the intensity just a touch, giving it a little more luminance in there even though it's gray. I'll add one more up front by pressing Ctrl D and sliding that over again. I'll put one more up front by the Emmas, again pressing Ctrl D and pulling this light forward. I'm going to make the spotlight that's over the movable sculpture important, so I'll make sure that the Emmas are all lit by some point lights so they show up. I don't mind if the gallery is a little murky. I can always boost up the ambient or crank up these lights as needed, but I want to get all my lights really in before I start adjusting. I like the way it's looking. My gallery has decent lighting, and I'm going to go through and tag these point lights as important. I'll pick all of them, and they're all instancing types here. They're not prefabs necessarily, but because they're all the same object type, available parameters show up as instances. I'll make sure their render mode is important, and that way they'll all show decently in the space and give me a soft light. I'll play this and see how it looks. My gallery is looking decent, and there's Emma turning. I've got the poles showing, good wall coverage, spotlights overhead, and there's enough light going on I believe that this space is lit. I need to make my sun important and hit everything, and while I'm at it, I can knock over the sculpture and see it in full light. There's a rigid body on that wall which helps it fall over, and coming into the rest of the space, I can definitely see where I've got decent lighting going. Those point lights could use a little adjusting, but I like the way they're hitting all the walls. I definitely am going to start to need some additional light on the art, and some of it could use a little rescaling. It's the start of reasonable lighting in the space. We're at least able to get around, see where we are, and tell where the corners of the rooms are. We can always add more lights, adjusting them to be important or not, and adding different layers in to be able to tag certain specific objects if we need. Shadows are an essential part of lighting, but we have to make some judgment calls over what is acceptable in our shadows. Casting and calculating real-time shadows is enormously computationally intensive, and so we need to be very careful about what lights cast shadows and what kind of shadows they are. Right now, the only shadows I have are those from the sun coming into the space and actually shadowing off the roof and inside this building. I'll look at my sun first and adjust the shadow quality, and then I'll see if there's any other lights I can put shadows on. I'll select my sun, scrolling down in the hierarchy and picking the sun, and right now it's set to soft shadows with the default quality settings. I'll zoom in over by the balcony and take a look at how these lights are behaving. Soft shadows are the ideal. They spread out as natural light does and have the appearance of the light diffusing and light bouncing into the shadow correctly. They're computationally fairly expensive, and so we want to use them very carefully. We have hard shadows as well, and the difference is that hard shadows are, as the name suggests, hard. They are as crisp as possible given the quality settings from the start of the shadow all the way out. And it's really a judgment call in the look we want versus a physically correct shadow one way or another. We may want the game to be very hard-edged and our shadows to be very crisp, in this case throwing in sharp relief the pattern from the window mullions onto the floor. For this game, though, I want it to be softer and warmer, so I'll choose soft shadows and let those shadows fuzz out. It's using shadow map or depth map shadows, where it's approximating the spread and fuzz of a natural shadow by calculating that shadow in RAM and then projecting it forward. For our shadows then, we can choose in here different quality settings, and we want to balance the quality we're using versus the computational hit. Very high resolution shadows look terrific, but are more overhead to think through and may slow down the game. I'm going to leave my sun at high resolution, but then I'll play with the softness and softness fade. Within our soft shadows then, softness at 0 gives us a very crisp shadow. Softness all the way up fuzzes that shadow out completely. I'll put this down about 2.5 or so it's got a little spread to it without being excessively fuzzy. The softness fade then is the edge of that shadow, how diffuse it is or how crisp. Again, pulling softness fade all the way back results in a crisp but aliased shadow. I'll pull mine up in the 1.5, almost 2 range. And finally, there's bias. Bias relates to the shadow map, and what that does is it says if that shadow is bleeding around the front of the object because it's approximating the fuzz of a shadow, push it forward. I'm going to leave the bias alone, but I'll crank it up temporarily just to show what it looks like when you adjust it. I'll zoom in on the window frame, and right now it looks roughly so like those shadows are coming from the frame. We are getting a bit of an artifact right here around the base, where there's a little bit of a spread in the shadow. Pulling that bias around may push that shadow out too much, but it may avoid a shadow bleed around the front of those objects. Pulling bias down to 0 then may wrap the shadow around the front of that window frame. And so a little bit of bias in here, 0.05, 0.07, is just enough to push that shadow forward. In this case, even 0.07 is too much. I'll pull that back down, and it looks about as good as I'm going to get. The shadow strength, finally, is the opacity of our shadow. By default at 1, they're very hard and very black. I'm going to pull this back, and what I'm doing here with the shadow, in addition to just simply lowering the strength value, is simulating the bounce of light into the shadow from adjacent objects. Light bounces in the world, and when light bounces off objects into shadows, the shadows appear lighter. And so we can use our shadow strength to soften a rendering. So we don't have heavy black shadows. We have darker shadows plus the color of the material they're over. And we can get a good adjustment in here. I'll click play and see how this looks, and run around the scene a bit. My shadow quality is looking decent. I've got a little bit of dottiness going on, but it's not terrible. I can live with it, and I'm planning to blur this later. I also haven't increased my quality settings, so I'm still seeing some aliasing. Some better anti-aliasing, a little glow, color correction, and depth of field in the image effects will help smooth this out. The shadows look pretty good, and inside my scene is holding up nicely. I've got decent light overall, some lights spotting the ceiling here and there, and decent light in the volumes. What I may end up wanting to do as a side note on this is take that ceiling and put it on its own layer and use a different light to aim up and light up just the ceiling, leaving the point lights free to just hit the walls in Building Interior A. For now though, I like how my gallery is going. I've got good value in the lighting, and I can definitely see the can lights, and I feel like they're contributing to the light. Cookies in Unity are images that are placed over a light to change the shape of the light. If you've noticed, we've got 3 basic light types to use, and their shapes are fairly limited. There's points, which are spheres of light, directional lights that run fairly parallel and simulate suns well, and spotlights, which yield even cones of light. In order to make the light vary, we'll place a cookie over a light, and this is analogous to what we do in real-world theatrical lighting. placing a pattern over a light to simulate the cast of light on an object and project forward either a shadow or a cutout of that light. Cookies are useful, for example, for projecting leaf shadows onto the ground, sparing you from making all the different trees to cast shadow through, and instead cutting straight to the dappled shadows. I'll put a cookie to start on my sun. In this case, I'm going to use a cookie to simulate the varied sunlight from the clouds to match my skybox. We can also use cookies inside, simulating different kinds of diffusers or shaping the lights. Light fixtures come in all sizes and shapes and colors. Right now I'm working under a fairly linear desk lamp, for example, and there are 3 cones in the corner. Outside are some larger cones and a sphere. We've got all kinds of lights available, and so we need to have a tool in our tool bag to be able to simulate that fairly cheaply. What I've done then is to place in the Textures folder a new image, and it's called Clouds. Cookies then are typically grayscale images with an alpha channel, where it's usually the same image in the color and the alpha. To make this into a cookie, what I'll do is in the texture type, drop down under Texture and choose Cookie. This tags it as a cookie, and I can specify it for a specific kind of light. I'll drop down under Light Type and pick Directional, and then I'll hit Apply. I'm going to leave the max size alone, as this is already 512 square. Now that that's made as a cookie, I can see it when I choose a cookie in my sun. What I'll do, though, to add some variety to the light, but still keep my shadows, is to duplicate that sun. I'll pick my existing sun and back off the intensity just a little bit, maybe 0.8. Then I'll pick it and press Ctrl-D to duplicate, and name this new sun Sun Clouds. Now I'll take this new sun and turn off the shadows. It's going to brighten up my scene considerably, but I'll adjust the luminance in a minute. First, though, I'll pick my cookie, clicking on the Pick button next to the cookie texture. And in here in the assets, I'll type in CL to filter down for clouds. And there's my Clouds cookie. With it selected, it casts that dappled pattern over my scene, adding a subtle variation to things. I'll lower down the intensity of this light, and I get that soft sun coming in, and we can perceive, especially on the balcony, a little bit of variety across that surface. As we pan around and look outside, we can see some minor drama going on in the lighting on the bridge, and that's the result of that cloud shadow in the sun. We need to be careful with cookies because it's very easy to end up with dark rings from them or odd light areas. So often I'll use a cookie for general mood like this, and then back off the intensity of both lights because I'm doubling the sun. What I'll do then is use a cookie as well for diffusers on a light, for example, to square off a light and let it come through a surface in a different shape than a standard cone. You can make any kind of cookie you'd like, and putting them in is as easy as choosing the type and putting in that light. I'll back off the intensity just a little more, down to 0.2 for my cookie. And now it's just the tiniest bit of subtlety, which we can really see up here on the roof. Try making a cookie of your own and putting it in the scene. You may even want to use a cookie to focus down or spread out a spotlight a little bit for your can lights, or use a cookie to add some variety into the point lights so they're not so obvious spheres of light in the scene. In Unity, scripting provides a powerful toolset to extend and enhance the functionality of the game. We can even extend and enhance the functionality of Unity itself, and it supports 3 different scripting languages plus a shader language to do so. To attach a script to a game object, like we did with the first-person controller, we can simply drag it in as a component. I'll put a new, blank script on one of my objects to start out. For example, I'll pick the master building and add a component. In the components, I'll choose New Script, and I've got some different languages available. Unity supports JavaScript, C#, and Boo, which is a Python variant. I'll choose JavaScript, for example, and name this new script Sync. Now I've got a new script on this game object master building. The new script is noted with a JS icon next to the name Sync, and that shows that it's a JavaScript. The script then is chosen, called Sync, and if I add any other functionality, it'll show up there. We can edit this script then in MonoDevelop, either double-clicking on it in the Assets folder or dropping down here under the gear and choosing Edit Script. MonoDevelop is a powerful scripting program that ships with Unity and supports multiple languages. It also supports code hinting and syntax coloring. It'll help you along as much as it can and really let you get in and get the best out of your scripting. What this says, for example, now, is that when the game starts, function start, do something, in this case nothing. And then update, every frame, do something, and again, nothing. We're ready to add pieces into this script, and it's that simple to attach scripts to an object. We can either make scripts by choosing new components, or we can make a new script right in the Assets window and then drag it onto an object. I'll close this script, sync in MonoDevelop, and come back and look at creating a new script. I'll right-click in the Assets window and choose Create, and here's a C#. I'll name this C# Rise. And there's that C# script selected in the inspector, showing, well, what's going on so far. In this case, void start, nothing, and void update, nothing. When it starts out the game, initializes, do something, and once per frame, do something. That's the basics of it. We can make a script to do just about anything we'd like. Anything from calling animations through extending functionality when a character collides with something. If you've used a first-person controller, you're already using scripts, and it's that simple to get them implemented. There's no limit to what you can do with a script, so get in and explore, and start to make scripts that enhance the functionality of your game. Using the right syntax in your scripting is highly important. Your script simply won't work, and your game won't compile if there's errors in the code. And so you need to get this right so that, well, you can build the game. One of the things to do to avoid some confusion is stick with one kind of scripting wherever possible. For example, if you start in C#, stay with C#. If you're running JavaScript, run JavaScript all the way through. Consistency will help, because that way the term, syntax, and naming is the same in every script. Although you can mix, and we often do see a mix, for example on the first-person controller, I'd highly recommend that you stay in one language. We can see that our first-person controller has a C# and 3 Javas on it. I'll open up one of the scripts that comes with Unity, the Activate trigger, and look a little bit at the syntax, and see why this is such a big deal. In the Assets, I'll go under Standard Assets, and then into Scripts. In Scripts, in General Scripts, there's my Activate trigger and Drag rigid body. I'll double-click on Activate trigger to open it up. Unity has opened up that trigger script in MonoDevelop, and we can see it's a C# script by the extension .cs. What it says then, for example, right up at the top is using Unity Engine, semicolon. That's a perfect example of scripting syntax and how we need to keep this straight. It's declaring right off the bat that we are using the Unity Engine and the line is ending with a semicolon. In the next section down, there's a public class, Activate trigger, which is a monobehavior. And within that, those curly braces, a public enum, and there's a mode available. What this basically lets us do is say, what kind of trigger would you like? An enum refers to a drop-down list. We can see in here as well that the code is colored and hinted, and when we're writing code in MonoDevelop, we'll get hinting and auto-completion of our different words to help us with the syntax. We need to make sure then that we're encasing in curly braces at the start and end things that should be encapsulated, that we're ending our lines with semicolons, that we're commenting out our lines as well, the double slash for commenting a section and the triple for commenting an entire line or paragraph. As we look farther down, we can see that this is affecting public game objects and allowing us to choose different ones. It's also got cases in here within the void do activate trigger inside the curly braces if different things are happening. For example, if the trigger count is 0 and it's a repeat trigger, what happens if the object hits something? What happens to the behavior? Who's the game object target? If we're switching around, switching cases, what happens? Are we replacing and so on? What they've done here then, for example, is to say, when we're activating the trigger, all of this goes on. And sometimes there's even some other pieces. For example, in replace, if the source is null, do that. And we can see that the lines are tabbed in so that we get all the different situations encapsulated in their braces, and lines are ended with a semicolon. Finally, at the bottom, we can see that there's the end braces, ending all the different levels of encapsulation. It's important to make sure that the lines are ended with semicolons and that we're using the right kind of language. For example, at the bottom it says case mode.deactivate. We'll see a lot of this, a dot syntax, which is very common in all kinds of scripting languages. Really just saying, for the case mode deactivate, do something. At the end of it, we've got a semicolon, and then finally it's enclosed in the rest of those curly braces. At the bottom then, we're going to see, now that we've declared all the stuff we're going to do, enter the trigger and do something. So all of what's up here, inside those curly braces, is what happens when we do activate the trigger. I can't stress this one enough. You need to be as organized in your code as you are in your assets. So make sure that you're sticking with one language and take the time to get to know the ins and outs of it. Make sure you've got consistent naming conventions and that you're commenting out your scripts as much as possible. It's very reasonable, again, that you'll work on this script, implement it, and not touch it for 6 months, and then come back to it and say, what was I doing? And so if you've got any kind of hints in there, that'll be immensely helpful. It's also very likely, especially if you're in a small team, let's say on a mobile game, that you and 3 other people will be working together and sharing scripts freely. And you need to be able to hand off a script to somebody and have them be able to read it without saying, what was he thinking? What we may end up doing then is attaching scripts to blank game objects or other game objects with meshes associated, doing things like the simple ones, activating doors, or looking for things for score. We may even turn off and on gravity in a rigid body so things don't fall until we contact them, and then they run away. We can do all sorts of things here in the scripts, including making new custom materials, putting in new colors and new kinds of properties such as rim shade or rim power to be able to get edge-lit surfaces. I want to encourage you to go as far as you can with your scripting. For this course, we're purposefully staying light on the scripting, putting in the interactivity we can without getting too deep in the code. There's so much we can do with it that it's really a course on its own. So make sure you check back on lynda.com for courses on Unity scripting. In the meantime, if you'd like more resources, one of the most exciting new developments in Unity 4.3 is the new 2D engine. It's a 2D game engine inside Unity, and it works just the same as the 3D, except you're missing your Z-axis. You get all the physics you expect, the scripting still ties in, and everything works, well, exactly like the 3D world, except you're working flat, and this is fantastic if you're developing mobile games or casual games, for example. There's a couple ways to get going with 2D, and it integrates wonderfully with the 3D if you'd like. You can do a 2D minigame or overlay 2D in the 3D. You can also start out a project natively in 2D using a new template, and I'll show what that looks like before I bring some 2D into my 3D game here. If you choose File and New Project, you can create a new project with setup defaults for 2D. When you do this, you have the same options as usual. Are we bringing in a character controller, cookies, scripts, and so on? I'll start out by bringing in my character controller, and then also adding in my physics materials and standard assets and scripts. I'll browse to set my project and then get going in 2D. I've selected a folder, and keep in mind that I'm showing this as a possibility. Because we've already set up the project here for 3D, we're going to bring the 2D in, but I wanted to take a minute and show the new 2D defaults. When we start out in a new 2D project, the scene view is configured to be 2D, and we can toggle that off and on with the 2D button at the top of the scene view. What's actually going on here is that the main camera is defaulted to the projection as orthographic, and we can see it here in the camera where we can switch back and forth. Usually in a 3D game, we use a perspective, but now it's set as orthographic and ready for a 2D game. When we import assets, there's also a new asset type, and I'll bring a piece in just to show what it looks like. In the 1201 Assets Textures folder, I've placed a couple assets we're going to use in that game. I'll bring in this Cars 2D and click Import. What happens is that in a 2D preset, the default texture type is set to sprite, and we've got sprite modes and places to set the pivots. It's defining the sprites based on the alpha channel of this image, and I've brought in a PSD here natively, and that way I'm going to work uncompressed for the best quality. For sprites then, we'll put the format as true color, and I'm going to max out the size as it was drawn at 2048. I'll click apply, and then I can go in and edit the sprites. What I'm going to do though, is I'm going to go back into my 3D gallery project and bring in the sprites there, because what I'd like to have happen is this is a modern painting that'll go on the wall, and it'll appear to be flat until the player triggers an animation, causing the cars to zoom by and smash into each other. Keep in mind though that if you're working exclusively in 2D, you can start out a new 2D project and set everything up to be, well, flat, but you'll be able to take advantage of all the physics and scripting from Unity you already know, just applied in 2D. Importing sprites for 2D is just like importing any other asset. You can either copy that file into your Assets or Textures folder, or wherever it is you're placing them, or you can right-click in the Assets section and choose Import New Asset. I've already put some 2D assets in the Textures folder here in my Assets. There's Cars Background and Cars 2D. The Cars 2D has an alpha channel, and when we look at it, we can see that the cars are in white, mostly, and the background is in black. There's also a ground plane down there, so that the bottom cars can ride along it and fall onto it. Cars Background, then, is just a background image. What I'll do first when I import these in to make them 2D is change the texture type. I'll drop down under Texture and choose Sprite. I'll also change the size. In this case, this background image was drawn at 2048, and I'd like it to be big, so I'll let the max size be bigger. I'll leave alone the packing tag, pixels, and pivot for the moment. This is going to be a static sprite, just there as a background, and so I'll just make sure that I push it to the back in the new Sorting Layers. I'll click Apply, and I'm ready to bring in the cars. I'll select the cars, and what we can see here is that alpha channel. Again, this was drawn large, and that way I can bring it in with good-looking sprites instead of compressing them. I'll make the max size 2048 and turn the format from compressed to true color. This is an important note. If you leave it as the default, compressed, when you go into the sprite editor, you'll get messages saying, wait a minute, this is not going to look good because you're working with compressed images. And you'll see some pixelation and odd edges in your sprites. So when you're working with sprites, because inherently you're dealing in smaller assets, you can work in true color. I'll also change this texture type to sprite. And in this case, this is going to be multiple sprites. We have a choice in here between single and multiple. Single, as the name implies, means that this is all one sprite of all these cars. Multiple, then, means I'm going to break this up in the sprite editor into multiple sprites and place them around or link them together. I'll choose multiple and then click Apply. I can go straight from here into the sprite editor, or I can open up the sprite editor separately. Now it's regarded as a sprite, and the alpha channel is automatically knocked out. I'm ready to break this up into the individual cars and put on the new 2D colliders and 2D physics. After you've imported in your sprites and tagged them as single or multiple, you can start to slice them up, slicing up a sheet of multiple images into different sprites for use. I'll pick my background image, and the first thing I'm going to do is to change the pixels to units. I'll put these at 512, so that my 2048 image becomes 4 meters wide once I bring it into my scene. I'm going to put the pivot down to the bottom as well, and this way if I need to register something against that pivot at a known coordinate, I can do that. I'll also change the format from compressed down to true color. Make sure when you're using sprites you're running true color, so you don't compress your sprites and see artifacts or have odd issues when you're trying to slice them. Now I'll click Apply, and then I'll do the same with my Cars 2D before I slice it. Pixels to units are set at 512. It's a multiple sprite and true color. I'll apply it and go into the sprite editor, which I can get to either here from the inspector or by choosing Window and Sprite Editor from the top menu. In the sprite editor, we can see our image, and the transparency is shown by our gray grid. We have a couple of different ways to slice this. We can drop down on the Slice menu in the top left and choose Automatic or Grid. This will do a best guess for automatic based on the alpha channel of the image. I would run into some issues with it because the alpha channel on my cars just touches that pink bottom bar, and so I may get some very odd slicing in here. Grid, as an alternate, lets you set out a slice based on a pixel size. And this way, if you know you've gridded out your sprite sheet, for example, and can slice evenly along that multiple, you can slice a whole sheet of sprites very quickly. I'm going to leave this alone and do a manual slice instead. I'll start out with the white car, as this is the one I'll animate to knock into the green car next to it. Once I lay out a slice, a menu pops up asking do I want to trim this and set that pivot. I'll trim it to size down around that sprite and put the pivot down on the bottom. Then I'll pick the next car and do the same. Again, trimming and putting the pivot on the bottom. Now look at the next cars down. I'll take these 3 yellow and other color cars, trim them, and put their pivot at the bottom as well, and finally the solo green car next to it. For the bottom cars and the pink bar they sit on, I'm going to trim them all at once, and this way it's a fixed bottom object the other cars will stack onto. I'll select everything in here, all 6 of the bottom cars plus that bottom border. In the sprite menu, I'll choose Trim and put the pivot down at the bottom. Now my sprites are sliced. I've got 3 unique cars, one group of 3, and a group of 6 with a bottom, and I can apply these and order them as I need. I can even make them lap over each other to create parallax by putting them on different sorting layers. I'll click Apply, and Unity will finish, and I can close the sprite editor, and now in the Cars 2D, I can see I've got all 5 sprites. They can be named if we need, and we can drag them uniquely into the scene to start to build up our 2D elements. Sprites have their own layering system beyond the normal Unity layer system, and it allows us to stack flat sprites exactly on top of each other, but determine who renders or who displays first. What I'll do is to select my background and then start to get in some sorting layers for these sprites, so I can layer the cars over the background and create some parallax if needed. I'll pick that car's background texture, and here in the inspector, we've got it all set. It's at 512 pixels per unit, true color, and it's all sliced, well, as a single sprite with a pivot at the bottom. I'll go into the 2D view in my scene, pan down until I can find a blank space, and drag this background object in. When I'm all done with the painting, I'll nest all the elements under a game object, and then move it around in the scene as I need. I'll zoom in on this object, and what we can see here when we bring it in is that it creates a prefab just like any other asset. It's got a transform with no Z at the moment. The scale is 1, and it's got a new sprite renderer component. This sprite renderer component has its own kind of material and a color we can use to tint that sprite if we need. It also looks to that car's background sprite I defined, and there's a sorting layer and order in that layer. What I'll do first then is to drop down under Default in the sorting layer and choose Add Sorting Layer. In my sorting layers, I can add by clicking the plus below Default, and I'll name this new layer Background. Now I'll add on a Cars 1 and Cars 2 layer. These load from the top down, so if I put something on the background and then something else on Cars 1 will be in front of it. You can drag these around if you need by grabbing the double bars next to the layer name and simply pulling it. I'll leave these alone, Background, Cars 1 and Cars 2. And within each sorting layer, we actually have a sorting order if we need. I'll select this background object and change its sorting layer to Background. Within that layer, if you've got multiple objects, you can number them. This is like arranging objects in Adobe Illustrator if you're familiar with that workflow, where within one layer, each object non-destructively can lay over the ones in front and in back of it. And that way, you can stack things correctly and define exactly what is shown first in your layers. Now I'll get my cars in. In the cars here, at the bottom, Cars 2D4 is my giant background cars. This one's going to be more or less a static, and I'll put it in there by dragging it into the scene. In the sorting layers then, I'll put this on Cars 1, and it appears over the background. Now I'll snap it in place. There's a couple of ways to do this with a sprite. First, I can pick the background and put it maybe at a more round coordinate. How about -56? I'll also put the Y at 17. This way it's just easy to type in. The pivot is on the bottom, and that's what that position refers to. Now when I pick this Cars 1 object here and put its pivot in the same place, they'll match exactly. With the pivot of Cars 1 down at -56 and 17, those cars are exactly stuck to the bottom over that sprite. I'm ready to get my other cars in. I'll pick Cars 2D 0, and drag it into the scene as well. I'll put this sorting layer on layer 2, and then I'll pull in some other cars. Now I've got all of my cars in. These top 4 clusters are on Cars 2, and I can set the order in the layer. I'll start out by making this white car number 1. I'll let the green be 0. This bottom green will come in as 2, and so on. Now that I've sorted all of them, put them on their layers, and put in the sorting order within that layer, those cars will all draw in the right order and not overlap each other. When I take these cars and slide them over, we can see that the cars cleanly move over because they're at the higher number in the layer. Now I'll get my cars aligned. What I'll do then is to zoom in. What I'd like to have happen is that the white car accelerates to bump into the green car, which then will turn on its physics and fall down onto the others. I'll pick this white car and hold V for snap. What we get then is a registration of the snap at whatever the closest corner is on that sprite. I'll snap it over to the other car and then pull it back. Holding Shift constrains that motion. Now these 2 cars are snapped together, and I'll do the same with the next row down. Holding V for snap, snapping them together, and then pulling back while holding Shift. My painting is ready to bring to life. I've established my sorting order and layers, and this way I get parallax if needed, or at least the idea of these flat objects passing in front and behind each other. Like all things in Unity, it's important to stay organized. So create layers and name them, and precisely figure out your order in your layer. This way you can avoid any Z fighting, or places where the objects don't know who's on top, and each one competes to draw first. The new 2D tools in Unity have a new 2D set of physics components available. I'll put some colliders on my cars to start, and we'll see that they're much like their counterparts in 3D. I'll start out by looking at the bottom cars. I'll select them, and with their sprite selected, I'm going to put on a box collider. It's the simplest kind of collider available, and to do this, I'll choose Component, Physics 2D, and we can see in here in the colliders that they're standard kind of colliders, circle colliders instead of spheres, box 2D colliders instead of 3D boxes, edge colliders, and polygon colliders. There's also a collection of joints to use, such as springs and hinges in 2D. I'll put onto these bottom cars a box collider, so that cars generally stack up and bounce on top of this, rather than colliding with each one uniquely. Next, I'll look at some of my other cars and put colliders on them. I'll choose the 3 cars, and they'll get a box as well. As a note here on selecting, clicking on them seems to select the background. So what I'll do is select them by a window here, and make sure I grab all of those cars. Once I've windowed around their entire sprite, it selects. Alternately, I can pick them in the hierarchy just like any other object. For these again, I'll choose Component, Physics 2D, Box Collider. Next, I'll pick the single car next to it. I'd like this one to collide a little closer, so I'll use a Mesh Collider by choosing Component, Physics 2D, Polygon Collider. What this does is, based on the alpha channel, draw a quick polygon collider for that car. I'll zoom in and take a quick look, and we can see in here that it fairly faithfully follows that sprite. It does a good job of optimizing that collider around there. Now this is the most expensive kind of collider to use. It's equivalent to the Mesh Collider in 3D, where it's a tremendous amount of overhead to use a Mesh Collider versus a Box Collider. But for specific instances like this car, the Polygon Collider will work nicely. With this Polygon Collider then, like with our colliders in 3D, we can see we can put on a physics material. And this corresponds to the physics materials in 3D, where if we bring in that package, we have different choices available of the way things react. There's also collider info, the number of vertices in that Polygon Collider. And this will let us keep track of how it's working, if we need to do a custom collider, or if we should run with a box or an edge. Finally, I'll get Polygon Colliders on my other 2 cars. This white one will animate, and so I want it to cleanly contact the bumper of the one it's next to. Now that all of my cars have 2D colliders, I'm ready to get my physics and animation going. It's just like working in physics in 3D, where we bring in our meshes and then put colliders on, seeking to optimize our colliders as much as possible, judging how an object needs to contact, if the player is going to hit it, and whatever else we need to think of to really optimize the gameplay. So we're not dealing in solving a whole bunch of just mesh colliders. Now I can get some rigid bodies on. And after that, I'll get that white car animated and see if I can get my painting to come to life, letting the cars hit each other when they're triggered by the player. Rigid bodies work in 2D much the way they do in 3D. Once we've got our colliders on, in this case boxes and polygon colliders, we can put rigid bodies on some of the cars, letting them fall after they're collided with. I'll start out by picking this green car in the middle. It's already got a polygon collider on it, and I'll choose Component, Physics 2D, Rigid Body 2D. In here in the rigid body, we've got many of the same parameters we do for 3D, mass, drag, and so on. What I'll do is to start this out as a sleep, meaning it doesn't do anything and doesn't fall until it's knocked into. I'll leave mass and gravity alone and see how it behaves once I get it into my scene correctly. Next, I'll pick this other single car and choose Component, Physics 2D, and Rigid Body. And again, I'll make this car start asleep. This car already has a polygon collider on it, and I'm going to let it simply start animating and keep going, knocking into that green car and knocking it down. Finally, I'll take this trio of cars with a box collider, and onto them I'll get another rigid body. Here in the rigid body, I'll start out asleep, and for these I'm going to make their mass a little bit bigger. Now these will go down and hit the box collider at the bottom, and this box collider on these several cars is not going to get a rigid body. I don't want it to fall down. I want it to stay fixed, and so I'm going to leave it alone as just a box collider. This way, when the player triggers this car, it will knock into this one, and this one will fall, as will that one. They'll get the idea that they've disturbed or upset the painting by getting close to view it. In addition to our rigid bodies then, we can do things like putting on our hinges, looking at spring joints, distance, and sliders, allowing us to link objects together in 2D to make things like chains. The new one here is a distance joint, and what this lets us do is have two objects that maintain a fixed distance from each other, but still react as if they're pinned together. This opens up a lot of fun actually in 2D, because you can let things happen and start to fling things around. If you'd like to make your own version of Angry Birds, for example, a classic game of, well, loading up birds and flinging them at pigs and structures, you can. Enabling the physics in 2D is a great way to get going. And we'll start here with this painting, getting ready for those cars to collide and start to fall. Animating in 2D in Unity is just like animating in 3D. We've got great control with the dope sheet and curve editor over our animation. What I'll do to start out, before I animate the car, is parent all of these cars in their background under an empty game object and get them into place so that when I key position, it's in the right place and the cars don't jump around. I'll start out by choosing Game Object and Create Empty. I'll name this empty game object ArtK for Kinematic Cars. And now I'll use the Hierarchy view to parent those cars under that game object. I'll roll up the ArtS and select those car elements. I'll drag them right under ArtK, and now they're parented in. Now I'll move this into place in the view, getting out of my 2D window and pulling it down into the scene. I'll switch over to a wireframe, and I'm going to pull these cars right down into the building by the EMMAs. I've pulled my cars into the view, and I'm ready to get the animation on that lead car. As a note, if you're moving your 2D around and rotating it or positioning in the space, you may want to hold off on the colliders until you're all ready. Once that 2D is finally in place, and it may be even parented under, then get the colliders on. 2D colliders rotate oddly when they're parented under things, so be careful of the order you're working in. Now I'll animate that car. I'll select that lead car and pull up my animation window, choosing Window and Animation. We can work in either the dope sheet or the curves, depending on which way you'd like to start. With either one, I'll create an animation clip first. Simply clicking over on the timeline creates one, and I'll name this new animation clip Car Move. I'll put it in the Assets, Animations folder. I'll click Save, and it's made the new car animation file. Now I'll animate this car, first by pulling it over, and then adjusting the keys. I'll pull the car over just enough to bonk into the car in front of it. This should trigger those physics. Now go into the Curves menu, and there's those curves. They're actually very slight. If we look at the position X, we can see it's really not a big jump. I'm going to play with the curves just a little bit. What I'll do is let the car start out slow and accelerate into motion. I'll pick that key at the end, right-click, and choose Flat Tangents. This way, I can adjust that handle, and I'll make it a sharp in. Then I'll pick the key in the beginning and flatten out that tangent as well, making sure to right-click straight on the key. If you don't, you'll add another key as you just saw that menu pop up. I'll choose Flat and just pull that handle a little bit. Now the car starts fairly slowly, zooms into motion, and will smack into the other car. We can see in there that the car actually keyed all 3 axes. We just didn't have any motion on the Y or Z. It was only an X move. Now this animation is ready, and I can put on either an animation controller and an activate trigger on a box collider in front of it, or I can use Mecanim. It's up to you which you'd like to do. The 2D elements tie beautifully into Mecanim as well, and so if you want to do a 2D game with all kinds of behavior states, you can put that in, just simply swapping out your 3D elements and 3D character for your 2D sprites. Image effects in Unity provide a powerful way to add some overall polish to your scene and unify the look. What I've done so far is to tune up some of the lighting in Building A here, moving the point lights closer to the ceiling, making sure everything was marked for the correct layer, putting a light over the Emmas, and turning only the spots and the points for this building to important. This way, they hit just what they need to, and I've added one more light in to hit the ceiling. That way the ceiling isn't being hit by 5 or 6 lights and trying to figure out who's the most important. I'll scroll out and show what's going on here. This light underneath Building A is a Building A ceiling light. It's got a big range and a fairly low intensity, and all it does is hit that roof object, which is now on its own layer called Roof AB. I made 2 new layers, Roof AB and Roof C. What these do then is let me say this ceiling light can only hit this piece. This roof will be hit underneath from that point light and from the top by the suns. That way, the roof won't blow out. The ceiling will be softly lit inside the building, and the building lights themselves don't have to worry about hitting the ceiling. They'll take out any hot spots they have, leaving me a slightly dimmer than the walls, evenly lit ceiling in the building. Now I'll look at some of the image effects. What I'm going to do is import in a new package that's available for Unity Pro only. If you're using Unity Indie, you can watch this one and try to approximate some of the effects either in your textures or with some creative scripting. I'll right-click in my Assets folder, choose Import Package, and Image Effects. Note that it's marked Pro only. In the Importing Package dialog, I'll import everything in. There's a bunch of different image effects in here, and I want to be able to pick and choose. I'll click Import. Unity will take a minute, bring those image effects in, and then I'll start in on my sun shafts. My image effects are imported in. In the Standard Assets folder, there's now an Image Effects folder, and I've got all kinds of different image effects scripts. These are a mix of JavaScript and C#, and there's all manner of neat things to put on, and I want to offer a word of caution on that. It's very tempting to put on everything, blur and bloom and flare and so on, and this will bog down your game. Because these are image effects, they drastically multiply the number of draw calls you're making, because objects are first drawn and then drawn seen through the image effect, some of which have blurs with multiple iterations. And so very quickly you can see a tripling or quadrupling of the number of draw calls going on and watch your game slow down. I'm going to start out with my sun shafts, putting them first on the main camera. I'll pick my first-person controller, select the main camera, scroll down in the image effects, and grab the sun shafts and drag it across. The sun shafts look to a transform of an object to originate. I'll use the sun so that the directional light for the sun, the long sunbeams on the floor, and the sun shafts all match in angle. I'll click on the Pick button for Transform, and up in the Scene section of the Select Transform dialog, I'll click Sun and pick my sun. Always adjust an effect when you put it on. Never use just the default effect. They look pretty decent, but remember, everybody has them. So you need to customize these for your game and make it look like you want. What I'll do is to bring up the intensity just a bit. I'll put it up to 2 and see how it looks. Then I'll click on the shaft's color and add just a little warmth in. Maybe a saturation of 5 and a hue in the, let's say 35 range, a warm orange. I'll have to see how this looks. I may end up switching blending modes, and what this lets me do is go from screen to add. Add is additive in luminance and tends to get very big, very white, and very hot very quickly. But if you're familiar with Nuke, God Rays, that's actually the mode to use. By the way, that is an actual filter in the compositing package Nuke, God Rays. It's what we use to put on this phenomenon, crepuscular lighting, or dust in the sunbeams. I'll leave the resolution at normal. There's choices in here, low, normal, and high, and we can bring it up or down depending on the quality we need versus the hit and performance we're taking. I'll see how it looks once I get my other effects on, but first I'll test out my sun shafts. I'll click play. Unity jumps into the game, and I can just see a little bit of haze going on in the sun shafts on the floor. We can see them coming in, and they're very subtle. That's okay, because I'm going to put on some other effects that may boost them up, so I don't want to make those sun shafts absolutely giant for the moment. Also, keep in mind we actually want to see what's going on here. Subtlety is good, so just a little bit of emphasis in the sun shafts is more than enough. Here's that painting, by the way. I'll zoom over to it and get close enough, and we can just see that car knock into the other and knock it down. It's a 2D image, or 2D set of sprites actually, that's functioning as a painting that we bumped into, which sprang to life and had an accident. Now that I'm out of the game, I can adjust the sun shafts a little further, but I'll wait on the sun shafts until I get my other image effects on. Next, I'll put on ambient occlusion, depth of field, motion blur, and a little bit of color correction to tie it all together. Ambient occlusion is really a wonderful thing for 3D work. What it lets you do is settle everything down. Here's what ambient occlusion is in a nutshell. At some point, light is general and therefore ambient in the scene. It's not from anywhere in particular. Adjacent objects block that light, giving us grounding darkness in the corners of walls and floors, or up at the ceiling where the ceiling meets the wall. Under characters' feet and under furniture, it's that lingering darkness. Not a shadow, but simply darker than the rest of the room. It's a terrific thing for grounding pieces, making stuff look like it's in contact with whatever it's adjacent to. We'll add on screen space ambient occlusion as an image effect here to help add some of that grounding darkness to our scene. I'll pick my main camera, and I'll scroll down under my sun shafts and add a component. I'll choose Image Effects and Rendering and Screen Space Ambient Occlusion. I'll scroll down, and what we can see in here in the SSAO effect is that it's got a sample count, and it's medium, low, or high, a radius, and this is in scene units, an occlusion intensity, how much darkness is there, and a blur. There's also an occlusion attenuation and minimum Z. Finally, there's a shader and a randomization within it. What this lets me do, in a nutshell, is put in the occlusion and say, how big is the spreading darkness in the corners? I'll start out with a radius at 0.5 and see how it looks. I'll put the sample count up to high, just to see if I can really see it, and also if I can pull it back down and notice any difference. I'll press play and see how it behaves before I adjust it more. We can definitely see the ambient occlusion. It's that low darkness along the walls, really grounding them and making them look like they're contacting the floor. Up at the ceiling, it's a little bit on the dark side and a little heavy, so I could probably pull that distance back. As I play forward though, it's a nice way of adding some gravity into the scene. It's definitely too heavy on the ceiling. It works really well on the walls, probably because down low they're darker anyhow. But in some places it's a little bit too much. I'll get out of the preview and check out the occlusion, seeing if I can pull it back just a little bit while still maintaining that gravity in my scene. Here's what I'll do. I'll pull back the occlusion intensity to 0.8. Maybe that'll reduce the darkness just enough that I can get by here with a lower sample count. I'll drop the sample count to medium and press play again. This is better. I still have some darkness up here, but it's not nearly as, well, ferocious as before. The walls are definitely grounded, and everything is definitely in contact with adjacent objects. I'll pull this back just a little bit more, as I don't want to counteract the white walls in my gallery. I'll pull the radius back to 0.35 and see how it looks. I'll also play with the occlusion attenuation, the rate of fall off in that occlusion. I'll try this by pulling it up a little bit higher to 1.5, so it falls off quicker. That's better. What I've got now that I've adjusted the occlusion, is some fairly tight grounding darkness in the corners without being oppressively heavy. I could even pull it back a little bit further, or just leave it alone for a good feeling of gloom in there. It's up to you how you'd like it to look, but this is a great way to really add some gravity in the room. Keep in mind, though, that because it's a screen space occlusion and we've got limited quality available, that on small tight things like the Emma's feet, for example, we're not going to get a ton of occlusion. They're also in a spotlight, which is going to mute out most of the occlusion, and it's just a screen space effect, not actually a rendered occlusion like we'd use in 3ds Max or Maya. If you do need occlusion in tight, dark areas, such as the vents or outlets, for example, or maybe on a sculpture or other model where a normal map has been baked out, render that occlusion out and composite it into the diffuse texture. This screen space occlusion is good only on geometry, and so a lot of times, because we're using textures to put in final detail, the screen space occlusion will be kind of a general wash of darkness more than a fine detailing and darkness popping things out. It looks pretty good and definitely helps kind of ground my scene. My gallery is really coming to life. And here's that car one more time. As I get close enough, it knocks into the other car and the 2D sprites drop down in their own physics. Depth of field is one of those effects that really can add some visual subtlety and power to your images. Sunbeams are neat, and they're really cool to see coming in through windows, and ambient occlusion really adds the gravity. But putting depth of field on really takes the player from seeing something that's not quite right to really sitting in the scene. Here's why. We see with our two eyes, or occasionally one, out to one point in space. And things beyond that, things in the background, and things closer than that, in the foreground, blur out. Cameras see the same way. What this means is that when we see a scene like this in Unity, where everything is, well, smaller in distance but perfectly in focus, it seems a little bit odd. So we can add on some depth of field to tell the audience, I want you to focus in this range. There's two different depth of field image effects we can put on, and I'll go through a little bit of each one to show what they do. You can choose which one you want to use depending on the look you want. I'll start out by selecting my main camera in the first-person controller and dragging over depth of field 3.4. I'll roll up the screen space occlusion and pull that in. What this does is say, here's a focal distance and a focal size and how much blur we have. I'll try it out just at the default settings, and these are going to need some tweaking already, I can tell you. It's beautiful. Apparently we forgot our glasses today because everything is strongly out of focus. Here's what's really going on, joking aside. The focal distance and depth of field is set to 1. 1 meter out is in focus. Focal size of 0 means that 1 point 1 meter out is in focus and everything else blurs out from there. Theoretical depth of field is 0. Only 1 point is in focus at a time. But we use focal size to give us a focal plane thickness, is how you can think of it, a zone of focus instead of a point, so that things more or less stay in focus until they really start to go out. I'll push out that focal distance to 15 and bring up that focal size to 6. Next, I'll take that blur spread way down. Here it is at 0.25, and I'll take the blurriness down as well. This way, I've pushed out how far we can see and given us quite a good zone that's always in focus. I've reduced the maximum blur way down, and this way, things are subtly blurry in the deep background. Lastly, I'll look at the quality. Right now the resolution is low, and I'll see if I can get by with it low because high takes more computing power. There's also a quality choice, only background or background and foreground. This is a judgment call in the look. If we're using only background, everything in the foreground up to that focal distance is clear, and beyond it we start to see blur. With background and foreground on, the foreground blurs as well. It comes into focus, and then we get the background blur. I'll try it on these settings before I switch over and see if I have enough in focus. This is somewhat better. The building across the way is noticeably blurry still, but inside my building, I'm definitely in focus. It looks good, although my sky is definitely blurring out. Inside, though, everything is nicely in focus, so I'm really telling the audience, you should run around this building and look around what's in here first, before you get outside. Once you get close enough to the outside, things will resolve into focus, like as you look through the windows, and you can say, maybe I should go look over there, now that I can see what it is. Here's what happens when we turn on foreground and background. We've got a foreground size now, and we'll really start to see things blur out in the foreground at this value. With the foreground and background blur on, we can definitely see where that focal point is. If I pull back and look into this space, we can see 2 walls back are in focus, but the Emmas are definitely blurred. It's okay to use this because it can give you a very soft, almost dreamy quality. Just be mindful of using too much blur in there. Too much blur is visually disconcerting. It makes us feel like our eyes aren't working well. I'll take that foreground size back to 0.15, again keeping it very subtle. Now I've got just a little blur in the foreground, pushing my attention out to where my focal point is. In this case, it's really up to you which one you want to have your audience focus on. If they're back here knocking over the art, that should probably be in focus. So in this particular case, most likely a foreground blur is not the right choice. I'll switch back to only background. One of the last things we've got here is Enable Bokeh Blur. What this does is enable an extreme blur, and we can see it when we turn it on and scroll down. Bokeh Blur is when things like specular highlights or little twinkling lights blur out into distinct shapes. Often we see hexagons or pentagons of light, maybe squares, and it really depends on the number of blades in the lens. We can customize that bokeh blur if we need through the texture mask, taking in a texture with an alpha channel. You could even make a bokeh blur turn into hearts or stars if you wanted. What this will do for us then is say, at what point do we see a bokeh blur? What shape does it become? And how big should those pieces be? I'll try it out and see if we notice any difference. At the moment, there's not much of a difference. And this is because I don't have many round things in here with twinkling highlights. It's also daylight, so I'm not getting any really pin lights in places. What would be great for a bokeh blur is if it was near dusk and there was a sparking fountain in the background or something similar. Something with little points of light that could bloom into those shapes. So I'll turn off the bokeh blur and let my depth of field go just background only. Now I'll turn off this depth of field and put on the other depth of field for scatter. I'll drag it in, and now I've got slightly different parameters. First, we've got a focal distance and a focal size. Then there's a focus on a distinct transform if we want to keep one object in focus. And finally, an aperture. The lower the aperture, the blurrier things get. We have a defocus type, depending on what kind of blur we'd like, both disk blur and DirectX 11 if you're supporting it, and then a sample count and a max blur distance. I'll try this out and see how it looks at the default settings before I adjust it. This is a pretty nice looking blur, although it's a little blurry on the Emmas. They do come into focus decently when I'm close, but it's a little too much blur as we saw before. What I'll do is take that focal size up. I'll put it at 4, so I'm dealing in a good range and focus, and then lower down the aperture to 8. I'll press play again, and now I've got most everything clear and just a little bit of blur in the background. I like the way it's looking, although the Emmas up close are still very blurred. We actually need to back off to see them in focus. It's up to you which way you'd like to handle it. Personally, I would like to have this game be about a close focus, because right now, close up on the art, we're losing the detail in the texture that we should probably see. So I'd like to use the other depth of field and push that focus back. So it's really a background blur more than an obscuring blur in the foreground. As with any effect, it's up to you which one you'd like to use. And you need to pick the one that really enhances the look, feel, mood, and immersion of your game. How should the viewer feel when they see this space? Visualize, then, for us, enables visualization. When we play our game, we'll actually see what's close and what's far. And in this case, we're seeing where that depth of field sits. It's very, very close, and we're seeing what's only in focus, degenerating into blur very quickly. As we start to push those focal distances around, we'll see that turn into more of a grayscale, and it's a tool for visualizing how far out the blur is and how subtle it's getting. I'm going to remove this component and turn back on the depth of field 3.4. I'm ready to add on some final polish. I've got depth of field on, sun shafts, and screen space occlusion, things that are naturally occurring and really help bring out the look. Now I can think about unifying the look of my entire scene with some color correction and a little bit of motion blur. Motion blur requires some judicious use. but in the right place can really enhance the look of a game. What motion blur does is to simulate the effect we see, well, originally in film, where the motion of an object was too fast to be captured in one frame of film and that object blurred across multiple frames. It's prevalent now even in digital cameras and digital cinematography, where we simply can't see fast enough to catch an object still in one frame at one time. Without motion blur, things tend to look very crisp, especially as they're moving, and actually blurring them out, degrading their quality, believe it or not, helps enhance the look. It makes things more believable and enhances the feeling of speed. So if you're making a driving or racing game, for example, motion blur is probably high on your list. I'll add on motion blur to test out how it looks here in my scene. It may give me a little extra blur as I'm whipping around my gallery, and I'll see if that really holds. I'll go into the first-person controller, into the main camera, and then add on that image effect, clicking Add Component or choosing from the Assets, Image Effects folder. In the Standard Assets here under Image Effect, I'll pick Camera Motion Blur and drag it over. In the camera-based motion blur, we've got a couple of options as to how to do the blur and how much blur to use. We can either reconstruct, choose from a local blur, DirectX 11, disk, or camera motion, and these are available in detail in the Unity help. I'm going to leave it at reconstruction for the moment and just see what the default blur looks like. There's a velocity scale, how much blur is there, and also a minimum and maximum velocity. This keeps the motion blur from getting excessive or from blurring out still objects. I'll start out by pressing play, and let's see what this motion blur does. As I move around the scene, I feel like I see a little blur in the background objects, and this is good. As I dolly forward, there's not a ton of blur evident, but panning around the scene definitely gets a little swimmy. It's almost there and just needs a little bit of tweaking. It definitely enhances the feeling of rapid movement around here, and that's really the thing to consider as I knock down the painting again. How much movement is there, and how much blur do you really need to see? What is it you're trying to tell your audience? Do you want them to focus on one particular thing, look at those Emmas move, or should they be whipping around the scene, or whipping around hard turns in a driving game, for example? I'll stop the play and just tweak the motion blur a little bit. I'll pull this velocity scale down, putting in 0.25. We can exclude if we need, and what this means is this motion blur not affecting a certain layer? For example, if we're making a driving game, we could say, don't include the car, but include the background. I'll leave it alone and just try that lower velocity scale and see if this works any. I've got a little bit of blur, just enough that as I move around rapidly, I noticed a little bit of zooming going on. Or not zooming, but, well, blur, motion blur. And it enhances the idea that I'm whipping my head around the game fast. Being that the control over the character is, well, as fast as we can move the mouse, a little motion blur actually tells people to slow down and look around, lest you get so blurred that you start to miss things. My game look is coming together. In addition to the lighting, I've got a really good series of blurs going, blurring out the images and telling the audience to focus in a particular area, keeping their focus close so they look at the art and they try to find their way out, hinting at what's going on by gradually revealing things into focus in the background. There's one important point on blurs here before we get into color correction. If you notice, when I look across my entire scene, as far as I can, I'm dealing in, let's see if I can max this. This is about as far as I can look and almost 2,000 draw calls. So keep in mind that these kind of image effects do drastically jump up the number of draw calls your graphics card is making. When I turn on the terrain and the grass, we're going to see an even more drastic jump. I'll turn on those layers and see how all the image effects start to hold together. I'll turn on my plane for my water, and then finally the terrain. Now I'll play again, and we can really watch those draw calls kick up. At the most, with everything blurred out, I'm at 2,500, and this may be a little much for some mobile applications, so we really need to watch not only where are we publishing to, but what image effects are we using, and how much blur are we putting in. I'll reduce that depth of field more, because I'd like it to be really clear on the buildings all the way back. It looks good though inside, and I definitely get the idea of being inside and looking around close, and coming up to the windows and seeing things come into focus. If you'd like to go further with this, You can actually access all the depth of field parameters, for example, in scripting. And you can key them. For example, there have been games where that focal plane has been keyed to the scroll wheel on the mouse. This way you can focus in and out, driving the character to look around, focusing off in the distance to see something, and coming back close for a small task or close operation. It can really enhance the natural look of the game, because we, with our eyes, can focus in multiple places, zooming in and out, and really taking things in. Now I'll add in some color correction, getting on that final polish in the look of my game, and finally a little bit of glow as well, to make those sunbeams and other hot areas pop out. Color correction can add the final polish to the game, adding a subtle overall unification in the color scheme. It helps us tint that color overall in the game, applying a color to everything and bringing it all together. I'll use a color lookup table, and first what I'll do is take a screen capture of the game to then color adjust and apply those adjustments onto a special lookup table image here in Unity. I'll press play and go into my game and take a screen cap of it. Pressing play, and I'll go and look out the windows, or rather, go over to the windows and look back through. This gives me a pretty good representative image of the game, and I'll hit Print Screen. Now I'll go over to Photoshop and paste in that image. Alternately, depending on where you are, you can also make this window bigger and take a screen cap of it. The big deal is to get to see all of your game. As a note, what I've done here also is to reduce that outside fog even more and change it back to a linear fog so it's just a subtle coloration on the hills. I've pasted that screen capture into Photoshop, and I'll color correct it, and then record those color corrections and apply them across to a color lookup image from Unity. Here's how I'll make this work. What I'm going to do is choose Window and Actions, and I'll record what I do as a new action. I don't really care how long it is, as long as I'm capturing what I'm doing. Alternately, if you know the sequence of what you're doing, you can save out things like hue and saturation adjustments or brightness and contrast, but an action will work nicely. I'll click New Action, and I'll make a new action here called CC for color correction. I'll leave it in the default actions, and I'm not going to assign a hotkey to it. I'll hit Record, and now I'll adjust this image. I'll choose Image, Adjustments, and first I'll work on the levels. In levels, for example, I'm going to swing around the midpoint and see what it does, pushing that midpoint up to make the image just a little dimmer, and then playing with the output levels as well. Again, going a little bit darker. Then I'll work with the RGBs in hue and saturation. It's really up to you how you'd like to work this. You can work by master, by RGB, by levels, by curves, by you take your pick. I may even take this into a program such as Nuke and play with the color correction there. Personally, I also work in Ion Fusion, and so I like to use the color correction in different programs to see what I'll get. We're just moving pixels around in an image, so it's perfectly fine to use whatever tool you'd like, as long as you can record it and apply it to the lookup table. What I'll do then, for example, is to take my blue tones and saturate them just a little bit, but then darken them down. I'll also take my yellows and push them up just a bit, and that looks fairly reasonable. I'll click OK, and this action is recording the whole time. Finally, I'll bring a little more contrast in, choosing Image, Adjustments, and Brightness and Contrast. I'll just bring the contrast up, play with the brightness to see what I get, bring it up just a touch, and declare victory. We could keep adjusting and tweaking it. It's really up to you how you'd like to be able to adjust this. If you'd like to do one more adjustment, such as a hue saturation, and maybe swing the overall hue around, go for it. For example, I'll add just the tiniest bit of warmth in, maybe a -0.3, so it's just a little bit warmer overall, and click OK. Now I'll stop this recording, and I'll open up the lookup table from Unity. We've got a neutral 3D 16, and that's our color strip we're going to start with. We can also use a color correction ramp, but I'll color correct this one and load it in. This special image, 256 by 16, has a series of gradients on it. What I'll do is open that up and then apply that action to it. I'll apply my CC action by selecting it and pressing play. There's a subtle change in the image, and I'll save this out as a copy with a different name. I'm going to put this image in the same folder, in the Sources Textures folder, and calling it Modernista 3D16 as a PNG file. I'll click Save, and then I'll bring it into Unity. Here in Unity, I'm ready to put my color correction on. I'll select my main camera on the first-person controller, and in the Image Effects, scroll down and grab Color Correction LUT, or Lookup Table. We actually have 3 different color corrections available. We can work by curves. There's an effect we can use if we'd like to get into scripting, and finally the lookup. I prefer to use the lookup personally because it lets me fine-tune the color in an application that's really made for it, like Photoshop, and then apply that across here in Unity. I'll drag that lookup table in, and then go select that texture. I'll click on Select, and in the Assets, scroll down, and there's my Modernista 3D16 color lookup table. Once it's selected, I'll hit Convert and Apply. It's been converted and applied, and when I play the game, I'll actually see that coloration applied. I'll press play, and what we get in here is that subtle gradation in color applied in the scene. It's a little deeper overall, a little more contrast, a little bit warmer, and a little bit hotter in the yellows. The blues are nice and rich. Whatever I've done in that color correction has been applied through here. It's a really neat way to work because it lets you take advantage of the tools in an application like Photoshop. As I said before, I'll work in a compositing package sometime with an even finer way of evaluating colors. Personally, I work in both the Foundry's Nuke and Ion Fusion because I like the color correction software in there. But wherever you'd like to work is fine. Simply get that image dialed in and record what you're doing, and then apply it to that color correction lookup table. Then bring it in and apply that grading and color correction to your scene. Water has always been a tough one to tackle in computer-generated art. It's not only a surface but a volume. And because it's clear, yet seems to be so many colors, it's difficult to make the surface really look right, especially in the limited resources in a game. In Unity then, we've got 2 available waters to use. Basic water that comes with Unity Free, and Pro water, which comes with Unity Pro. If you're using Unity Free, import in the basic water. For Pro users, make sure you import the Water Pro into the scene. I'll right-click in the Assets folder and choose Import Package and Water Pro. It comes with quite a lot of things. A couple of prefabs, water scripts for different lighting, source materials, gradients, and so on, and finally some custom shaders. I'll import the lot and see what I get once those come in. The water imported in, and I got a shader warning down below about a hidden screen space occlusion GLSL vertex shader. There's something going on in there it doesn't like in the syntax, but for now I'll ignore it, as it's just a warning, not a show-stopping error. In my standard assets, I have a Water Pro-only folder, and in there I've got prefabs for daylight and nighttime water. In there as well, in Water 4, I've got examples of simple and advanced water, and sources for each of them. In the sources then, we've got materials, objects, scripts, shaders, and textures. What happens in a lot of water is we'll start out with a fairly simple image, such as foam. Then we'll take it and start to add in things into those materials. We'll use foam, for example, and distort it with gradients or procedural textures. We'll then use other shaders that are custom defined to determine reflection and so on, and build up this shader to get the richness of water. I'm going to replace that blue plane I've been using as a stand-in, but first I'll turn off the terrain and turn off my building in the inspector. With those off, I can see a little more clearly what I'm doing. I'll take the water I've got now, this plane, and copy the Y height by pressing Ctrl-C after I select that field. Now I'll drag in the daylight water, dragging from the standard assets into the scene. It starts out as a disk, and what I'll do in here is delete that plane and then size out this water. I'll select my original plane, press delete, pick this new water, and paste in that Y height. It's a match, and now I haven't disturbed the water level in my scene. What we've got going when we look around at this is what looks like a real-time reflection. It's coupled with a surface distortion, as well as some shine and other factors going on. Here's what's happening in that shader. There's a scale of waves and an amount of distortion in the reflection. It's governed by a Fresnel ramp, which shows it as more reflective as we're tangent to it. Finally, there's a wave speed, which is procedural, and a reflective color in a Fresnel ramp as an image. There's also a reflective cube, a horizon, as well as internal reflections and refractions, and these are actually the real-time components. What's going on in here, if we click Select, is that it's a water reflection of a render texture, which is a special image we can put on a camera to render what the water is seeing. That's a Pro-only feature, and that's really what defines the Pro from the basic. Render to a texture what a camera is seeing is unique to Pro, and it's very useful for things like real-time reflection, but at the cost of extra draw calls and a performance hit. That's why we tend to limit down our reflections to cube maps wherever we can, and only use a reflection like this where it's really necessary. Now what I'll do is to scroll up in the water, and way up at the top is a scale. I'll bring out the scale in the X and Z for this water circle until it laps into the lake shore. I'll try 50 by 50 and turn back on the terrain to see what it looks like. Well, so far, I've made a puddle, so I definitely need to bring out that water further. I'll try a scale of 200 by 200, and now I'm getting my lake back. That may be too much, and I can go underneath and take a look, or turn on wireframe and see through the terrain. 200 by 200 is good, although maybe a little bit big. I'll make sure I pull this back as much as possible so it's not reflecting the underside. I'll try 150 by 150. And back here in a texture, just make sure it's catching the edge of the lake. We can continue to scale this down. 120 just seems to work, and this way I'm limiting down how much real-time reflection I'm doing. I'll slide it over just to make sure it catches all the edges, and I've got a lake in. It's got a good real-time reflection of my clouds and hopefully my buildings. Now in the water, I can custom tune the color of it. In each of these, it's got either a cube map for the color, or there's a gradient image we can adjust. When we pick this ocean gradient, for example, selecting the texture, it's actually a very slim gradient. Selecting it then, or adjusting and changing, will change the overall color of that part of the water. I'll turn back on my building and see how it looks, turning on the building in the inspector and pressing play. It takes a minute, but as we get outside, we can really see the surface of that water there. It's reflecting the sky and has a lot of motion to it. Before I adjust the color, because the color is strongly biased by whatever is reflecting, I'm going to adjust the wave speed. The lake is neat, but it's really got some flow to it, and I'd like it to be a little more tranquil. I'll select the water, and in that water, scrolling down, we have control over the wave speed. I'm going to pull these down here on all the factors and see what they do. I'll try an X of 6, a Y of 2.5, a Z of -5, and a W of -1. Hopefully this will pull it down more. What I'll also do in here is turn off my refraction. This water doesn't need to show the lake bed underneath. I don't really want to see through and see the brown. So in the refract layers, just like with lights, I'll drop down and choose nothing and save on some computing power. Because it's not refracting, essentially acting just as a reflective surface, in the game, I can see the water is definitely a bright blue, even tinted through the windows. I'll definitely need to go take down that diffuse color, pulling it back from that really screaming blue into almost a blue-black. However, the slower speed is working much better. It's got a rippling in the reflection and really gets the idea of a very still lake with just little water ripple from the wind. I like how it's looking, so once I go in and pull down the color in that gradient and bring it back in, I should really have much dimmer water. I'm okay with not seeing through. I don't really need to show how shallow the lake is, but more that it's just opaque, that this complex is perched on the water. We can keep adjusting things like speed, pulling it all the way down and even keying those parameters to simulate wind kicking up or a sudden flow or gust. It's up to you how you'd like to use it. If you can get by with a simple water, do so. Even if you're using the Pro version and a simple water looks good without doing a real-time reflection and gets you the idea of the water you want cheaper, use it. In an application like this, though, where I want the serenity of these buildings perched on the lake, the Pro water is the way to go, and the real-time reflection from the render to texture really helps sell it. Wind zones provide another subtle thing that reinforces the realism of a place. What a wind zone does is to take trees and other features in the landscape and blow them just a little bit. We can work in either spherical wind zones or directional ones, and they can affect the landscape in subtle ways. I'll choose Game Object, Create Other, and Wind Zone. And I'll make a wind zone. What we can see here is that it starts out with a transform in the middle, and we can just see some of the trees waving here in the wind. It's probably too much at the moment, as I'd like to keep it subtle. Depending on where we see these trees, they wave. It's really dependent on proximity. That is, far-off trees will be fairly still, but close ones will have wind. In the wind zone, then, we can define it as directional or spherical. A spherical wind zone is good for a local turbulence, whereas a directional will give us an overall gentle breeze through this forest. I'll leave mine as directional and just lower down the wind main to 0.2. I'll put in the tiniest bit of turbulence, maybe in the 0.2 range as well. And so there's just a little bit of wave in those trees. When we see it from the buildings, we'll get the idea of just the littlest bit of a breeze rippling through the leaves. It's just enough to bring those trees to life, and that's how we should think of it. We don't need to make gale force gusts. Really what we need to do is just add a little bit of motion in otherwise exactly static objects. I'll press play and see how it looks, and see if I can see it through the depth of field. It's definitely blurry on the shore, but I feel like I can see the leaves moving just a little bit, and that one close tree is moving. I'll jump outside and check it out. It looks good. There's just the littlest bit of movement in the trees, just enough to get the idea that there's something going on. And that's really all we need. Again, if you'd like to make a swirling tornado or giant gale force winds that rip trees apart, be my guest. You might want to look into a particle system as well. But for just the littlest bit of wind to make that landscape have some life, a wind zone is all you need. Audio is in many ways as big of a part of a game as the visual components. We expect to hear things with everything we do, and we expect to hear situational audio as we move around from place to place in a game. The different kinds of audio we'll hear in a game then are positional, or 3D, where we move into a defined zone and the sound increases or decreases depending on distance. We'll also hear audio that's continuous, things like backing music for an example. Finally, there's triggered audio, audio that goes with a particular animation, such as a door opening or lock turning. I've put some sound files in the assets folder, and I'll get them organized in their own sound folder, and then look at how sounds come in and what we can do with them. I'll start out by making a new folder in the assets, right-clicking and choosing Create and Folder. I've named this new folder Sounds, and I'll pick all of these sound files and move them into that Sounds folder. When audio comes in, we have options as to what to do with it. I'll select the interior tone for an example. We can see that it comes in natively as a wave, and we have a choice in here in the audio format to compress it to the Ogg Vorbis or leave it alone. Often we want to have positional or 3D sounds stay native, whereas long-tone sounds may work better compressed. It's up to you how you'd like to run it, and it also depends on the platform you're authoring for. Different mobile platforms may have different ways of dealing with the audio and compressing it accordingly. I'll leave this native as it's already fairly small. This is my interior room tone, and it's a 3D sound, meaning that I can make it positional and in a radius. We also can decide to load it into memory or to stream it from a disk if we're actually working from a disk. I'll preview this audio. It's about 1:30 worth of a deep bass and room tone. It's basically a room tone to fill the space plus a hum from the ventilation. We can tone it back, but it'll keep our interiors from being entirely quiet while still reinforcing the stillness of our gallery. Here's a lake tone with birds. This is the one that we're going to use occasionally when we step out onto the balcony. And again, I'll leave it native for now. It's the sound of water on a lake. Fairly still, but it still has some ambient water sound. And occasionally there's a bird or other noise in there. When we're dealing especially with an outdoor environment, we can think of the sound as a way to fill up that forest or jungle, for example. A lot of times, there's a lot of things we hear and we really never get to see, like birds or maybe other animals in the trees. We need to hear that there's some life out there in addition to the water, and there's a wind tone as well. And all of that together reinforces the idea of this being a very live place around us. In reality, there's actually no birds in the scene. It's just the audio getting the idea across. Finally, here's the door open. This is the one I've clipped down and really scaled back, so it's a very, very slight sound that will play when we trigger the door. It's just enough to show that that door is opening, and we'll get it to sync up, and it'll reinforce that something is going on here that the player has triggered. In Unity then, there's an audio listener component, and it's attached by default to the first-person controller and main camera. If you've seen a note down at the bottom of the screen occasionally saying There can only be one audio listener in the scene. Here's what it means. On the first-person controller, in that main camera object, there's an audio listener. And also on the main camera that's created by default in our scene, there's an audio listener. The audio listener doesn't have any properties. What it does is listen to what's going on and actually determines what we hear through our speakers or headphones. I'm going to take the audio listener off my main camera, leaving it just on the first-person controller. Now I've got exactly one audio listener here, and I'm ready to listen to the sounds I'm adding in. There's a number of ways we can put audio into our scene. They're all going to be an audio source, but we really need to think about when do we hear a sound. For this game, there's not really a backing music or overall track that rides over the entire game. If you do need one of those, put an empty game object into your scene and an audio source, and simply let it come on and not really have a fixed range to it. You'll have music throughout the game. What I'm going to do is similar, but I'm going to put a range on, and I'll use that interior room tone for each building, basically ranging it in the room in a large area so that when you're in the building, you do hear the vents, and it is a little bit positional, but definitely starts to fade out once you go outside. I'll begin by hiding my water and terrain so I can see my buildings and navigate around a little more easily. I'll hide the water and then the terrain object, and I'll also turn off the effects at the top of the scene view. Now get in some game objects. Choosing Game Object, Create Empty, and I'll name this one Building A Interior Sound. This will be my room tone, and I'll have one for buildings B and C as well. Now I'll attach an audio source to it, choosing Add Component, Audio, and Audio Source. As you can see, we've got a bunch of different components to add. Different filters, distortion, and echoes, and so on. For example, if we needed a reverb zone where our character has footsteps and we enter into a cave and we hear those footsteps reverberate, we could add a reverb zone to it. And that way, when we hear that audio, it'll be echoey, as if we're surrounded by rock. I'll pick my audio source, and then I'll get my audio clip in. I'll click on the Pick button for the audio clip and choose Interior Tone. I'll move this into Building A. I'll position it roughly in the middle. I'm going to let this range be most of the building, although occasionally we get into a quiet spot up by the doors. That's pretty good, and I can see in this, pressing F to focus in, that there's actually a sphere with this audio. What this determines is our minimum distance, and then there's a maximum distance which is 500 units out. Very, very big. What I'm going to do is size this down, using that icon and clicking and dragging to affect the minimum distance. I'll make it bigger, so we definitely hear when we're in this range. Then I'll pull max distance down. I'll try 50 to begin, and as we back out, we can see that other sphere. It's still very big. It's a giant piece of audio, and that'll overwhelm everything. I'll pull this back further. I'll try 15. And now that outer range, the limit on this audio, encompasses this building. There's a corner over here by the window that's definitely quiet, and the opposite corner by the brick wall will definitely have sound. Once we get out onto the balcony, that sound really starts to fade out, and this is a good place to be able to lap into the audio from outside. Now look at the volume. What happens here is that this sound is going to play on awake, meaning as soon as the game starts, play that sound. I'll leave that alone and check loop, and then scroll down to look at the 3D sound settings. The 3D sound means that as I get closer or farther from the center of that sound, it comes and goes with a Doppler effect, meaning it starts out high and gets low as we go away. Down in this graph where I've got my logarithmic roll-off set by default, I can see I've got volume keys for the sound. I'm going to take this all the way down at the end, so that by the time we exit the volume, it's exactly quiet. Right now what this means is that I would always hear this sound in the game, because the end key here still has a volume of about a third or so. I'll pull this down further, so that by the time we reach the end of that range, that sound is really gone. It's important to think about when do we hear the sound as well. I'll alter the handles, and so now when we're in that range, we definitely hear the sound, and as we get out to the outside, it fades to precisely 0. Sometimes we want sound to always be there in the scene. For example, let's say we're running around a place with generators. Even at the farthest reach of the level, we may hear a gentle hum from the generators, and it turns into a roar when we get close. For other places, we may want the sound to fall off exactly, so that when we're out on the balcony, we don't get the interior hum of the air conditioning. I'll play this and see how it sounds. Hopefully it'll be in the right range and I'll still hear the sound nicely enough inside. Here I am in the game, and I can definitely hear that audio, the hum of the vents. As I move around, the sound changes, getting into that corner, and the game gets very quiet. It really recedes off, so I'm in a really still place. As I come back over, it picks up again. It's working nicely. I may end up wanting to take the volume down, and I can do it here in this graph. Alternately, I've got an overall volume for that sound. I'll lower the overall volume just a bit, and then I'll look at the priority. Priority goes between 0 and 255, with 0 being the highest. I'm going to pull this sound down, so it's got a higher priority. This way, I'll always hear this hum, and it'll override other sounds that are occasional or triggered, such as doors. Now I can clone this around. I'll press Ctrl-D, duplicate it, and slide it over into the next building, naming this one Building B Interior Sound. Finally, I'll duplicate it into Building C, pressing Ctrl-D one more time and pulling it over. Once I've got these in, I'm ready to get my lake sounds in. They'll use the same kind of audio source with a much smaller range, so as we step out onto the balcony, I've got the sound of water around the base of the buildings. Triggered audio helps reinforce the immersion in our game environment. There's a mantra, especially in sound editing: see a sound, hear a sound. What that means is that we see something we expect to make a sound, and we should hear the sound that goes with it. What I've done so far is to make prefabs for my balcony sound birds and balcony sound water. I've put them at the corner of the buildings on the balconies, so that depending on where we are, we hear that water sound when we step outside. For an example, here's balcony sound birds, and this one's got a max distance on the curve of 9, and a minimum distance that's pretty small, so that we're always in the sound zone essentially when we step outside, and it fades out to 0 at the end of that range. It's the sound of the lake water and occasionally a bird. It plays on a wake and loops so that whenever we're on the balcony, we're going to run into this sound. Now get a sound on the doors. What I'm going to do is put the sound actually on the door trigger, so that when we trigger a door to open, we hear this door open sound. I've put a small JavaScript into the scripts folder in the assets folder. Here's what this script does. I'll select it and look in the inspector. Basically what it says is, I have an audio clip. On trigger enter, play that sound once. We can add this to other scripts, and it's very possible you may have quite a few bits of script running on one object. A sound, a check for a key, for example, or a tag, or something similar. But in this case, I'm just going to play this one sound when we step into that trigger. Here's how I'll make it work. I'll pick my door openers, and I've got 5 of them in here because I've run around and cloned the door animation so that every balcony has one operable door. I'll start out with door 11 and press F to focus in. There's my collider, and I'm going to put on this script and a sound source. I'll scroll down, roll up the Activate trigger, and choose Add Component, Audio, and Audio Source. In the audio clip then, pulling the preview window down in the material, I'll go and find that door open sound. It's the clip down one, not the full version door open. I'll let it play on a wake, and it's not a looping sound. I'll make its range just a little bit bigger, taking down that max distance to, we'll say 1.5, and leaving the min distance at 0.75. So it's a very small zone of audio we're in. I'll turn off play on a wake, and I'm ready to get this sound playing. Now what I'll do is add the script onto the box collider to play that sound. I'll drag my door open sound over, and then I can go choose that particular audio clip. When I run into the collider, it will trigger that sound, and the door will open as well. I'll play my game, run over to the door, trigger it to open, and I hear the door, and then I'm into the water. It's very common to get previews together of actions in a game and hand off to an audio person. For example, if you're working on a character, get a preview of that character moving, running, or whatever the actions are over to your audio person so they can start to get sound together to match that character. Then when you trigger that particular animation, trigger the sound as well. I'll add this same script and sound onto my other door opening box colliders. And that way, whenever I go up to a door, I hear that door open, the weather stripping scraping against the brick patio, for example, and it reinforces what I'm seeing. Audio effects can shape the audio in a game as much as simply putting it in. What they allow us to do is to take the audio and make it even more positional to certain materials and situations. I'll put a reverb zone in as an effect, and this way, when I put it on in the balcony between the two bridges, we'll get the idea of a little more concrete around or a little more material reflecting the sound. To do this, I'll choose Game Object, Create Other, and Audio Reverb Zone. We can also put a component on an empty game object as a reverb zone if you'd like, but I'll make the reverb zone as a standalone piece. Essentially what it does is it makes that object and puts the reverb zone component on, allowing me to choose how it reverberates. I'll move this one into position, roughly on the balcony, but not quite located with the others. I'll pull it up, maybe snapping it over, and then moving it off that corner. This reverberation zone has a min and max distance just like the other audio, and I'll pull back the min and max distance so it's really just in this situation. I'll take the min distance down to 5, and the max I'm going to try at 15 and see how it behaves. 15 might be a little bit big as it's almost getting into the other buildings, but I'll give it a shot. In the reverb preset then, we've got all kinds of different choices. Living rooms, concert halls, mountains and quarries, and even user, where if you'd like to get very specific in each little part of how the decay and reflection functions, you can. I'm going to choose a preset to begin. I'll pick mountains, so it's got that big open feel, but kind of adds to the audio here. Now I'll try it, pressing play and seeing if I can detect how that sounds in this situation. There's a definite difference. As I'm out here, I can really hear the bigness of this particular water sound versus the other is a little more localized. There's a little more volume to it, a little more echo. The water sound over here on this balcony is definitely different. Where we're on those bridges, there's a noticeable difference because of the reverb zone. Anything that's triggered in there will also reverberate. Say if we had footsteps on the character, for example. As a note on that, a lot of folks want to jump to putting footsteps on a character, and we tend to overemphasize them. One of the things to remember with sounds is that a lot of what we hear blends together, that we may not be able to hear each individual footstep, and it may get to be a little too much if we can really pick them out. We should just hear the change in footsteps in the white noise when we change surfaces. Say if we're going from pavement to gravel, there should be a little bit of crunching in the background, but it shouldn't be a giant sound in there. So get in and use your effects and position your sound around your scene, bringing the world to life situationally, depending on where your player is and depending on the surfaces they're near. Particle systems can add a tremendous amount of life and animation to a game. We can use them for anything from sparks to explosions to smoke, or even just drifting dust and particles in the air. Making them is pretty straightforward. We simply make a particle system and then start to adjust its parameters. And we have lots and lots of places to adjust. I'll make a particle system in my scene that's just little puffs of dust we see outside, maybe some seeds floating by from the cattails or something similar. I'll choose Game Object, Create Other, and Particle System. There is a package if you'd like. You can right-click and import that new package, and there are particles available. If you haven't brought it in, go ahead and bring that one in, because it's got lots of different presets for different kinds of particles, such as smoke and fire. I'm going to work with this default particle and configure it to be little white puffs. Particle systems only display in the scene view when they're selected. So I'll take my particle system and pull it to the side so I can see it more clearly, pressing F to focus in. I'll pull down my project window, and there's my default particles. They start out as just little white dots. What we've got with particles then is a playback speed, so we can speed it up or slow it down, and a time that it's running. If you need your particles in a script, for example, to key to a particular time, starting and stopping at certain times, you can monitor that time here in the particle effect. Over on the right side in the inspector then is our particle system. It starts out with a transform and then is a particle system object. And within that particle system object, we have control over birth, death, shape, velocity, and lots of control over the lifetime of the particle. Particle systems also come with their own unique material. There's a default particle material, and we have different particle materials available depending on what we're doing. These range from semi-transparent and additive for smoke to completely opaque or determined by an alpha channel in a texture for things like butterflies or other distinct particles. Finally, particles can have sub-emitters, multiple particle systems within one particle system. This way, for example, if you have a collision, it can spawn new and different particles. Now that we've got a particle system made, we can get in and start to customize it, changing the behavior, motion, and look of those particles. Once we've made our particle system, we have nearly infinite ways to customize it and make it look exactly like we want. What I'll do with these cattails is to put a new material on, cattail puffs, and then get them configured to stream little white puffs out across the lake from the edge. I'll start out by making a new material, clicking on the Materials folder, right-clicking, and creating a new material. I'll name this new material Cattail Puffs and then change the shader over to Particles. Once it's named, I'll drop down under the shaders and choose Particles and Additive Soft. There's different particle shaders available, and what we can see in here is that they're largely geared to be blending together. This is so that we can make particles that are very transparent and blend together and still maintain transparency, like smoke. We can also use things like Multiply for them to get very dark if we need, say, black smoke. And these also accommodate things like sparks, being totally self-illuminating. It's up to you which shader you'd like to use. And one shader may not work consistently for everything, so make sure you experiment with the different available shaders in here, trying it out to see which one works the best for your given situation. I'll leave mine as Additive Soft, and then I'll get a texture in, clicking on the sample sphere and choosing Select in the texture slot. I've made a new texture called Cattail Puff, drawn in Photoshop, and it's simply a white puff with a feathery edge. I'll close my Select texture, and I'm ready to see these particles with this white puff on them. I'll select my particles to start them playing, and then drag this Cattail Puff material right on. We can see the particles change. Alternately, we can scroll down and drag it right into the inspector here under the renderer. And there's our particle material, and we can change the shader if needed. Now what I'll do is get this placed and size out the emitter, and then look at the behavior of those particles. I'll turn back on my terrain, turning it on in the inspector, and then I'll also bring on the daylight water. For our particles, they start out coming from a point of a cone, and we can enlarge this out into nearly any size we'd like. What I'll worry about with particles is not necessarily how they look initially, but how they behave and where they come from. I may end up customizing this shader as I get more into it, but really what I'm after is that I've got what we think are lots of little white puffs coming from an area on the bank. I'll pick my particle system, pull it onto that bank edge, making sure I'm nestled in the grass, and then go down to the emission section. In the emission in our particles, we can choose a rate, and I'm going to lower this down and also use a curve to be able to affect where this goes. What we can see in particles then is a lot of places give us opportunities to either randomize or change subtly. I'll pick for my curve just an upswing, a slow in, and this just puffs off a few here and there as the particle system loops. It's looping up here in the particle system rollout with a duration of 5 seconds. So roughly every 5 seconds there's another puff of these particles. A nice, random-looking enough array, rather than a constant stream aiming at us. Now look at the particle shape. This shape actually concerns the emitter, not the particle shape itself. What we can do is we can tell these particles, please come from something. Are you coming from a mesh or emitting from a cone? Are you emitting from a box or from a volume? We can change the shape of the emitter, so instead of one plant giving off seeds, it's most of this side of the lake. I'll change that shape over to a box, and then enlarge out that box by clicking and dragging on the size. Here's my X size, getting nice and big, and then my Y size. If you notice here, I'm cranking out Y and it's going out to the side. That's because it's working on the global pivot. When we change over to local, we can see which direction corresponds to those axes listed in the shape section. I'll move it over, rotate it into place, and then customize how they behave. I'll push this particle emission back into the grass, so there's a range of cattails that spew seeds towards the building. Right now their velocity is just leading them straight up, and they're simply drifting and hitting lifespan and dying off. What we can see in here in the particle system section is that there's a start lifetime and a start speed. What I'll do is take that start speed down to 0 and then put in a force over lifetime. So the particles are born on that box within that volume and simply don't go anywhere. Now I'm going to get some force in. I'll open up the force over lifetime. What we can do is we can say to particles, you have a velocity over lifetime. Smoke may start out fast and then hang in a column in the sky. A force then lets us simulate wind. What I'll do is to kick up this force in the world coordinate system and then bring up the y-axis. I'll try a y of 0.25, so they just start to rise up a bit. I'll make sure to switch back over to the global coordinates so I can see which way I'm going, and then put in the z of, well, let's try 1.5. It looks nice, but it's the wrong direction, so I'll go negative with the z, -2, a little more strength. If you'd like, you can randomize this, dropping down the arrow and choosing random between two constants. I'll leave the y alone, but put the z at -2 and -2.65 because it sounds neat. Now I've got the particles randomly over their life, starting slow and beginning to drift across the lake, dying off before they hit the building, simulating those seeds. As they get closer, we sort of lose them, and only when they're far away can we really see a whole bunch of them together. I'll scroll back up to the top in the particle system and take the max particles down. I don't want to have that many, just a few there so it's not terribly noticeable. I'll pull the max particles down to 100, and we just have a few particles out there. What I'd also like to do is to pre-warm these particles. And what this lets us do is if we have the particles that need to ramp up or cycle in, it pre-warms them so that when we start out, the particle system is already in motion. It's up to you how much customization you'd like to do. You can get really quite crazy with it, getting in particles on texture sheets, cycling between multiple particles, changing color over life, speed over life, and even putting in animated wind. You can go as far as you'd like, and you can access most of the particle elements in scripting as well, so you can further hook into them. What I'll do is randomize that size and call my cattails good. I'll drop down in the start size and choose random between two constants. I'll set this start size then to start at 0.1 and go up to 0.5. So I get microscopic puffs and slightly bigger puffs, and that's it. And they start out, blow gently towards the buildings, and disappear before any of them collide with the building. On collision then, we have limited options for collision, although we can put in pretty decent collision effects. If we open up the collision section, we can see that once we turn it on, we can collide with planes in a transform, and we can add on multiple objects if we need. So for example, if I'd like to add the lake surface in, I can choose it here in the picker and type in dA for daylight water, and now the particles that'll hit that lake surface may bounce a little bit, simulating the skipping of puffs across the surface. Within that collision then, we can determine it as bouncy, dampening, killing it off, spawning, all kinds of fun things in there, and it's really up to you how far you'd like to go. I'll leave mine alone. I like the way it's looking, how they're born and sort of gently leave the cattails. I'll play the game and see how it looks. I'm in my scene. I don't really see much because I've got depth of field on, but going outside, and even picking the right door, I can just start to see maybe a puff or two. I see some little winking over there, but it's really hidden. I'm going to take a quick shortcut, jumping over the railings and going over to the other building. Yes, as a dev, you're allowed to do this. We may end up restricting our player by raising those colliders, but for now, this'll work. I can just see off in the distance my little puffs streaming towards me, as if there's cattails losing seeds. And in the depth of field, looking at the water, I kind of lose track of them, so they're working nicely. If you'd like to add in multiple particle systems, you can. You can also lower the amount of blur on the depth of field if you'd like to show off your cattail puffs. It's up to you how far you'd like to go, and you can really take these to a tremendous degree. So get in there and have fun making some particles. It's neat to see what kind of life you can add to your animation. Optimization for smooth play is something that should be in the forefront of the game designer's mind. Now, we should be making beautiful art and putting it around in a place that's new and exciting to play in, crafting an immersive environment. But at the same time, it has to work well. A beautiful game that's buggy and plays slow doesn't do anybody any good. Conversely, there's some games that are looking decent but play wonderfully and are immersive time and time again. We can do a lot on the back end to optimize how our game plays. And actually, we've been doing some of it already, making prefabs and cloning them around. This is a terrific one because it helps optimize how many objects we're actually using. We can also do a lot of optimization with things like limiting down lights to only hit certain layers and culling down other objects so that we're being very picky about exactly what interactions are taking place. When you're ready to optimize on a more global level what the camera sees, you can use occlusion culling. And what this does is to limit down how much we see if it's blocked by another object. I'll go into my scene and turn on the overdraw so we can get a good idea of what's going on. I'm here in building B, and I'm going to look out the windows towards the other buildings. I'll drop down where it says RGB and choose overdraw. What we can see here is that objects are drawn in a transparent red, and as more and more and more objects are overlaid, we get a brighter color, showing we are overdrawing more and more things. Now here's where this really starts to kick in. When we turn back on the water and turn on the terrain, we'll see a tremendous amount of overdrawing going on. Finally, with the effects back on, we'll even see how bright those get. What this means then is if we can limit down what the camera sees, we can get a smoother and faster gameplay. And so we'll use our occlusion culling. I'll choose Window and Occlusion Culling from the top menu. The idea in occlusion culling is we're going to mark things as static, anything that doesn't move, and then bake out zones of occlusion. I'll start out by marking things as static. I'll pick all of my solid walls, picking one, holding Shift, picking the last one, and over in the inspector, checking static. This way, these objects will be marked as not moving and can be culled down. I'll scroll up and look at the other pieces. The waiting Emmas move, so they may not cull well, but some of the other things will. The master building really only has some movement on the doors. French doors 4, 6, 11, 13, and 20. So I'm going to pick this master building and mark it as static and then come back and choose those objects. I'll change the children so they're all marked static. Then I'll open them up and go look at those French doors. Here in the gallery, I'll scroll down and there's my French doors. French doors 4, 6, 11, 13, and 20. And these 5 I will uncheck as being not static. I'm ready to try a bake. There might be some other objects I can catch, but I'll see how this behaves first. Actually, before I do, I'll look at the art. I know that the paintings don't move, so I can pick all of the Art P for paintings and check them as static as well. I'll change the children because that way it'll catch the painting in the frame, and I'll go back to the occlusion window. What this says is it's going to bake the things that are static, occluder and occludee, meaning it'll look at is it static on its own and is it static being blocked. I'll click Bake with nothing selected, and it'll take a minute and bake out that occlusion. My occlusion is baked, and I'm seeing that overdraw culled way down. Now I do have a message at the bottom. Some renderers use a transparent shader but are marked as occluder static. What this means is I need to go through that scene and look at all the glass objects and uncheck them as static. This way I can see through the glass properly. But I'll take a look at it and see how it plays. It definitely looks more optimized. There's not nearly as much of that giant white in the background where so many objects are clumping together. I'll switch back to RGB mode, and I'm here in my scene. I'll press play and see how it looks. Here in my scene, I'm getting some varied results. What I'm seeing is that in some places, things are winking in and out. And what this means is that my occlusion distance isn't quite set right. It's definitely helping. I'm watching my draw calls go way down, but I'm definitely seeing some flickering in the background and things coming and going. Inside, I can still knock over the art, and that's working nicely, and the inside of the building looks good. But I do need to fine-tune that occlusion. This may take some time, and it may take some time to go through and tag things think through the bake and think about how it's working. What we can look at in that occlusion then is in the bake section. How big are we dealing with? How big is the backface threshold? What's going on in terms of how far are we seeing? And how are our objects that are transparent reacting? What I should do is to go through this building, opening up that gallery and selecting those glass objects. For example, here's one of those outside metal screens. This one probably shouldn't be a static because we should be able to see through slightly. I can pick all of the screen objects at once and uncheck them. It'll take some judicious checking, but I can make sure that the occlusion is working correctly and not clipping out more of the surrounding and environment than it should. When you've got it ready, you can go back into the occlusion, clear off the initial bake, and bake it again. This is a terrific way to save draw calls because it says don't draw if we can't see it. So make sure you work with the occlusion culling and really cull down how many things are actually showing up in your view. Occlusion baking is a terrific way to save draw calls, occluding out what we really can't see. I've gone through my scene, untagging objects that have transparent shaders to make the occlusion work a little more smoothly. I've turned off the screen and the window glass as well as the railings from being static, and this way they occlude correctly, or rather we can see through them properly. Some buildings are more of a hit in draw calls than others, especially when they've got more windows on the outside. If we were doing a scene that was all concrete bunkers, for example, we'd get terrific occlusion culling, but at the price of, well, not too many windows. So it's a trade-off in here between the design of the game and the amount of culling we can do. Keep this in mind, that if we can limit down the view in any chance in our game design, we should, because it provides a way to optimize performance. We should be able to do it through design, not merely a brute force approach of just putting a wall up, but instead thoughtfully thinking about how far we can see in the game as a method of designing our way out of excessive draw calls. What we'll see is a lot of batching taking place now that we're dealing in occlusion culling and also once we're batching our prefabs. I'll choose Edit and Project Settings. Here in the project settings, we've got the different quality settings for our different components, such as physics and so on. I'll go under Player, and what we can see is when we scroll down here in the standalone under Other Settings, we have our static and dynamic batching. I'll turn on static batching. What this lets me do is take objects that are declared as prefabs and marked as static and batch them together to reduce draw calls. I'll take a look at it first, looking at the statistics in the game window before I turn on static batching. In the game window, I'll make sure that statistics are up, clicking on statistics and maxing on play. I'll press play and see how that looks. My game definitely looks better with the occlusion culling optimized. Right now I'm saving by batching at the most about 600 or so. It's still a lot of calls, but I can optimize it further. Now I'll turn on static batching. It'll take a minute, and then I'll have static batching in my game. I'll press play again, and we'll see how it looks. I'm still seeing about the same reduction, but it's definitely saving some draw calls the farther back I get and the more I see. Between the batching and the occlusion, we can save a lot of draw calls. This will change radically depending on where I go and what I see in here. We can see that I'm saving a lot of draw calls by batching when I'm dealing in like objects. So obviously this is situation specific. It depends on what we see and how many prefabs are instanced through here versus how many unique objects we're seeing. That number changes radically when we get outside. There's more and more unique things visible, and we can really see where batching takes a hit in some places. This really starts to max out the batching, where looking across the railings and the bridge here, for an example, we see a lot of the same kind of objects, and we're able to batch a lot of them together. The scene is really starting to come together, and through some careful attention in how we're building, we can really economize how it's playing. As we've seen throughout the course, testing, testing, and testing again is highly important in developing the game. There's some things we simply can't see until we get in and play. Once we're getting everything really together and we finally can see all of our parts coming in, we can get into our game window and really configure what we're seeing in the statistics and the aspect. I'll start off by configuring the game as I'd like to see it when it's played, dropping down under Free Aspect and choosing Standalone, for example. I had set this up as a standalone 1280 by 720, so I'll make sure when I play I actually see it at that resolution. I've had on statistics here in my game window as well, and what these let me do is see what's going on as this game plays. What's going on with the main thread in the renderer? How many draw calls am I dealing with? How many million tries do I have? And how many megabytes of texture? What's going on with our render textures? And that really decides how much we can spend on reflective surfaces. I can see in here what's happening with my screen and how much RAM I'm using and how much is available. I can also deal in how many possible shadow casters I have and visible skin meshes, the three, my EMMAs. It'll tell me how many animations I have and if anybody's networking. We can use these statistics, especially if we're dealing in a platform that has a limit, to really calibrate our game, deciding what to optimize and what absolutely has to stay in. I'll try playing again. And what I'll also do in here is show the scene and the game window side by side so I can see that occlusion culling. I'll take my game window and drag it down here next to the console. I'll pull this up a little bit so I can see my scene, and I'll make sure here in the scene window that I've got that occlusion on, choosing Window and Occlusion Culling. I'll press play and see how it looks in game. I can already see it looks different when it's constrained down to that 16 by 9. It went full screen, and that's because I left Maximize on Play checked. I'll stop temporarily and turn off Max on Play. This is where stuff gets neat. What I'm seeing in here is in the scene window, the occlusion culling is really working. As I move around, we can see things coming and going depending on what we're seeing. I'll move forward in the scene, bump into the column, and go out the doors, and we can definitely see things changing. It's working nicely, and I can really tell what's there and what's not. I can see that batching in action and watch those draw calls go down depending on how far I'm seeing. Now I'll turn back on Maximize on Play and take a look at it full screen. It's important to do this, to check out your game in the right size. You may be calibrating for a certain aspect or certain size, and you need to make sure that you're using the frame, much as a cinematographer would, to frame the action. Now you may say, wait a sec, it's a navigable place, we can go anywhere. But how we see that frame, the size of it, affects how we perceive our space. If it's taller, more square, wider, whatever it is, we get a different feel as we see it. So we need to consider that as part of testing our play. And we can also look at our statistics, seeing how our draw calls are culled down depending on how big that screen is. Now that I've really seen my occlusion culling working, and I can see really how does it look within that frame, I can see if there's anywhere else to optimize this game. Are there any other textures I can reduce in size now that I really see them at the right res? Are there any other objects maybe I should replace with a prefab, again so I can batch further? Is there anything else in here I can do to reduce down what lights are seeing, or if there's anywhere else where I can lessen a shadow quality and make it just a little bit easier to draw? Using those statistics is really vital, and it takes some time to go through and troubleshoot and optimize as much as possible. Some of it you should do along the way, carefully constructing your prefabs, textures, and animations, making sure that in as many places as possible you're using a modular approach to building the game. But sometimes you have to get it all together, play it, and go back and optimize using those statistics to learn what's going on. When we're getting close to completing our game, we can actually make a build of that game. And a build then is a calculation of everything in the game to produce a standalone executable. This may be a standalone app for a phone or a standalone for web or PC. You should know your platform going in. It shouldn't come as a surprise that suddenly you're authoring for iOS, for an example. But you can always go and change if you need, and Unity has a lot of great things along the way to facilitate developing for multiple platforms. I'll produce a development build to start, and this will let me pull up a debugger and a profiler to watch out for any either warnings or show-stopping errors. I'll choose File and Build and Run. In Build and Run then, I can choose a platform I'm building towards. iOS, Android, BlackBerry, and so on. I'm going to build mine for PC, Mac, and Linux, as that's where I've directed all of my textures to go to, and I haven't used any overrides for anything in here. I'll check Development Build, and then I'll check Auto Connect Profiler and Script Debugging. Now when I go to build this, it'll pull up a profiler, which is a pro version only, and show me where my resources are going. It'll also help me debug any scripts along the way, flagging any errors in my code so I can run the game correctly. In our architecture then, we can specify a target platform. In this case, because I'm working on a PC, I can't develop for Mac OS. If you're working on a Mac, you can develop for Mac OS, and the same with iPhone. I'm going to build for the x86 architecture, but we do have an option in here to do x86 64 if we'd like. I'll press Build and Run, and what it's going to do is take the current player settings, build the game, and then open it up running in the Unity player. When I click Build and Run, it wants to make an exe, an executable for Windows. I'll name this for a testing build, so in case I see it in my directory later, I can delete it because it's just a working build of the game. I'll name it Modernista Test, and I'll make a new folder that this is built into. It'll go into a folder I've called Debug Builds, and this way I can be careful about what version I'm actually putting out there for consumption. I'll click Save, and Unity will take a minute, compile the scripts, and build the game. The build came up and opened up the profiler. What I can see in here is that I haven't specified a splash screen yet, and it's at the default quality of good. My screen resolution came across, and it's going to play windowed. I can also see in the Input tab that it's just the standard WASD inputs. That is, the standard keys here for jumping around, firing, moving, and so on. We can always get in and change if we need, and we can lock these if we'd like. Back here in the graphics, I'll try the graphics quality at Fantastic, the most it can go, and see how it looks. I'll press play, and I'll watch that debugger as well. With my build open, it looks really good. I can see in here that the anti-aliasing I've spec'd looks fantastic. I've got a development build going, and it looks really nice. All the work I put into the lighting and the shading is really coming across well. I'll move forward, knock over my sculpture, and go out the doors. Finally, bumbling around like a player, I found the right door to get out. I can hear the water and see the water in front of me. The shallow depth helps me focus on the railing, and that background is blurred. Looking down, I can see the detail on the railing and a little bit of that cube map moving in the metal. I knocked over the painting. I can see some areas I'd like to fix, like the clipping plane and the collision on that player collider. I went into the painting a little bit. That's an easy fix though. I can go back in and fix the size of that so that as I go forward I can't quite pass through objects. The ambient occlusion looks good. There's some minor issues with the bottom of the wall texture, but I can take care of that quickly in some mapping. The screens are holding up well. Not too much of a moire pattern, and the lighting looks really good in the space. I'll close that build, and what I can see here in the profiler is my usage and my frame rate. I'm hitting a frame rate roughly of 30 frames per second, and getting reasonably close occasionally and a little bit under. This definitely tells me I've got places where I can optimize, where I really need to streamline what it is we're seeing. It's neat though, because I can see where my rendering and draw calls are depending on how much I've seen, that is, how far away I'm looking. I can also see in here that I'm probably taking a big hit in the draw calls from those image effects. And so if there's any way to optimize them down, maybe going through and color balancing out all the different colors, I should, and see if there's any of those I can take off. I should also see if there's any optimization I can do along the way in terms of either geometry or textures. And this provides a really nice graph of where are we using that processing power. So far, it looks like my scripts are working. There weren't any errors popping up, although this is not terribly intensive on the scripting. As you get farther and farther into your scripting, you'll find more and more places where that debugger is really helpful, flagging areas where scripts are in conflict, either in their order in running or in the syntax, and you can go in and find and fix those before you publish your game. So you make a development build, look at the profiler, look at the script, and really read what those consoles and debuggers and graphs are showing you. because it'll help you streamline your game so you can play as smoothly as possible. The final step in making a game here in Unity is to actually build the game. So far, we've got in models, textures, lights, particles, animation, interaction, scripts, characters, motion, all kinds of stuff. And we're ready to finally build the game as a standalone. In this case, we're working out to a standalone EXE for a PC. Alternately, you may be building out to iOS, Android, or something similar. Along the way, hopefully you've configured everything for that specific platform, introducing overrides if necessary, and always thinking about your destination so that you can calibrate your game appropriately. I'll take care of one last detail here before I actually do a build, and that's to get an icon and a splash screen in place. I've brought in those two files, plus the working sources from Adobe Illustrator. They're in the Textures folder in the Assets, and I'll take a quick look at them before I put them in. The M icon is actually what will go on the EXE. M for Modernista, on a modern orange. And this is actually what will show up on both the EXE and a shortcut on the desktop, for example. I'm going to leave it alone, sized at 128 square, a power of 2, and marked as a texture. The splash screen is what goes on the initial Unity configuration screen, when you're choosing the play size and mode, beautiful, fantastic, and so on. For this, because it's an odd size, we need to configure it. I'll drop down here under Texture and choose Advanced. This image is 432 by 163, which is definitely an odd size but fits perfectly in that UI. Remember, 432 by 163. I'll change the non-power of 2 from nearest over to none, and this way it doesn't rescale it. I'll uncheck Generate Bitmaps, and I'll leave that max size alone. I'll change from Automatic Compress to Automatic True Color, and click Apply. Now it's regarding it correctly, leaving it at 432 by 163, True Color, and it's ready to bring into the player settings. I'll go under Edit and Project Settings, Player. And in the player settings, there's my splash image and my default icon. I'll click Select in the texture slot for default icon, and I'll scroll down and choose my M icon. Now I'll select the texture for the splash image, clicking on Splash Image, scrolling down, and choosing M Splash Screen. It's ready to build. If there's any tweaks along the way, we can always play it, test it, and rebuild it. I'll choose File and Build Settings. In the Build Settings, I'm going to make sure that all the development pieces are off, turning on Development Build if I need to, and unchecking the Profiler and Debugging. I'm authoring in this case for a Windows platform using the x86 architecture. Depending on where you're running, you may be authoring for a different target platform. For example, if you're using a Mac, you may choose macOS. Linux users might choose Linux. You can also test on different platforms than what you're authoring on to make sure your game is compatible all around. Once it's all in, I'll click Build and Run. I'll put this into my Debug Builds folder, naming it instead of Modernista Test, Modernista. It'll make an EXE with that icon I've chosen, and then run my game. I'll click Save, and Unity will start to make the build. The game starts out, and there's my configuration dialog. My banner showed up, 432 by 163, and it fits in perfectly. It's now my game with my logo. My screen resolution is as I've designed, 1280 by 720 in a window, and the default graphics quality is fantastic as I've set it. I haven't done anything with the input yet, so it's the default WASD. I'll leave that alone and get in and play the game. I started out where I had left my character, so I may want to move back to that spawn point and build again. But for now, it's neat to run around it. My blurs are all working, my water is sparkling, and I can see all of the things I put in all their rich, subtle detail. I'll move forward, knock over some sculpture, because I can, dash around the wall, knock over that painting, watch the cars fall, and head out the door. My door opens, and there's my sound zone with birds. It's working terrifically, and I can see into the other building across the way. I'll go across the bridge, hear the sounds fade out, and into the other spaces. There's always room for testing and tweaking, but I really like the way it's working. And there off in the distance are my cattail puffs, just puffing and disappearing before they actually reach me. There's the trigger on the door, and I'm into the third gallery space, ready to get in there and just bumped my head on that mobile. The mobile's watching me as I try to find my way out. Everything in my gallery is working as it's supposed to, and it looks terrific. That final push in the anti-aliasing is really working nice, and I can see all the richness and subtlety I've put in the detail, textures, and lighting. It's a lot of fun to make a game, almost as much fun as playing them, and I hope you had as much fun learning how to make it as I did teaching it. There's so many different things to get into here, and so many different possibilities. We can only cover a small bit of it in this course, but I hope you're excited about getting in there and delving in to really explore the power of Unity. Thanks for watching the Unity 4.3 Essential Training, and I hope you had as much fun making the game as I did teaching. If you'd like to go further, I'd highly recommend the C# Essential Training with Joe Marini. It's a great way to get immersed in code and really bring functionality to your game. I'd also like to recommend Animating Characters with Mecanim in Unity 3D by Sue Blackman. It's an in-depth look at the Mecanim character animation system for bringing life and multiple animations to characters and objects in your game. Finally, I'd like to recommend Materials and Lighting in Unity. It's a course I developed on material and light and goes in-depth into the different shaders and possibilities in Unity to make your game look simply amazing. Thanks again for watching Unity 4.3 Essential Training. Now get out there and make some really fun games in Unity.